Seeing if we can push. Testing to make sure this works. Sounds right? That's what I sound like? I hate that. So we'll get started here in about 1 minute. So if I can ask folks to quickly take a seat, we'll get our first presenter up here and kick off. Okay.
I'm gonna need you. Somebody needs to kind of go for hours.
Oh, yeah. Make sure we do 50 minutes. That's what everybody's, and we'll amend the lunch hour and kind of.
10:05. You mean 10:05? Yeah.
That'll be the goal. Yep.
We'll just maybe skip the first break.
We'll just kind of tighten things up a little bit. 2 or 3 of these in a row.
I don't have to
tighten.
rush.
Okay, well, welcome to Eaton's 2023 Engineering Education Seminar. Thank you all for coming today and taking time out of your busy schedules to spend it with us. What we've done here is brought together a bunch of subject matter experts on industry trends and topics. The goal of this is really just to spark conversation, just to get ideas generated and give you a source and make sure you've got avenues and tools and assets to reach out to as consultants, as engineering firms, at kind of the tip of the spear with our customers, with our owners, with our architects out in the field. So some quick introductions here. We've got Glenn Hanley. He's one of our application engineers. We've got Kevin Davis, who is our other application engineer. They are your two go-to people. So if you don't know them and know them well, please make sure and tap them on the shoulder. Guys, right back to you too. If you don't know everybody's name at the end of the day, make sure and punch them in the arm. So. Again, I welcome everybody. If you do have any ideas or anything that sparked a little extra conversation, by all means, we can do sidebar parking lot conversations out in the back. We also have a few Eaton booths outside that you saw as you were coming in. Really, those are, again, just some different products that we've got that are a little bit new, a little bit more innovative, that we want to, again, make sure you're exposed to as you're touching base with your owners and kind of the market out there to start with. So first things, or I guess one thing would be remiss, if there is any reason to leave, if we have any sort of emergency, fire, you name it, the same way we came in is the same way we're going to leave. So we've got the two exits at the back, head right outside there. That'll be kind of our path out. And then my only message I've got for the group today is Eaton, like many of our other competitors out there, whether it be Schneider or ABB or Siemens or anybody else, are working through some very extraordinary times with material availability, with scheduling. As you all are perfectly aware of, we're not immune to this. We're not special in this. We get told quite often. Everybody's kind of going through a little bit of this. My ask of you is you guys and gals are so much closer to the owners, so much closer to the general contractors, so much closer to even the teams that are working on the financing aspects of these projects, is make sure that they're aware of that and taking that into consideration on the front end. It will make their projects hopefully go so much better, smoother, less frustration, sometimes less emotion on the front end, because the way that we did things 3 and 5 and 10 years ago are not the way that we're doing them today. I hope to, and Eaton has lots of reasons with major capital expenditures, new plants going into North America over the past couple of years here, that our capacity is going to continue to grow. So we should see some improvement there. But again, as you're talking to your owners, as you're talking to those general contractors and architects, again, just kind of remind them that these are some special times that we're still working through. We are getting better every single month, every single quarter. With record outputs, more material is going out. So again, with that, I thank you so much for making time to do this. This is meant to be somewhat interactive, so if you've got a question, be sure and raise your hand. I'm sure there's 1 or 2 or 10 other folks that are thinking it too. And with that, I'll kick it over to our first speaker, Tom Dimitrovich.
Thank you. There you go. Good morning. Yeah.
Okay, and one last thing, I always forget something. What we're going to be doing is passing down these notebooks during each session. We're going to start them on one end and literally just work them down to the other. So if you're down at the end, you're going to be our collection helpers over there. They're just going to end up over there. The next session, next speaker that comes in, we're going to start it on one side with a new sheet and just run it over there. That just makes sure that we keep the accountability so that we can generate the documentation that you may need for any PDH hours or any continuing education stuff. So if you see it coming your way, they've already got it set up for you, but should be good.
Perfect.
Thanks again.
Thank you. I thought I was getting the hook right off the bat. I mean, I've gotten hooks before, but never that fast. All right, so we ready? All right. How many IAEI members do we have in the audience? Got 2. I want to tell you about a great organization before I get started, International Association of Electrical Inspectors. As engineers, as design engineers, we need to know our inspectors, our contractors, et cetera. Great organization to get educated on things like what we're going to talk about today. So I just wanted to let you know, IAEI, if you want to learn more about that organization, let me know. All right, so we're going to talk 2023 code changes. My name is Thomas Dimitrovich. I'm Director of Codes and Standards for Eaton. I have global responsibilities for Eaton codes and standards, and I try to help our product lines understand the latest and greatest when it comes to the National Electrical Code and standards for product standards, and I work to build relationships to try to help people understand the proper use and application of our products. I sit on Code Making Panel 2 and 10. So panel 2 covers Article 210, Article 220, 210's branch circuits, 220's load calculations. Panel 10 is your overcurrent panel, code making panel, which is your Article 240, 235, 215, 225, 242, I think it is for surge, and some stuff in the annex and definitions. So I don't speak on behalf of NFPA. I don't speak on behalf of anybody other than this guy, because it starts up here, it comes out here, but I really mean it from the heart. So sometimes I'll say things I probably shouldn't say, but I will. In any case, I'll give you a little bit of the background on some of the code changes that you're going to see in the 2023 code cycle. There are code-wide changes. There are changes in the NEC that originate from things like task groups. Right now, we've got various task groups working on 2026 National Electrical Code. And out of those task groups, we get public inputs that have an impact code-wide. You'll see new articles, you'll see deleted articles, you'll see technical subjects like we're going to talk medium voltage changes and reorganization of the NEC all occurs because task groups get together and try to solve problems, right? Either code interpretation, ease of use of the code. The other code-wide changes that you'll see originate from what we call the style manual. The style manual tells us how the code book is organized, how to read the code book, how to apply the code book. The style manual tells you what is permitted from a language perspective, what's not permitted. We try to get rid of ambiguous and vague language, right? And the style manual helps drive that. So one of the changes that the style manual drove was we moved all terms and their definitions to the front of the book in Article 100. So if you're used to going into dot 2, which was the designated area for definitions, for terms, it's now all in Article 100. So Article 100 has all of your terms, all your definitions, and there are over 800 of those little puppies in there. So finding your term may be a little difficult, but they tried to do things for ease of use and organizing them, and organizing all the terms. So we had multiple definitions, multiple terms, same term, multiple definitions. And they tried to consolidate that, and where they couldn't, they left them both there. So that's all there is to it. And I will say that the way it's organized, you're going to look for, in some cases, a term that only applies to an article in the NEC will tell you in brackets, in parens, where they call that. They'll tell you the code making, the article, like for example, if you see a term in there for something related to marinas, you might see 555 in parens. That tells you that that term only applies to Article 555. Okay, don't apply it anywhere else. It'll also tell you if it's extracted text, if you see brackets, like little square brackets, and they'll tell you, like, for example, for talking marinas, 303, and then it'll be a comma, and they say 3.3.3. That'll be NFPA 303, section 3.3.3. That language, when it's in brackets like that throughout the code, is extracted text. That means it's the exact same definition that's in that document. And if you're looking that term up, and you see that extracted text, and you see another NFPA document, I would ask you to go look at that document, because if you're reading something and trying to apply the code in an application where you're seeing extracted text from another document, there's a very good chance that the requirements in that other document apply to whatever it is that you're working on. So be mindful of that. Now, when we moved everything from dot 2 to Article 100, we opened up dot 2s across many articles in the NEC that used it for definitions. So what we did there was we basically allocated dot 2 to reconditioned equipment. So if you're familiar with the changes over the last couple cycles in the NEC, there was a focus on reconditioned equipment, on what you can and cannot recondition, and then also, if you do recondition it, what are some of the rules that you need to follow? And it's all, in my opinion, it's all about transparency. If you recondition a product, we want you to put your name on it because you own it. Not whoever, it's not HP anymore. If you take that computer apart and you put it all back together again, yeah, you have the shell of an HP computer, but it's no longer HP, it's now yours, right? Same thing with electrical distribution equipment. If you recondition a switchgear, a power circuit breaker, whatever it is, we want your name on it, and you've got to remove the UL label or make it unreadable. That was a change that we made in this cycle for the motor guys out there who recondition or rewind motors all the time. Their UL, their label for the listing mark is on the motor nameplate. They did not want to remove the motor nameplate, so we just made it so you had to obliterate it and you can leave the nameplate on there. So, but be mindful that every section that pretty much, so I highlighted a few that didn't follow the rules. And the reason they didn't, and it's not a rule, it's sort of an unwritten thing. Right, when we did the .2s, it was sort of like a gentleman's agreement where you say, okay guys and gals, we're going to just use the .2 for a reconditioned. And some panels did it, some panels did not. And the reason is because if they did, it would probably renumber the entire article, and they didn't want to go that far. But those are all of your sections. So if you're looking in 430 for motors, 422 should be up there too. It's not actually for wiring devices, but you got Article 700 for your transfer switches. In there will either tell you you can or cannot recondition a product. All right, medium, new and deleted, so medium voltage was another focus from the, there was a medium voltage task group. A gentleman by the name of Robert Osborne chaired that with Underwriters Laboratories. And the group was looking at the medium voltage requirements. The challenge, the problem that we have is there are many medium voltage applications that are governed by the NEC. When do I know it's governed by the NEC? How about this? When do I know it's not governed by the NEC? When it's under control of the utilities, right, correct. But there are a lot of medium voltage applications that are owned by the owner. And unfortunately, there's a lot of people who don't follow the NEC. And then some of the comments you'll get is they'll say, well, the NEC doesn't have requirements. Well, they're in there. So what the task group did was they said, in this first draft, in this first edition for the medium voltage changes, and there's more to come, they simply moved all of the medium voltage requirements into their own articles. So you'll see some articles that have been deleted. You'll see some new articles. These new articles, 235, began in panel 2. We moved all of article, so in 210, we had like 2 sections that were addressing medium voltage applications. But in reality, everything in 210 for branch circuits applies to medium voltage applications. So we moved a lot of the 210 requirements into 235. And then panel 10 did the same thing for 230 for services, 225 for outdoor feeders and outdoor branch circuits. So you got 210, 215 for feeders in there. You have 225 and 230 all in Article 235. Branch circuits, feeders, services over 1,000 volts. So that's your medium voltage home. And quite frankly, if you are worried about what are the changes, technical changes didn't occur this cycle. All they did was move. They couldn't make technical changes because it was in the second draft. And it was just, you can't introduce new material. 245 is your overcurrent protection. So they took the contents of 240 that applied to medium voltage and moved it to 245. 305 for general requirements for wiring methods, 315, 395, 495. So you might see a trend, and the original thought was, hey, we'll just end all of the medium voltage articles with a 5, and that'll be an indicator that it's medium voltage. Well, 215 sort of put a kibosh on that, but in any case, for the most part, if it ends in a 5, there's a good chance it's medium voltage requirements. Now, when you see deleted articles, if you're familiar with some of these articles and you say, wow, the requirements are gone, Not necessarily. In many cases, they simply moved them, the requirements, into another article, or they just said it wasn't applicable and they just deleted it, like in the low voltage DC, but below 50 volts, they didn't see a need for it. But on most of the case, like the 311, they moved it to 315, 399 moved it to 395, and 490, they moved it to 495. And again, if I would hazard a guess, the technical changes in those articles are minimal, if any, because the primary focus was to just line up the medium voltage articles in the code. So it's getting some love. The medium voltage applications, we're recognizing there are some technical issues with the requirements. Medium voltage equipment, you don't do 1.25 times the load. It's not 80% rated equipment, it's 100% rated equipment. Yet the NEC sort of implied that it was 80%. So we're trying to add that clarity in the code. How many people here deal with medium voltage applications? All right, my ask is for you all to take a look at the medium voltage requirements in the NEC. If you see things that don't make sense, your familiarity with the NESC that deals with utilities is probably better than some of these individuals who are even on the code panel. So my ask would be, take a look at those requirements. If you see something that doesn't look right, doesn't smell right, it may not be right, if you can bring it to our attention, I'd really appreciate that. And we can help you either formulate a public input, or if you say, look, I don't want to do a public input, but this just isn't right, then let me know and we'll try to fix that in the next cycle. Public inputs aren't due until, I think it's August or September of this year, so we're working on 2026. These are new articles so these are 355 instrumentation cable tray. You've got drilling rig cable, type P, insulated bus pipe. You got flexible bus systems. Oh, you can't forget about cannabis, right? We all have to, I'm not sure if, there's a lot of there's more legal grow facilities going in the United States these days. Cables for power limited circuits. Power limited in class 4, there's a new technology on the market that drove this. There's a company out of California that is doing what they call pulsed DC power. They're trying to use more power over small conductors, right? And they want to make it a Chapter 8 wiring method because Chapter 8 is not a part of, it's a part of the code book, but it doesn't pull in chapters 1 through 7. So, and it's not inspected typically. So they're putting a lot of power over smaller conductors through this, what they call a pulsed DC. And they were listing it to data and communications standards. So UL got a whiff of that, and they said, and the industry got a whiff of this, and they said, we really need to formalize this, because if it is a good technology coming to the market, we don't want a failure. We don't want to give something a bad flavor if it is a good solution. So we basically UL created a standard for it. They did some research, and we created some requirements and new definitions in the NEC. So you'll see, take a look at 726 for pulsed power. I think the focus of that technology is around powering LED lights, because it's DC. I mean, if you think about it, everything we have that's plugged in got to go through a converter, right? And there's a lot of work going on low voltage DC distribution in the code and in standards. So it's another thing to keep your eye on the ball with regard to application of power distributions and how it may change in the future. All right, then Article 510 was deleted. They said, we didn't need it. And 720 for less than 50 volts, they said, it's already covered elsewhere. So some of the requirements in these articles were covered elsewhere. Article 512 is your cannabis. Can't forget about that. And these are all the medium voltage applications, which I just went over. I'm not going to go over it again. We already talked about medium voltage, 235, et cetera. So all of that. This is what you'll see now. So now Article 210, since we stripped out medium voltage, we had to change the scope of each of the articles. So now Article 210 just says not over 1,000 volts AC or 1,500 volts DC nominal. If you want the requirements for over 1,000 volts AC and 1,500 volts DC, then you go to where? 235. And why? And so the medium voltage, we established two lines in the sand, 1,000 amps or 1,000 volts for AC and 1,500 volts for DC. That was driven by IEEE standards and international standards. They established that 1,500 volts for DC as that line in the sand for medium voltage. And what drove the 1,000 volts up over the last couple cycles was your photovoltaic applications, PV. They got rid of the transformer in your inverters, lightened them up. They removed the losses. But when you take a transformer out of the picture and you need voltage, they had to raise the voltages in those applications. So, and the voltages in PV are still going up and up. I don't think they've settled out yet. There's your 235. So part 1, general, branch circuits, feeders, outside branch circuits and feeders, and then part 5 is services. So again, when you look at this article, it's existing language. And in fact, if you look at branch circuits, I chuckled a little bit because we simply moved stuff out of 210. So you'll see things in there about branch circuits for appliances, medium voltage appliances, which I thought was, boy, that's kind of ridiculous. But we couldn't make any technical changes. So we're going to clean it up. We're going to clean it up this next cycle. All right, surge. We all love surge. Power quality is important, right? So last cycle, what did we do with surge? We put a mandate. So surge has seen a lot of changes over the years. We had requirements in Article 700, 708 around special conditions for surge protection. Article 700, any panel board or switchboard in a life safety system, an emergency system, has to have surge installed. In Article 708, I think that's the first place it was put in, because I was trying to find a justification, and I couldn't find a justification for surge in Article 708 systems, at least substantiation for the public input, because it was put in when Article 708 was created itself. So, and that happened because of 911. That was for your national security reasons. So Article 708 was, I would argue, the first location, and then we did 700. But then if you look at all these different special equipment, but from elevator control panels and other applications, industrial control panels, you're seeing more and more surge requirements. The big change that happened last cycle was dwelling units. We put it in for dwelling unit service entrance. And then this cycle, what we had to clean up, there was a realization on panel 10 that sometimes, we had it in Article 230 for services, for dwelling units. But then we said, well, wait a second, what happens if the service is out at the road? Because in many cases, there's a service is out at the road, and then we have what? An outside feeder that comes to the structure. We don't want surge out at the road. We want surge on the structure, right? And then we said, well, we can't make it required both locations. So we modified and we added some language in 215 and in 225 that recognize those applications. And I guess the bottom line with surge from an industrial and a commercial, regardless application, you want those lead lengths very, very short. And you want the surge as close to the structure as your distribution as possible. And you can't forget that surges come from out there, but they can also be generated from inside. So you may need surge at various levels. I believe IEEE tells you to have multiple levels of surge protection, from the surge strip that you might have on the appliance to knock it down that final level, all the ways up through the system. And I know Dan Carnevale has a great demonstration as part of our experience center, where he demonstrates the lead length and the impact of every inch of lead length that you add between the surge device and the bus makes a big difference in let through, right? I can sell you the product, but if you put it 10 feet away, I got the money and you don't have no value. So you want to make sure we apply surge products correctly. And I tried to get language in the code that said, a minimum lead length, but I failed there. I got a recognition that lead length matters in regard to surge installations, but I did not achieve a maximum length of conductor for connecting the surge. All right, so we expanded surge and again, 215, 225, and 230, and we went beyond dwelling units to other commercial type of facilities. We went to dormitory units, guest rooms and guest suites of hotels and motels, and then nursing homes and limited care facilities used exclusively as patient sleeping rooms. Anybody do healthcare in the room? All right, so in the healthcare applications, you might say, some healthcare people might say, wait a second, you're stepping on the toes of Article 517 with regard to nursing homes and limited care facilities. But if you look at the exceptions, there is a section in Article 517 that says the branch circuit requirements are not covered in 517 for those applications. So that language is exactly extracted basic text from Article 517, that specific section. And we already talked about the 215 and 225, and we reorganized 230. So here's how we did it. 230-67. You have surge protective device requirements, you have the location, you have the type, the replacement. So we addressed that if you update a service, and say it was from the 50s, we want you to put surge in for the new service. Also the feeders, et cetera. And the type, replacement, and the ratings. One of the big complaints that we got was that you put surge requirements in, but you didn't tell me what the rating needs to be, right? Because you can buy a surge device and it may not produce and do what you think it's going to do just because of how it's constructed and what some of the parameters are. So, dwelling units, there's the 4 areas that we added. And then this was in 230, so we said, and we said if you, in 215 or 225, we said if you have it at the location, at the structure, then you don't need to put it in 230.6, meet 230.67. We want it to be an integral part of the service equipment or immediately adjacent thereto. And we had there's the exception if it's located at each next level distribution. So basically I could put surge there in an application, or if I put it at all the next level distribution, then I don't need it there, right? And that's like good for your like multi-family dwelling units and your larger installations. But now the other application that we saw was in some cases off of that meter stack, they were coming off with a breaker and going to an HVAC unit outside. And they said, well, do I need to have it on that HVAC unit, or still do I need to put it in my service equipment? If you feed anything, it says in the code, all downstream equipment, whether it be an HVAC unit or panel boards or whatever you're feeding from that structure, from that service, you have to have it at all the locations downstream. So if you have something on the outside and you're taking a breaker off of that to feed, like say an HVAC unit, you either have to have surge in that service or down there at the HVAC unit to be complete and meet the code. Type 1 or Type 2, you can put a Type 1 on the line side of the service over current device or on the load side of the service over current device. You can only put a Type 2 on the load side of the service over current device. So this just gives you an idea, this just tells you what is applicable. You're only going to be using a Type 1 or a Type 2. The rest of the other types are used like for industrial control panels and things like that. There's your replacement. If you replace it, then you have to adhere to the requirements of 230. And we put this same language in 215 and 225 as well. And I have a feeling that in next cycle, we're going to clean up the rest of the surge locations as well. So this is just a taste of what's going to probably come for industrial control panels and Article 700 systems, et cetera. It's just a flavor for what you're probably going to see over there. Because here's what happens. We make a change in Chapter 2 and one cycle, and then someone scratches their head and says, well, wait a second. I have a good friend of mine who'll say, Thomas, how does that little electron know that it's in a dwelling unit and it's not in an Article 700 system? And he's absolutely right. So then all of a sudden you get public inputs, and then we move those requirements. So I'm sure you're going to see probably especially things around ratings as well, for that's like sort of the performance. So the rating that we put, and this was relatively controversial actually. It was appealed. There was arguments at the floor of the annual meeting. The nominal discharge current rating of not less than 10,000 amps, I liken this to like the treads on or like you're going to buy a roof, right? You're going to put shingle on the roof. You can get a 20-year shingle, you can get a 30-year shingle, you can get a 100-year shingle. You can put a metal roof on, it'll last forever, right? So this is sort of the way they test the devices. They'll hit it with surges, and it has to last based upon, it has to survive a number of hits of certain magnitudes. So that's what this rating does, and it's more of a performance from a longevity. The argument being that, look, when a surge device fails, or when it gives its life for your products, right? When it finally expels its final electron, what happens? You get a little LED that says, I'm dead, right? That's it. So it doesn't turn the circuit off like a circuit breaker does. It just turns a little LED and you have to go down and actually look for it. So we want these things to last as long as we can, and that's what that rating is all about. We did the same thing in 210.8. You'll see the same structure, same language, load side of the feeder, it contains branch circuit. So this is similar language, basically the same language that we saw in 225 and in 230. So same structure, and my only reason, there's the language I got in for the lead lengths. I argued that one. I argued very passionately at the table too, but it was online. So this cycle was all virtual. So there's only so much emphasis you can put when you're just a voice on the other side of the phone. All right, energy management systems. We all love energy management systems, right? So an energy management system, they came up with a definition, and I absolutely hate the definition. I think it needs a lot of work, in my opinion. It says a system consisting of any of the following: a monitor, communication equipment, a controller, a timer, or other devices that monitor and or controls an electrical load or a power production storage source. So I have a phone. On my phone, I can look at how much energy my outside lights and my inside lights are using at the house, and I can turn them on and off. Drives my wife crazy when I'm remote and I demonstrate it to somebody. But technically, I meet the definition because I monitor. I mean, all I have to do is monitor. And they call it an energy management system. So, but the way they use the term elsewhere in the code, in Article 750, 220, 705, 625, a very important aspect of an energy management system is that it has to control the loads. And how we leverage the energy management systems in the NEC is we'll tell you, you can size feeders, you can size your service based upon what these energy management systems limit your energy usage to via load control. An important aspect of this is in Article 705 for interconnected systems. The challenge in a 705 system, if I have photovoltaics and I'm coming into a panel board on the load side of the service over current device, not on the line side, but on the load side, I'm going to connect it through a breaker, which hopefully will be reverse power fed capability, right? And what do I have to do to the bus? I've got to consider now I have two sources, and I can put more load on this panel board, right? If my panel board's rated for 200 amps, and I have a 200 amp main, I can tell you I'm not going to get more than 200 amps long enough for me to overload and heat up that bus bar, right? But if I have my main at 200 amps and I have a photovoltaic system connected in, now I can put more than 200 amps worth of load and not trip an overcurrent device, and now my bus is overloaded. So in the photovoltaic world, in Article 705, any interconnected system, they're basically saying, look, if you have an energy management system and it limits the amount of energy that it can put into the system, then you can size your panel board based upon the set point of the energy management system. Now that's a little scary because a lot of these energy management systems, if you have to do any interaction with them, what happens? You install it, and you get a pay raise and a promotion because you saved the company so much money, and then they give you a promotion and you move to another facility and the new person comes in and says, I don't know anything about it, just turn it off, right? They don't want that. They want to make sure that this is a safety-related piece of equipment now, because now I'm sizing my power distribution system based upon that set point. And we're also seeing it in electric vehicle chargers. So electric vehicles, you know what's going on in the electrical vehicle industry? You know, you bought this $80,000 hunk of burning love that's sitting in the driveway, and it's got this big battery, and you want to power the house with it, right? Why buy a generator when I got my F-150 out there or my Chevy or whatever, and I just paid 80 grand for it? So now they're saying, look, we can power the house. And if you do that, you need to make sure that you are doing an energy management, have an energy management system in place so that you don't overload the system, overload the vehicle, et cetera. So we're relying more and more on energy management systems. They're used in these articles and these sections, and I think it needs a little bit more love, but I think it'll get there over, you know, the code book is like a fine wine. It gets better with time, based on public inputs. So you get engaged with the NEC as you see things. If you see applications that aren't covered or need help, think about some public inputs or raise the idea. Give one of us a call and we'll help you formulate a public input for next cycle. There's your 705.13, an energy management system in accordance with 750. 750 is for energy. It's the title of the whole article is energy management systems. Permitted to limit current and loading on the bus bars and conductors supplied by the output of one or more interconnected electric power production or energy storage sources. So we're relying on this system to size our equipment, and it better work. So the standards are addressing this. I think there's probably some opportunity for the UL standards to take a look at the listing requirements around these energy management systems and make sure that they're going to perform the way we need them to perform. They have to be listed as a type of EMS. A listed power control system is a type of EMS that is capable of monitoring multiple sources, et cetera. So, and what you're seeing on the electrical vehicle charger world is the management of the power distribution, where you have multiple vehicles can plug in and then they'll manage the power for charging those vehicles. So you don't have to size the service for the electric vehicle chargers bigger than the service for the structure. 110.3, so what do we do there? I'll tell you what we did there. We modified cybersecurity. We added, so cybersecurity is now in the NEC. And it's a challenge. It's controversial. Some people will argue it shouldn't belong in the NEC. Some people will say it belongs in the NEC because that's the hook. That's the document that's enforced and adopted by states. And so if you don't have it in the NEC, it becomes like a 70E document, which is only enforced after the fact if you have a problem. So in any case, we have a requirement in list item 8 that says cybersecurity for network-connected life safety equipment to address its ability to withstand unauthorized updates and malicious attacks while continuing to perform its intended safety functionality. This is what an electrical inspector is supposed to review your installation in regard to, right? Which is very, very vague. Okay, what is a life safety system? If you would assume life safety system would be what? Article 700. Right? I would go, hey, I'm going to go back to 700. There's no requirements in Article 700 that were accepted by Panel 13 around cybersecurity. So you say, well, I don't have any requirements there. So we have requirements in Article 240 for overcurrent protection devices that are network connected that I can control the set points. We put it in Article 708, and I'll show you that language, which was, again, controversial, probably not applicable for the NEC. So this whole topic is in its infancy with regard to the NEC. It's already in NFPA 72 and many other NFPA documents. The general concern is we don't want someone to be able to take out a power distribution system maliciously because it's connected to the network. Now, if you talk to a cybersecurity expert, they'll tell you, well, that doesn't address the internal threat. Right? The actors, the bad actors don't have to be outside, they can also be inside. So, but in any case, it's getting recognition. There's a lot to be done on cybersecurity. There's two philosophies. There's a component focus. You know, UL's out there says, hey, we got a standard, we can list our product to this standard, and then there are people that say, well, wait a second, I don't need that. I'm just going to do a cybersecurity assessment because it's not just the product that makes the difference. I can buy an Apple computer and say, look, okay, Apple computers don't get hacked as much, all right, so I'm good there. I can put some virus scan on it and say, okay, this is great. But then, you know, next month, all of a sudden, I've had 5 updates to the virus scan for the virus software, and I can still be vulnerable, right? So it's not a set it and forget it mentality. It's a continuous process, which the NEC is an installation requirement, right? We're inspectors. The inspector guys will say, I'm an inspector, not expector. I can't tell you what's going to happen in the future. So we got some requirements, but that's the basic gist of the philosophies. You know, 2 philosophies. I want listed product, and the second philosophy is we want a system analysis, and we want a cybersecurity assessment, which, I love the language, a circuit breaker that can be adjusted remotely to modify the adjusting means shall be permitted to have an ampere rating. So this is your adjustant, 240.6. I can adjust the amp rating of the device, and then I can connect it to the internet, right? I can connect it to the network. And it says that you can do that if you connect it through a networked interface that complies with one of the following. A circuit breaker's associated software for adjusting settings are identified as being evaluated for cybersecurity. That's a listing mark, okay? And then the other is a cybersecurity assessment of the network is completed. So you install your system, and you get these circuit breakers, and you do a cybersecurity assessment, and you hire our guys to come out and do it. And Dan Carnevale comes out to site. He walks through everywhere, and he says, all right, guys, you know, man, you're in bad shape. You know, not only are you hackable, but you've been hacked 4 times since I've been here. And here's my assessment. You get red, 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 red. This is terrible, terrible, terrible. And I give you that report, and I met the language of the code. I did a cybersecurity assessment. Okay, so I think this needs a little bit of love, a little bit of work to put some performance parameters around it that says a cybersecurity assessment that meets X, Y, and Z performance would be good, or something of that nature. My point is, it's in its infancy, but it is there. It's in Article 240. So you take circuit breakers, you put them on a network. You can view them from your iPhone, from your Android phone, whatever phone that you're using. And you can access your system from your computer and your desk. All these great things you can do. You can change set points. You can do a coordination study. All these great things. You're going to have to do either have all of those breakers listed or do a cybersecurity assessment. Probably everybody's going to migrate to the cybersecurity assessment. And you should have a program in place anyway that is ongoing, because cybersecurity threats don't stop just because you have an assessment. There are some references to standards. There's 2900 for cybersecurity. That's what we would list products to. And then there's NIST frameworks and et cetera. So there's a lot of reference materials out there that we can use to harden your system. There's your 240.6D, the ISA. So these are, again, just the informational notes. There's your 240. Remotely accessible. Again, cybersecurity is a specialized field. So they added a bunch of information. And this was controversial. You know, the Ciscos of the world and others were like, look, and they're technically right. Okay, their point was that, look, you have a requirement in the National Electrical Code that is defunct the moment you do the assessment. And oh, by the way, I can do an assessment and it tells you you're very vulnerable and you didn't get anything done. So, but it will get better. It's like a fine wine. There's your 708. Now here's the issue with this one. Okay, you'll see that, again, the 2 philosophies are here. Connected through a network interface, you have A, being evaluated for cybersecurity, B, doing the assessment. But the problem in 708 was this language right here, which is what failed it at the panel meeting. The National Electrical Code is an installation requirement. We don't look at it every 5 years. 70E tells us we need to do our systems analysis studies every 5 years because that's a part of your work plan, your safety plan. But the NEC, that doesn't necessarily belong in the NEC. Cybersecurity assessments shall be conducted when the system configuration changes at not more than 5-year intervals. And the point of a lot of the cybersecurity people is that it's not when system changes. It's an issue regardless of your system may not change at all, and you still have a cybersecurity threat. All right. Arc flash hazards, okay, 110.16. Remember these, right? 110.16, there you had your arc flash hazard. This is your arc flash label based on 70E. This is an IEEE 1584. That's just a, hey, it's dangerous. This has been in the code for a while, and this cycle, we expanded the marking requirement in 110.16b beyond 1,200 amps. We moved it to 1,000, and then we also said feeder supplied equipment. So it's not just services anymore. So we expanded that to feeder supplied equipment. If you do arc flash studies, who does arc flash studies? I love all of you. All right, so you're going to be doing more of that for anything that's 1,000 amps and above, whether it's a service or a feeder supplied equipment. There's where we took the 1,000 and in accordance with acceptable industry practice. So what we removed out of here, remember, we had the voltage, we had the clearing time of the service overcurrent device, all that jazz. That lined up with 70E's PPE category method. But when you're at the service, you can't use the category method at the service because your protecting overcurrent device is on the utility. And if you dressed based upon the PPE category method, you would be underdressed for that application. We know service equipment is very high incident energy. So be mindful of that. Those are your type of your labels. And this is both of these would be in accordance with 70E, whether you do an analysis method or you use a PPE category method. Both of those are accepted by 70E. And remember, you're protecting overcurrent devices upstream. You're doing the work downstream and your label is down there, but your clearing time is based upon the upstream overcurrent protected device. So 1,000 amps and larger, that equipment would have to be labeled. Reconditioned equipment, I already talked about that. I'm not gonna, we just added more clarity on reconditioned equipment. Again, more clarity on marking requirements. I already talked about the motors. Servicing, we added the definition for servicing because people said, look, if I'm not reconditioning, remember, if I take a product and I take it from a non-working state to a working state, I'm reconditioning it, okay? But if I take it from a non-working state to a working state and I buy products, I buy components with instructions from the manufacturer, now I'm servicing it. Okay, and we added the definition of servicing and what that means. So you're following instructions and you're servicing equipment. This helps make sure that if you remember, the confusion is the definitions are critical because if I meet the definition, now I got to follow the requirements. So because we added the definition of servicing, you should be sure that we will have requirements for servicing when you are servicing, where you get the parts, what are acceptable parts, and who can perform the servicing. And that's in 110.17. And you can look that 110.17 up as you get through there. So we addressed servicing. This is a big one, 110.26. All open doors. So remember, we took the large equipment. We made changes in large equipment. We said if it adds up to 1,200 amps and above, then you need to have two entrances and egresses from that room, not just 1,200 amps, right? So if it adds up to 1,200 amps. And we also added language that says the doors, open doors, cannot impede egress to or from a working space. And what they did was they took that language and they moved it to the parent text, both for low voltage and medium voltage. So now if you have a hallway and you have equipment on either side of that hallway and it says simultaneously opening doors, simultaneously open equipment doors. So if I open the doors on both sides of the hallway, I need at least 24 inches of egress space. If your hallway's short or your hallway's wide and your equipment is deep and you open both sets of doors and you don't have 24 inches, you have an issue with egress. How are we on time? 5? I got a little bit more? Okay. All right. 210.8. Here's what we did in 210.8. I won't cover dwelling units. Other than dwelling units, kitchens. We just split out kitchens and areas with sinks. Here's what we recognized. The hazard is not the receptacle. In 210.8, we do all of our measurements off of a receptacle. Why? Because inspectors can walk into a rough-in or into a for final inspection, they can see the receptacles, they can do the measurements. But we realized the hazard is not the receptacle, the hazard is the appliance. It's what's plugged into the receptacle. So we made a change in 210.8A for dwelling units. It said if it's in a kitchen, I don't care. If it's in a kitchen and it's plugged in, you GFCI protect it. And if it's cord and plug connected, we added a 210.8D. But for other than dwelling units, we added a little bit different language. We said, look, if your appliance is within 6 foot of the sink, it's a permanently fixed or stationary appliance. If it is within 6 feet of the sink, not the receptacle, then you need to GFCI protect it. Okay, so we added that realizing that it's the appliance that's the hazard, not the receptacle. We fixed the indoor damper. Aquariums, bait wells, and similar. If you do aquariums, if you do one of those bait shops, you're going to be GFCI protected. You're probably already doing it anyway. Okay, I already talked about that. There's your specific appliances. We expanded this. The panel, there were a few people on the code panel that did not want to expand to appliances. And one of those individuals reached out to the Consumer Product Safety Commission and said, show me the numbers. And they taught that individual how to fish, I say, and he did his own homework. So the expansion that you see with appliances in 210.8D are because of his research. So in 210.8D, it's whether it's cord or plug connected or hardwired, doesn't matter. 150 volts less to ground, 60 amps or less, single or three phase. We added electric ranges, wall-mounted ovens, counter-mounted cooking units, clothes dryers, and microwave ovens. All of those have body counts associated with the Consumer Product Safety Commission. And most of them are from workers, people. What do you do? What's justified energized work? Maintenance, right? If you're troubleshooting a circuit, you've got to have it on. And these appliances were killing people because they're troubleshooting. There's a new special purpose. So if you do, what do you call it, hotels, place like this, and you have a swimming pool, and it's a 480 volt pool pump motor, or if you have a very big home and you've got a 480 volt pool pump motor, you're going to need what they call a special purpose GFCI. Special purpose GFCI doesn't trip at 4 to 6 milliamps. It acts off of the principles from the European standards. So European standards use 30 milliamps. In the US, we use 4 to 6. Do you know why? Why is the equivalent of GFCI in Europe 30 milliamps? Anybody know?
Because they do multiple circuits. So that one GFCI that covers 8 circuits and the cumulative adds up.
But how can it protect you from shock at 30 milliamps? Oh, it doesn't. All right, I'll tell you that they do that, and I just learned that. I was looking at some circuits this past week. 30 milliamps in Europe is because they worry about defib. We go into defib around 40 milliamps. In the United States, we care about let-go thresholds. Dalziel, all of Dalziel's research, right? Dalziel, took all of those people who needed beer money, right? And they said, hey, let's put some current, see if you can hold on to this rod, right? And oh, you know what? It's not just men. We got to get some women too. And then if you go back to the 30s, they tested children to determine their resistance values of their bodies. So a lot of what we know now about let go is because of the sins of our fathers who were doing the bad things, and now we know what 4 to 6 milliamps is about, the place where you can't let go of a conductor. In Europe, they don't care about the let go, they worry about the defib, okay? And the 30 milliamps is because of those accumulated leakage currents, right? And in some cases, some countries use 300 milliamps at the main. So they put a 300 milliamps at the main on a structure, and then they go 30 milliamps on those branch circuits. So the special purpose GFCI works off of that same principle, and what they're doing with a special purpose is they are trying to control the voltage across the body, and they have assured grounding paths. There's software in there that makes sure that the equipment grounding conductor has to be a certain size, and they're trying to control the voltage across the body so that they know how much current will flow through the body if you come in contact. But these are applicable to greater than 120 volts. They're up in the 480 volt systems. So there's peppered requirements in swimming pools and in, I believe, RV parks too. The same barriers that we have on service entrance equipment, 230, we put barriers on 230 because of why? What's the 2 elements of risk? 2 elements of risk, come on. I'll give you one, likelihood. The likelihood of an event happening, what's the other?
Incident energy.
Incident energy is a type of hazard. It's the severity. It's likelihood and severity, right? I'm going to get on a plane tonight to go home. The likelihood of the plane going down is pretty low. What's the severity? Pretty high. But we say the risk is low of getting on a plane as opposed to driving in a car, even though the severity in a plane crash is much higher than an accident in a car. So we could control or we can manage risk. And Article 215.15, the secondary of transformers, what do we know about the first panel board on the secondary of every transformer? Where's the incident energy is dependent upon what overcurrent device? First panel board on the secondary of a transformer, what is the overcurrent device that I rely on for my incident energy? Primary. And how do I pick that primary? Am I picking it if I have a 300 amp full load amp? Do I put a 300 amp breaker on it? No, right? I could go up to 250% of 300 amps. My instantaneous is moving further and further to the right. The incident energy on the secondary of every transformer is very high for that reason. So we recognized that, and we said, look, if you are feeding a panel board, switchboard, switchgear, or motor control center that are fed from a feeder tap, and a feeder tap is inflated high too, or a transformer, then you have to put barriers to reduce the likelihood of accidentally coming in contact with energized parts. So that device right here, this main overcurrent device on the secondary of the transformer, and if it's a delta Y ground, you always have to land on an overcurrent device for a panel board, especially a panel board. So you're going to have to barrier that line side, and that's really on us, but don't throw away the booties, okay? When we ship a panel board, if it has booties, don't throw it away, because if it's the first panel board on the secondary of a transformer, you need to put a barrier there. And this is why. Look at this. 23.5 calories on the secondary of this transformer. Why? Because it's relying on that device for the clearing time. But if I simply move the overcurrent device out, and maybe I integrate it with the transformer itself, now my incident energy, where the likelihood that I'm going to do justified energized work has gone from 23.5 to 0.34. I'd rather work on 0.34. Actually, I'd rather be on the couch. So anyway, so there's your OCPD, there's your tap conductors, panel boards. That OCPD is sized larger than these tap conductor sizes. So you've inflated the size of the overcurrent device. I've increased the risk because the severity of any working on any of this down here is high. And this is my last one. So selective coordination, emergency side. So how many people selectively do selective coordination studies? Oh man, I love all of you. Excellent. You know, it's beautiful. So all of this on the right-hand side is, say, your Article 700 system, right? 700, 701, 708, anything that's on the load side of that transfer switch and feeding the transfer switch from that generator, that's the emergency side. The big debate has been, panel 13 always gets public inputs and says, well, what about devices 1 and 4 that goes to that transfer switch? Do I have to selectively coordinate 1 and 4? So panel 13 said, no, look, you have to selectively coordinate 7 with 4G and 7 with 4 and 7 with 1, but 4 and 1 are outside of the purview of Article 700 because they're on the normal side. Article 700 can't tell you what to do on the normal side. They can tell you what to do between 7, 4, and 7 and 1, but the onus is on 7, not those other 2. So panel 10 said, you know, we're worried about the reliability, and from a failure mode, from a reliability perspective, transfer switches may not transfer. Generators may not start. So if I can avoid the transfer, then I've increased the reliability of the system. So in 240.11, we now require, when you are feeding a system where the overcurrent devices downstream of that transfer switch have to selectively coordinate with the normal side, which is your Article 700, 701, 708, I've got a list of them, then you have to selectively coordinate the main with the first level overcurrent devices. So the main and the immediately connected branch or feeder breakers. So everything in that top left. You don't have to selectively coordinate down below 2 or down below 3, but you know that if you have a fault down below 2, you'll take out 2 and you won't transfer. If they did not selectively coordinate, you could take device 1 out, which is your main, and now you've forced a transfer needlessly. And what if the transfer doesn't switch? What if the generator doesn't start? Now you're into an emergency mode. So that was the point there. Anywhere that the feeder overcurrent protected devices to be selectively coordinated with a service, basically anywhere you're feeding these types of systems, 620, 645, et cetera, you need to selectively coordinate those devices. Make sense? And that's it. And then the replacement trip units have to be listed. Whew. I didn't think I'd get through all of it, and I probably went over time. Any questions? Donations, answers? We take anything. Take orders, too. Nothing. You guys are all 2023'd up? You know all there is to know? There's a lot of other changes I didn't cover. A lot of changes in 2023. So
we're going to break for 10 minutes. So 10:25, we will resume with ASHRAE metering presentation.
And just be mindful, that is live streaming right now. So if you don't want to go this way, you can go that way. Just want to let you know. Sorry about that.
Thank you.
Thanks.
We gave you a late start.
Okay, I'm still on. All right, guys, out there on YouTube, we're going to be right back. And LinkedIn and Facebook, we're going to be right back here in a second. I'm going to give you a standby screen.
$11? 5 minutes to 11.
All right, I'm going to put this on your shirt. Is that okay? Now, you have that one too, so I don't know which one you want to put where. So let's put that one there. That should be fine. You still have that one too.
Oh, is it 2 mics?
Yeah, because that one is for the live stream.
Yeah, he was telling me that. Nice.
Yeah. We're gonna be famous.
Famous for the wrong reasons or right reasons?
All the right reasons.
So how do I activate this? Is it on off?
Well, that's already on. So you should be on here, and that's already on too.
So what we're talking about now is being written.
Is live stream right now.
But I don't hear anything though.
Nope, it should be coming over here too. I'm gonna pull that up on.
Yep.
It's on your left, on your right side. Give me that. You got it backwards. You got it pointing down. Pro. Kids, what are you gonna do with them? You know? There you go.
You can hit 10 till, great. If not, 5 till. Give them a 5-minute break.
Okay. When do I start? When do we start back up?
10:25.
Sir.
Do you want me to give you a 10-minute warning kind of deal, or?
I appreciate it. Hello, everyone. Welcome. My name is Dwayne McGrody. I am a regional power expert application engineer for the Gulf region. So I cover Texas and all the surrounding states. I've been with Eaton for about 18 years. 10 of those years, I was a product manager for meters. And the last 8 years, I've been located here in the Gulf region supporting our sales offices, supporting consulting engineers, work with each one of our sales offices if they want to set up lunch and learns and things like that. Today, I'm going to be talking about power monitoring and how it pertains to energy codes. I'm not going to be talking about the entire energy code, just very specific sections of it that pertain to the metering portion of it. So today's agenda, I'm just going to start off with the basics of metering, touch on the energy codes, at least from my experience, what I've seen in this region, and talk about how we solve addressing some of these energy codes with some of the products that we have. And then how does all this stuff communicate and come together to kind of meet and address these energy codes. So basics of metering, starting off, you really need two measurements. You need your current and you need your voltage. Starting with current, there's a variety of different ways to do that. The meter itself cannot take the amperage of a specific switchboard or panel board, which is typically 400 amps, 1200 amps, 2000 amps, whatever it is. We have to step that down to typically another signal that the meter will accept. In the marketplace, typically 5 amps has been the secondary signal that we've seen. As time went on and as new products came out, 333 millivolt has kind of been a new standard that's come out. Accuracies are important. With the 5 amp CTs, you typically get down to 0.3 amps or 0.3% accuracy. With the 333 millivolts, they're down to 0.5%. One of the advantages of the 333 millivolt is you don't need a CT shorting block. They can go directly to the meter without having to do that. When it comes to current, and you're using these current sensors, there's some important things you have to watch out for when you're using these. The current sensors have two leads coming out of them, a plus and a minus. And in the meter itself that they're going to connect to, there's a plus and a minus. Who can tell me what would happen if I mixed a plus and minus on the meter? Utility company pays you. Utility company pays you, exactly. So essentially, it's starting to monitor negative energy usage, which if you're using these for energy codes or if you're using these to do some cost allocation, that's a big deal. There's another marking on the current sensor that has a little arrow. The arrow says, typically says towards the load. What happens if you put the CT pointing towards the source? Yeah, again, the utility company pays you. So you'll get a negative reading as well. So if you just happen to get the leads wrong and the orientation of the CT wrong, it'll actually work right. So that's just something to be considered with. The other thing you need to pay attention to is a lot of these CTs and current sensors look the same. So a 5 amp CT versus a 333 millivolt CT look different. And I know that I've worked on some projects where we would ship out the meter and the CTs would show up. It'd be in a big box. And some would be 333 millivolt types, some would be 5 amp. And even in some of the same signal types, one could be a 30 amp CT, one other one could be a 100 amp CT, but they look exactly the same. So when these are being installed in the field, it's very important that those things are taken into consideration. I'm going to bring that up. The reason I'm bringing that up is we have solutions to address that. And as I go through, I'll talk about that. The other main part is voltage. Voltage is fairly simple. All of our meters are typically, a lot of the meters in the marketplace are rated for 600 volts or less. Anything above 600 volts, you're going to have to put some kind of transformer to step it down so it takes 600 volts. So typically a 208 or 480 can go directly into the meter. There's also a control power aspect of the meter as well. Some of those can go up to 415 volts. Some of them can go up to, like, say, 240, and that's it. And in those cases, you have to use a control power transformer to step that down. If these are installed in the factory, you don't even have to worry about that. They're just going to have all the correct wiring and voltage and things like that already in there. All right, so when it comes to using these meters, there's usually two categories that you're wanting. One is the energy and the power, and the other is the power quality. For today's discussion, I'm going to focus on the energy and the power. Usually the energy and power is actually the work that's being done by the meter. So simplified, when it comes to energy, this is similar to at your home where you have a meter outside the home. It's monitoring the amount of energy you're using. So if you think about a 100-watt bulb used for 1 hour, that's a 1 watt hour. If you have 10 of those 100-watt bulbs, that's 1 kilowatt. Use that for an hour, it's 1 kilowatt hour. Use it for an entire day, that's 24 kilowatt hours. That is a constantly accumulating value. Now, when it comes to the energy codes, that's one parameter they're very interested in too. What is the amount of energy that's being used, or the watt hours? The second component is power demand. So power demand is usually specified over a period of time, usually a 15-minute window is very common, that the utility is basically going to provide enough power to that facility. Now, a facility has to decide when it's going to start things up in the morning. Say, let's just take an example of a facility that starts at 8 a.m. and they turn on all their chillers, they turn on all their lights, and within that 15 minutes, they turn everything on. Now, if they do that, that demand is going to be pretty high, within that 15 minutes. And that's how much power that utility has to provide to that specific customer. And there's a separate charge, typically in a commercial environment, on the bill that'll say demand charge, and it'll be like so many cents per kilowatts. And sometimes that demand charge can be more than the kilowatt hour charge for the entire month. So it's very important to pay attention to that specific charge and power so that you can manage it and maybe start things, maybe delay over that 15-minute window. And each utility is going to have a different window. It might be a 30-minute window, it might be a 1-hour window, just depending on the utility. So in talking about what the utility has to provide, another thing that the power or the utility it provides is what they call VA, or the volts times the amps. So if a facility was all electric use, like electric heaters, it would basically, the VA that it's supplying would equal to the watts or the work being done at the facility, because it would all come out as heat. But if I have a facility that has a lot of motors, some of the motors are actually doing some work by turning, but some of the motors are also generating heat, which is actually wasted. So the VA is actually the total amount of power that the utility has to provide. The watts is basically what's doing the work, and what's left over is considered waste. And sometimes they use that power factor is another charge that the utility would charge based on how efficient the facility is. So say, for instance, they might say, well, at a 0.9 power factor, we're not going to charge you anything, but below that, we might charge you a power factor penalty. And there are some things you can do to address that with capacitors and things like that. But for today, I'm just going to about the meters that are monitoring those specific parameters. All right, so why meter? There are lots of different reasons. You can benchmark energy usage. You can verify the savings from projects you've done. You can monitor the quality of the power. But for today, I'm going to focus on primarily the energy codes. And if your particular metering system can meet energy codes, you can also do cost allocation. So a lot of the products in application that I'm presenting today that are addressing the energy codes are the same products that we would use to do cost allocation. We're actually allocating the energy use back to the tenant usage. So energy codes. The first one that I've kind of run into when I started in the metering world is LEED, which is Leadership for Energy and Environmental Design. And basically, when it comes to power monitoring, there's a certain number of rating system that the LEED gives you. And the more meters you have on a project, the higher points you get towards that rating, and you basically become more of a green building. But there are some requirements that LEED kind of started it all for the metering system that you'll see run into the ASHRAE 90.1 codes and most recently IEEE 2021. So the whole intent is to be able to monitor the energy usage within a facility, maybe at specific usages, in order to be able to do something about it. The meter itself, it can't do anything. Basically, the action you take based on the information you get from the meter is actually where you get most of the benefit. So if you look at the actual requirements, I know this is kind of small here. The whole building source needs to be monitored, the entire building. The meters actually have to be permanently installed, so you can't put something temporary out there. It has to be able to store at least 3 years worth of data, and it has to be able to do some reporting back hourly, daily, monthly, and yearly usage. That has to be able to come out. The next thing is ASHRAE 90.1. How many have heard of this energy code? So how many have heard of ASHRAE 90.1 2013, and then 16, and then 19, and 2022? So every 3 years they update this. So I did a little bit of research, and I put the link on here where you can actually look at ASHRAE 90.1. Since 2015, since I started monitoring this, 19 states have adopted 2013. 2013 is where they started defining ASHRAE, the individual categories that you need to monitor. There are 9 states that have actually done 2016 and 2019, and this is actually growing. So this was actually as of December 2022. I put a link on there where I can get this information from. It's a government link that actually tracks this specific information. Texas has decided to adopt 2013 based on a state and a city level. And when I see this on projects, sometimes it's at a state project, sometimes it's just decided that that particular owner wants to follow the latest energy codes. And 2013 is the minimum as far as like doing energy classification and sorting. So the requirements for ASHRAE 91 is a specific section within 90.1, is 8-4.3. And I put a link there on the bottom right that you can go to the ASHRAE website and do a read-only version of it. And that's where I got a lot of this information. You don't have to purchase it, but you can actually read through the information and what these codes mean. So 5 different categories that it's requiring. The total building, total HVAC, interior lighting, exterior lighting, and receptacle loads. So each one of those individual categories have to be broken out with the metering system. And there are different ways to do that, and I'll go over that. In 2016, they added the addition of chilled water plant metering, which is actually covered in a different section within ASHRAE 90.1. It's actually under section 6, and I'll show that. And then in 2022, which I haven't really found a published version, but I did find like remarks on 2022. And it basically said that if the refrigeration load is more than 10% of the entire building, that needs to be monitored as a separate category as well. So this was the chilled water plant monitoring that came out in 2016. It's actually from section 6.4, which is where the building management system is basically located, where they define that. And basically big water-cooled chiller systems, air-cooled systems, those are the kind that they're wanting to monitor the specific electrical usage of those devices. And then they want to do an efficiency calculation. So ideally, the chilled water system would probably go back into the BMS system to do some of these calculations. And I'll show kind of like what happened in 2016, where they required, if a building had a digital control system, like a building management system, they want all that data to be fed up through that system and to do the separation of the loads, different categories and things like that. Now, there are products out there like the meters themselves, they can do that as well. They can break out all these different categories between lighting and receptacle and HVAC, and they can feed that information up to BMS, or BMS can do it independently. You just need to make sure that the metering system can break out all these individual loads depending on how it's designed and monitored. So some of the same requirements for the metering system that you saw in LEED. You have to be at least go down to a 15-minute window. You have to have at least 3 years worth of data. You have to be able to report this hourly, daily, monthly, and yearly. And then the data has to be available for the tenant, who's going to be either be charged for the electrical usage or the energy codes. And one way to make it available for the tenant is there can be a display on the gear in an electrical room, or what would be more beneficial would be having a web page of the devices, or a web page showing the individual category of the electrical usage. A lot of BMS systems have that capability. Basically, all of our metering systems have web page enabled devices that all you need is a browser to look up that type of information. So there are some exceptions. Any building less than 25,000 square feet does not need to follow ASHRAE 90.1. An individual tenant space, say in a commercial building, if they're less than 10,000 square feet, they don't need to have the loads broken out. Individual dwelling units, like in your apartment or whatever, they don't need to break out, all of the individual receptacles and lightings, things like that. And in a residential building area with 10,000 square feet of a common area or less, that does not to be broken out. But if it is more than 10,000 square feet, it needs to be broken out into those individual categories. And then finally, any hospitals or anything like that, they don't need to follow ASHRAE 90.1 and break out these different categories. So here's an example of what maybe a drawing on a set of plans might look like. On the right-hand side, there might be a note that says, okay, we need to break out these individual categories to follow ASHRAE 90.1. And then they'll put a little, like maybe a number. In this case, we have a number 9, and that number 9 is associated with a specific panel. And that specific panel might be a specific load type. And we talked about those 5 different load types. It might be lighting, it might be receptacle, it might be HVAC. So they put individual notes on there, and then our offices, our sales offices would be looking through these plans, and I would help them determine what particular meter they need to put in that panel in order to meet all these requirements. And that way you can put together a system that complies with ASHRAE 90.1. Here's another example, same thing that talks about different load types. But in this instance, we actually have different load types within the same panel. And that's going to require a different type of product to address that. And then down here also, they're all spread out between different load types on different panels. So ASHRAE 90.1, 2016 or 2019, now I'm starting to see a new code that's being applied is IEEE 2021. How many people have seen this one? So, okay, so you guys are seeing this too. So they almost took ASHRAE 90.1 and added to it. So it's the same category, you got HVAC, you got lighting, you got receptacles, but they added 2 additional categories to it. They added process load, which could be like kitchen equipment or something like that. And then they have a category that's everything else that's not included in the previous category. So they really want to break down the individual energy uses. There are some exceptions here. HVAC and water equipment for individual dwellings does not need to be included, and then a few other there that I've noted as well. As far as the system's concerned, they went into a little bit more detail on the system. It was kind of funny to hear in the first one, they talked about the CT accuracy, but nowhere did they talk about the meter accuracy, nor in ASHRAE 90.1 do they talk about the meter accuracy. Most of the meters, especially modern meters today that are found on ANSI C1220, are either 0.5 or 0.2% accurate. The CTs here they put up, it's 2%, which I think is kind of high. Most of our current sensors are 0.5%. Usually when you're getting into that high 2%, category, maybe there are large split core CTs that maybe not quite as accurate, but usually you get into smaller CTs, you can get pretty accurate. The data acquisition system, they're actually defining it as a separate system. That could be the BMS system, that could be a device that's collecting all the data, that could be all the individual meters that have at least 3 years worth of data logging on board that you basically just grab the data and they bring it up. And then finally, a graphical reporting system. Now, they don't really go into exactly what it is, but it could be a BMS system that can create graphs and charts that separates out all the systems. It could be a web page that you can download the data and then bring up Excel and create graphs and charts. So really kind of left open into interpretation. One thing I haven't seen with these energy codes is any kind of enforcement. Has anybody seen any enforcement on these energy codes yet? Yeah, so I think we're at the point where we're just trying to get these into the system, and maybe the enforcement from your guys' perspective is, you're examining to make sure the system was put in correctly and it meets all these requirements. But going down the road where somebody's coming back and checking these, I think that's kind of still being developed. Here's an example of what you might see for IEEE 2021. Similar to ASHRAE 90.1, there might be a table there that says all the individual categories of loads, and they'll put some kind of notes on there, a designation of what load that needs to be. And that way, when we're looking through the plans, we're deciding what particular meter or product that we should put on there. All right, so now that we have the energy codes, now I'm going to talk about, well, how are we going to address these? What type of products should we use? What kind of design are we looking at in order to address these? So when I was a product manager for meters, I put this little chart together that shows kind of the basic meter down on the bottom, which is a feature set. And as the feature set goes up, you have a higher capabilities of the product, which means the price goes up. For today's discussion, I'm going to be focused on those bottom two layers. The bottom layer is basically a single point energy meter, monitoring that kilowatt hour, that power demand, the power factor, and then going one step up is the multi-point meter, where you're actually using that device to monitor a lot of circuits. Rather than have multiple single point meters, basically one device with multiple sets of CTs running to it. So when it comes to mounting these into the panel, or into the gear, there's two ways. They can either come directly from our factory with the meter installed. Now, when you get it from the factory with the meter installed, it's going to have the CT wiring correct, and it's going to have the CT orientation correct, right? When you do it with the external box there on the right, you're going to take that box, put it in the field, mount it next to the panel, run a set of CTs over to it, and then there could be a chance that the CTs weren't wired correctly to the meter or that they're oriented incorrectly. So the advantages of one versus the other, and I'll talk about some of that. Here's an example within a switchboard where typically you're monitoring the main power coming into the facility, where you would have a meter located within the switchboard, pre-wired, CT orientation correct, and then over on the right we have basically what we call an enclosed version of it, where we'll put it in a NEMA 12 box, all pre-wired inside, but you still have to run the CTs over to it, get the orientation right. But from the CT shorting block that we're connected to, it's going to be wired into the plus and minus of the meter as well. And then finally, the multi-point application. On the left-hand side, you see a switchboard where we have the CTs mounted on rails in the correct orientation. You just run your conductors through those rails directly into the breaker. On the top is where the metering device would be, and then there's a display on it that the tenant or whoever could go look at the device. And a lot of times we'll put a communication card in there as well that'll be connected to a building network that the customer or whoever's managing the facility can have access to. Over on the right-hand side is typically a smaller panel board where the current sensors are in what we call donuts. So they're pre-mounted on a board that you run your conductors in, mount it correctly, doesn't have to be wired, and then that could also be connected to the network as well. So on the right, typically 400 amps or less panel boards. On the left, anywhere up from 3,000, 4,000 to 1,200 amp switchboards and panel boards. And then for external, similar to what we did with the NEMA 12 box, we also put these multi-point meters in NEMA 12 boxes where you would mount one of these next to a distribution board and then run the current sensors, multiple sets of current sensors over to the breakers, and then bring that information into the connections on the device, and then connect this to the network as well. So on a drawing that we would review, we would see basically a designation that a CT needs to be put on each one of those breakers. And we could do that with a digital metering cabinet on the right, where we would put that multi-point meter in and run multiple sets of CTs over to it. Or down on the bottom, basically have it factory installed. So there's two ways to be able to do that and solve the ASHRAE 90.1. Say for instance, in a high-rise application or a retrofit application, we often recommend putting it in a NEMA 12 box and running multiple sets of current sensors. And on this case, we need to monitor 3 sets of meters on each floor. One of these multi-point meters can handle up to 8 meters, 8 3-pole meters. So in order to basically maximize or the usage of these meters, we might put 1 meter per floor or every other floor, run the current sensors up and run the current sensors down to catch the meters up and below the floors. That way you basically save on material costs for those individual meters. And these current sensors, they're pretty flexible. They can run up to like 200 feet. So lots of distance. When you're going up and down a floor, that's really not a big distance. Now, the design of the building has to be such that this has a common bus run all the way up through the building, and the electrical rooms are right off that bus run. So this kind of would work out nice for one of these multi-point applications. So when you're deciding, do I go integral or external? If you don't want callbacks or reduce the chance of callbacks, Internal is obviously the best, but it's also the most expensive because there's additional factory labor that has to be done in order to install these. But if you want lower first costs, then you put the meter in a box and then you put it next to the gear and run the current sensors over to the individual loads. And then from a design perspective, I guess there's a couple ways to handle that as well. You can either designate an individual panel as all mechanical, all lighting, or all plug, and then designate that on the drawings. And then we would decide, okay, that's going to be one single meter in that panel that's going to be pre-installed and shipped out. Or if it's a branch circuit monitor with all different types of loads in it, we'll put a branch circuit monitor in there, then we'll just use the software of the device to basically separate all the individual loads out. All right, so now we have our metering system. We've addressed our energy codes, but now we got to get this information back up to some other system. And we'll do that with communication. And there's two ways of communicating. There's serial communication and network communication. One of the most common serial communication protocols is Modbus RTU. And a lot of times we will daisy chain multiple devices and bring that to a device that would bring it out, a network device. Or they can connect directly via Modbus TCP, or very commonly with BMS systems is BACnet IP. So a lot of our meters basically cover most of those protocols. So where you're bringing those Modbus RTU or daisy chaining devices in, that would come into a device here. We call it a gateway or some type of processor or storage device that also has that 3 years worth of data logging capability in it. You would basically come in the bottom of this with the Modbus RTU daisy chaining in, and then out would come the network portion of it. And then here's just an example of those different devices daisy chained together going into that gateway device or network directly into the top. And then you have either software connection, BMS connection, or just a straight browser would connect to it. All right, so now that we got all that, let's talk about what a solution might look like. So remember, this is an example I showed before of what, you had a designation of the 9 up there, each one of those panels. The way we would address this, we would put together a communication wire diagram for it, designating what type of device we would put in here. So each one of those panels would get a PXM350 or a single point energy meter, and then that information would go back to that, basically that processor or storage device, and then that could be fed to BMS, or you can hit directly to that device itself. Here's another example that I presented earlier with ASHRAE 90.1, where you had different types of loads in the same distribution panel board. That's where we would take individual multi-point meters and enclosures, mount those next to those individual distribution panels, and run multiple sets of CTs over to that, network these into a switch within the building, and then that could be accessed by BMS, or it could be accessed directly by the owner. And then from an energy view, we have displays that would show the different categories. These can also be used for cost allocation because we can create the 20 different categories. So you saw that, IEEE 2021 added more than the 5. They're now up to 7. So we can go up to 20 with some of our devices and show the individual loads. And this information already bunched together can be fed directly up to the individual categories. And then putting it all together, finally, all these devices that I'm talking about, I have out on the table out there. But here's an example of different ways of capturing energy usage with some of our breakers, some of our multi-point meters, some of our single-point meters, all bringing that back to something like here. And if you guys want to see what these different products look like, have a touch and feel for them, I have a booth out there or a table out there where you guys can basically see what these devices are. I know that was a lot in a very short period of time. Does anybody have any questions? Yes. How many poles can you go on? So, yeah, so if you're putting it within a panel board, you can put up to 42 poles, but we actually have the system where you go up to 84. And then if you're doing externally, we can go up to 100 in one system. So 100 individual circuits can be monitored. When I say circuit, I mean a CT, current sensor. Yes?
The metering requirement in the IEEE, is that new to 2021 or was that in the previous?
Yes, that is new. The question was, is the metering requirement for IEEE 2021 new? Yes. The previous was 2015, And the only monitoring there in 2015 was an individual tenant needed to be monitored. And Texas right now is ICC 2015, but I am starting to see IC 2021 on the drawings. Certain jurisdictions have adopted it? Yes.
State will be adopting.
The state will be adopting by the end of the year? Okay. It's good to know. So we'll be seeing more of that. To ICC 2021? I had a slide on there. I did have some exceptions at the bottom. Like I think one of the things I covered was individual hot water heaters don't need to be covered, but there were 2 others in there as well. All right, with that, thank you guys for your time. Appreciate it.
We'll have another break. Ask that you guys make it back in here by 5 minutes after 11. And just a PSA, all the slides will be made available to you after we wrap this thing up in a few days.
One other thing I was just going to throw out there just for thinking about throughout the rest of today is if there are any topics, if there's any industry trends or technologies or anything that you run into or that you'd like to see us present on in the future, they don't have to be Eaton solutions. If it's just something that's out there in the industry, we want to make sure that we're doing things that are subject oriented towards what you're running into day in and day out. So think about that, over the lunch hour coming up here in a bit, and even in the afternoon sessions, and find us. We want to make sure we get notes down so that these are always dialed into what you're working on. So.
1 minute. Okay, everyone. Again, thank you for joining us today. The next presentation is called Switchgear Modernization Solutions. My name is Scott Brady. I am the regional manager for our engineering services technical application support team. I started actually as a field service engineer with Westinghouse Engineering Services and have worked through various roles as service manager, application engineer, and now in this current role as well. So our agenda for today is we're going to talk about what is switchgear modernization solutions, when to consider it, and we're going to talk about the standard that really is important when deciding to use switchgear modernization, which is IEEE C37.59. So this is solutions to renovate existing equipment. We've all seen out there, electrical equipment tends to last a very long time. Could last as long as 60 years if well maintained. I've even seen older than that before in the bowels of some very old customers. But this is a way to extend the life of that equipment and do it safely, and there are many other reasons for doing it as well. And we're going to go over those reasons. So one of the major reasons right now that we're seeing a lot of activity with switchgear modernization is these ridiculous lead times that are out there for new equipment. So we have customers that are looking for solutions to extend their existing equipment so that they don't have to turn to getting new equipment, which, as you probably all know, can be upwards of a year. The other thing is arc flash safety and arc flash mitigation. Adding features to existing equipment to help make it safer to operate, make it safer for everyone who interacts with it. And this is what happens when it's unsafe. If it's degraded too much, you see an explosion. I've done several investigations like this. It's never a good scene. Fortunately, many of them that I've been to have not been when people have gotten injured. So another thing is the equipment might be repurposed for a different function. The equipment loads change, different customer has moved into a building and they have a different application. So you need to reconfigure the equipment for that new application. Removal might not be economical. I've seen once in a hospital where they built, this was actually a VA hospital, where they built the electrical equipment in the bottom of the hospital, and they built, they used to ship, the turn hatches for a ship to enter the electrical room. It was incredibly unfeasible to even get into this electrical room. So it was really, the only alternative was to just modernize what they have. Yeah, the roof was sealed. There was no way into this vault. Updating equipment with new communication features, things like that, things that you saw in the last presentation. There is an ability to take equipment that was built in the 70s and 80s and put in new communication features into it. Multiple brands of electrical equipment, making service renewal parts a nightmare. You have, equipment manufacturers don't make parts and pieces forever for old equipment, so sometimes it's best to move on to new equipment, but this allows kind of the best of both worlds where you can get the advantages of the new equipment, current renewal parts, but you don't have to spend the capital to just replace the entire equipment in place. And then equipment is just obsolete and no longer supported by the manufacturer, or the manufacturer has gone completely out of business. How many people have seen that particular breaker out there? There's a lot of laughing over here. It's not a good sight, is it? No, it's not. Yeah, I saw this particular breaker once in a hospital very early on in my career, and when you pull it out of the cell actually wavers back and forth. So it's very scary. You didn't want to like reinsert it real fast. And then again, kind of talked about this before, your equipment is landlocked. It's no longer possible to remove it. The switchgear is okay. So we know that most of the switchgear is just this fixed copper or aluminum bus. It's not moving. It's not seeing a lot of, well, unless it's in California, it might be moving a little bit. But it's not really seeing any kind of mechanical stresses other than maybe if it saw a fault or something like that. But the circuit breakers are operating. They're kind of the one that needs the maintenance and to be maintained. So we tend to focus a lot of switchgear modernization solutions on circuit breakers, since that is obviously what usually fails early in the environment. So there's really two solutions. You can recondition your circuit breakers, or you can replace them. So there's advantages, of course, to replacing them. It's higher cost, of course, but it allows you to upgrade to today's technology. It might extend maintenance intervals. It might be a new product that doesn't require as much maintenance as the previous product did. Renewal parts are available. You might be able to increase short circuit capacity or meet new ratings. And it can extend the switchgear life back up to that 30-year typical threshold that you see out there. Then there's just the simple cleaning and relubrication. That's the lowest cost solution. Probably really depends on what kind of circuit breaker it was to begin with and how well it was manufactured, how effective that will be. Usually you're looking at 1 to 3 year service intervals. And then we also offer a service called full reconditioning. And in fact, if you go outside to the right, you'll see a display of a fully reconditioned Westinghouse DS breaker. TJ can show you about it. But again, that could re-extend that lifespan up to another 10 years. Again, but you don't get a lot of the other benefits that you could possibly with new. But again, there's a cost basis there. But of course, renewal parts remain an issue when you do that. So now we're going to talk about the standard that's associated with doing these services, which is C37.59. The current version is 2018. It's for conversion of power switchgear equipment. Who's heard of this standard before? 1, 2 in the back. Oh, good. Okay. So why was this created? So users recognize that circuit breakers reach the end of life quicker than the switchgear in which they were installed. Switchgear was not an option because of some of the solutions we just talked about. End users were overhauling or having breakers all to a point that it is just cheap to buy a new breaker. As manufacturers introduced new equipment, they discontinued some of the older stuff as well. So early aftermarket methods, there were a lot of players in this market, from what we would call used equipment dealers to OEMs, trying different things to modernize equipment, but there were inherent design issues with what some of the people were doing. And of course, a fatality changed the game. So for example, when a lot of different solution providers in this point were taking old medium voltage air circuit breakers and retrofitting them with vacuum technology. And there are consequences. There's obviously a lot of benefits with using a vacuum element versus an air element as far as size and durability and things like that, but there are also technical consequences to doing that that probably weren't looked at real closely by some of the people who were doing these things. So that was kind of like why IEEE, the Power Engineering Services, Power and Energy Society stepped in and decided to come up with this standard so that there were some rules around what you could do and what you could do and can't do, and what kind of testing is involved in doing all this. So the first version was published in 1991, and it focused on design verification on retrofitted circuit breakers and switchgear conversions, looking at continuous current, BIL, short time mechanical servicing, and endurance of the interlocks. Again, a lot around the safety configurations of the circuit breaker. And after the first version came, the supplier network kind of changed. It became more involved in the equipment OEMs. Obviously we're much more familiar with doing a lot of those tests, had a lot of laboratories to do those tests and the verifications that were out there. The designs kind of moved to a standardized section. I know even at Westinghouse, we were doing these type of modifications in various offices. We moved them all to one central location, focused all those standardizations there. And there were fewer people, 1 and 2 companies doing them here and there that were doing these type of conversions. And end users started making more educated purchases because these things, when there's a fatality in the industry, there's a lot of information goes out about what happened, and as those things came out, a lot of people realized the need for some kind of standard around this. So in the 30 years since that standard has come out, there's a lot of different conversions that have come out, a lot of different products and by various manufacturers. A lot of people realized that this was a very big need in the industry. So 2018, just a couple of changes that were in there. Also addressed arc resistant switchgear, added some guidance on medium voltage fused contactors. Requirements were expanded to talk about minimum design testing, and guidance for adding viewing windows in ports in switchgear, which is a very popular thing that's going on right now. Due to arc flash safety, people want to put viewing ports into their existing equipment and how to do that safely without violating the integrity of the switchgear. So C37.59 has the following items in its scope: reconditioning, roll-in replacement circuit breakers, vacuum starter replacements, retrofill applications, conversion of metal enclosed switchgear, new trip device conversions, in addition to the ports in the switchgear. Now, something that you might have picked up from Tom's presentation, the .2, the reconditioning. So you hear this term being used over and over again, is reconditioning kind of being standardized as the language out there. So one major distinction was made, though. For older equipment, the converter must use the preferred ratings and performance criteria that were in effect at the time of the original switchgear being converted was manufactured. Now, this can kind of be problematic because the standards were different back with some of the older switchgear. Some of them were actually more rigorous than they are today. So you might have difficulties just replacing with same, what was 65K back then might not be 65K now as far as how it's tested. And then another thing, a converter shall not knowingly convert a design without taking or recommending appropriate action to correct the defect in any assembly being converted. So there are some inherent issues with some of the equipment out there, and this statement is kind of like you need to resolve some of those inherent issues with the equipment. There's some very dangerous designs out there. There's some medium voltage breakers that have a levering system where you literally have to lever the breaker onto the bus. I've been in a power plant with one of those on it, and the operators were terrified of it. They would only call us to do it for them, which we weren't real happy with doing either. But we did make a vacuum replacement breaker that has that levering system, so it turns into a typical horizontal screw type system to remove that problem. So first, the next topic, we're going to talk about the terminology in C37.59. And I just wanted to start by saying, you notice the one thing that's missing, the one piece of language that's missing that I've never said yet is the term retrofit. So we hear a lot of people talk about retrofits. So retrofit is not a recognized term by IEEE or ANSI. So we are avoiding the word retrofit, trying to stay with conversion or reconditioning, which are defined. And then we have everything from non-interchangeable replacement circuit breaker. This is a circuit breaker that utilizes all new parts and has been tested to C37.09 and C37.50. But it requires conversion of existing switchgear to properly maintain. Reconditioning, so this is the product that you can see just outside these doors here. This is a process of maintaining existing switchgear equipment in operating condition that's recommended by the manufacturer's instructions, only using qualified parts. Again, it very specifically says you cannot reverse engineer parts. And I believe there is even language in the National Electric Code to that effect now as well. And again, just requiring design verification. And here is an example of what reconditioning can do. This is a medium voltage breaker. So you can see on the left, not in very good shape after reconditioning, which involves taking the breaker apart, putting it in various sandblasters and replating, things like that. That is what you could get out of it, which is, you know, basically you're creating a brand new breaker at that point. And some of these older breakers are very well designed. So, you know, they're made of steel, and so this process works very well on them. An interchangeable replacement circuit breaker. So this is a circuit breaker that uses all new parts and requires no conversion of existing switchgear to maintain proper operation. So in this case, this circuit breaker can go into the switchgear cell of an existing circuit breaker, and you don't have to change anything. So it's a very simple, rack out the old breaker, rack this one in. You could even use the old breaker as a spare, or send it off to be reconditioned to have a spare on the site, but it gives you a brand new breaker with brand new technology. And then there's the next terminology is a retrofill. So this is a conversion process that includes replacement of the circuit breaker and the circuit breaker compartment. So unlike the previous one, this is not backwards compatible. You're going to change out the cell in the switchgear. You're going to put in new technology, and you can see here from the left to the right is the picture of before and after. So you get a brand new breaker, new cell components, but you have no backwards compatibility at all to the old breaker. And the advantage of this is you get all the new technology, the through-the-door design, easier to maintain, things like that. So the key word on there was qualified design. So we do see a lot of people out there doing these type of retrofills, but there is inherent issues that need to be confirmed when you do a retrofill. So just because you're putting in the new breaker doesn't mean it has all the same characteristics of the old breaker, specifically heating. So you want to make sure that when someone is doing this, they have looked at it from a design standpoint and making sure that it has been verified, that it is going to work in that particular application. And the next terminal, so basically this cell goes into the cell, goes up into that compartment, and then now we have a horizontal breaker, which is what you see today, that goes into that cell, and it operates just like a normal horizontal breaker, and you never have to deal with that vertical lift mechanism again, which is got a lot of inherent issues with it. And there are a ton of these out there. Power plants, anything with a G turbine probably has a ton of those in it, so. And then in conversion, so this is the process of altering existing power switchgear equipment from a qualified design. So this is a solution that we do a lot, and there might be probably some slides in a later presentation talking about this as well with arc flash mitigation. So again, this goes back, Tom touched upon this a little bit on his, the most dangerous part of a, see, does this have a little laser pointer on it? The most dangerous part of a unit substation is this secondary of the transformer. This is, again, just like Tom indicated before, when there's a fuse there, you're working with the protection of that fuse that determines the arc flash incident energy on that low voltage side, which is going to be extremely high. So the solution is to retrofit or do a conversion. See, I even used that word wrong. Use a conversion to convert that fuse to a circuit breaker. And we also add current sensors to the low voltage side. So it kind of looks like this. So you have your original medium voltage switch, and instead of a fuse truck, you have a circuit breaker put in there, controls and relaying. Here's another picture of one. Again, the switch with where the fuses would go. Now you put a circuit breaker, and you can see this is kind of a diagram of what it would look like for your substation. And in this particular instance, if you look at the incident energy calculations, so before it's at 185, which is unapproachable, and now afterwards we have it down to 1.4. So it's a significant safety issue. Sure, many of you have done designs of unit substations like this. They're all over the place, from water treatment plants to almost every single customer has this type of design unit that was very prevalent. So. And just a little extra on this, there is an issue caused by putting a vacuum breaker where that switch is in front of the transformer, depending upon the transformer design. So we do recommend looking at putting in a snubber to dampen the chop current caused by the vacuum breaker, which might damage the transformer. So. That's kind of that before and after slide again. So design verification. So this is another term that's defined in C37.59. So this is a process of design qualification in accordance with appropriate standards. So design testing is very different from production testing or preventive maintenance tests. So another tactic I've seen do by some companies is they will do one of these conversions and they will test it to like NEDA ATS. Well, that's not acceptable. It needs to be more of a production type test. NEDA ATS is a maintenance standard. That's not a valid test for verifying the operation of something that you've done complete design change on. And again, this is a breaker, interchangeable circuit breaker. This is a medium voltage one. And you might hear these called roll-in replacement circuit breakers. Again, this is take out the old circuit breaker, rolls right out of the cell. You can roll the new one right in its place. It's still reverse compatible as well. And air fuse contactor. So what you find, especially, does anyone call a lot on utility generation plants? Not a lot of utility here. So you see this a lot in utility generation plants where they are using circuit breakers as motor starters. A lot of that has to do with that the fault current in the power plant is very, very high. So the contactors back in the day couldn't withstand them. So they used circuit breakers for motor starters. But when you use a circuit breaker for a motor starter's made to operate many, many times a day. Circuit breaker's not really designed for that many operations. So this allows a solution to that problem where we actually change out that circuit breaker into a contactor-based configuration to give them those kind of operations so they're not wearing this equipment out. And again, this is another example of the non-interchangeable circuit breaker. So requires the conversion of existing switchgear to maintain proper operation. That conversion might require installation of a compartment adapter. So, and the last term is remote racking. So racking is defined as well. Remote racking devices have become very, very popular. Sometimes you'll hear it called levering. But these devices are available. So again, you can remotely rack out a circuit breaker and take the operator out of the arc flash boundary while that's going on. And I'm sure you're aware that new equipment, some of this is integral to new equipment as well. So yeah, I got us back on target for lunch. So key takeaways, switchgear modernization offers options that can be more economical and faster than a replacement of switchgear. If you're going to spec one of these solutions, ensure the switchgear modernizations conform to IEEE C37.59 and make sure design verification is completed to applicable standard, not maintenance standards. Questions? I bet I went too fast, huh? Okay, thank you.
I was just going to say, I just went out and checked real quick. So they're just now bringing out the actual lunch items. They had to do a whole bunch of setup there. So they're just now bringing it up. So if you give them 2, 3, 5 minutes tops, everything will be out. Hot stuff will be hot, cold stuff will be cold, and we'll be good. So be out there in a couple minutes. What time are we back?
We'll plan to resume at 1.
Back at 1. We got plenty of time.
Yes.
My whole career.
Testing, testing. All right. We got to give you a mic.
The second half you haven't seen.
I'm going to give you a mic, okay?
Okay, good.
There we go. Look,
Thank
it
you.
even looks good.
Huh?
You got your food, right?
Yeah, it's over there. It's on that table. Yeah,
She came to ask.
yeah. I had mentioned it to her, but I got it. Yeah. Say when? 1 minute? I know this is the first one after lunch. Everybody's going to snooze on this thing, but let's see if we can keep you awake for a little bit. My name's Glenn Hanley, and I'll do the first half or so of this, and then I'll hand it off to Kevin. Arc flash, everybody knows what that is. At least in principle, we know what it is. All right, let me just get through these first. There we go. We're going to cover all of these in a thorough enough way that you have an appreciation. You guys can do the math. You can figure out how to calculate arc flash. I'm not going to go through teaching you how to calculate arc flash. But what we are going to talk about is what are the implications of it if it's done right, if it's done wrong, and if you have issues, how can we mitigate those things? So we're going to cover a broad range of things. Who needs to be concerned about it? Power system engineering study implementation, arc flash studies and OSHA requirements, discussing two philosophies regarding mitigation, and how do you fix the problem. These things are intended to be rolled into your everyday work. So the consideration is there, you think about it, and you express with your through specs and your artwork. You figure out how to make sure that everything's safe, because we all want to go home safely at night, and you don't want to be a piece of that issue. You want to make sure you always think about that. Owners, now this is interesting. A lot of people care about it, but I just want to make sure, because some of these people are sitting in this audience. Owners and facility management, design engineers, power system engineers, inspectors. Inspectors love this, right? Personnel who work on or around our electrical equipment. We do have maintenance people here. So all of these things, all of these people have a vested interest in arc flash and or how to prevent it. I'm sorry this is so small. Arc flash, it's just basically a definition. It's the light and heat produced when a thermal expansion of gases. When I talk about expansion, it's essentially a bomb going off. And what we need to appreciate is copper vaporizes and suddenly expands at a factor of 67,000 times. I know you can't understand what that is essentially, but think of it as the concussive blast of a bomb is right in front of someone's face, all right? So they get hit with a concussion, their hearing goes, eyes, you easily, the burn, right? We talk about temperatures of 35,000 degrees Fahrenheit. All of that ionized gas expansion blows the person back, lights them on fire, does nasty, nasty things, and I'm stopping there. You can get the picture. We cannot allow that to happen. Damage and injury results from burns from being hit by parts of the switchgear. Literally, it will rip off pieces of metal and plastic and other things that are in there. So there's just any number of reasons why this is the worst possible thing that can happen. And we do not want this to occur. All right, how does it happen? The usual, right? Animals get in there to stay warm. Bad electrical connections, everybody understands, heating and cooling and things of that nature. Test probe touching the wrong surface. Now you'll notice a trend here, and I'll mention it in a minute. Dropping a tool into energized gear. Energizing gear after maintenance left a tool in the gear. Other sources of human error. That's the point. If nobody ever touches this gear, if it's just sitting there static, aside from maybe a tree or an animal, it's not going to just blow up. We kind of know that. What happens is there's human intervention that causes these things to happen, either through negligence or sometimes they just didn't know that they left a tool in there, again, negligence, and they walk along and they flip the switch and it immediately blows. So the issue here is right there. 65% of the time when there's an arc flash, there's an operator doing energized work with the doors open. It's just scary. I can't put it any other way. Yes, 10% of the time when operators in front of the gear and all doors are closed, well, that's the idea of dead front. We know that helps. 25% of the time there's no operator present and all the doors are closed. So there is an opportunity for an animal or some other things. So it could flash when there's no one there. But statistically, 65% of the time there's a human involved. All right. IEEE 1584 is the standard for guiding how you calculate arc flash. And as I mentioned, I'm not going to go through the math for you. If you want those equations and don't know them, I can get them for you. That's not a problem. So here we have a revised 2018 version of the IEEE 1584 warning label. There's a lot going on here, okay? For those that can't read the small lettering, limited approach boundary, restricted approach boundary, glove class, very important. So those numbers are important. There's report numbers on there. There's the switchgear name. This label contains a lot of information. As you get if you don't know what's on that label, there's plenty of places to find out what's supposed to be on there, and it will be in the presentations that you get. So you can get a better look at this thing for those that aren't comfortable with it. Let me back up a minute. 1584, first published in 2002 based on about 300 live arc tests. The 2018 version is the most recent, is based on about 2,000. So there's a lot of refinement that went into this, and there were a lot of updates that 2018 brought in, and Kevin will talk about that in his segment. I know you can't really read this, it's sort of a terrible slide, but what it's basically saying is, this is the OSHA safety side of business. This is the electrical, NFPE 70E 1584. So this is the standards and practices that allow the safe operation of gear related to practices. So that's an interesting that so much feeds up into the standards, and then you have the OSHA 10 CFR standard. Okay, so we'll get into this a little bit. 2018 was released or published on November 30th, 2018, supersedes the 2002 version. NFPA 70E 2018 still references the old 2002, but encourages users to use the most recent version. So if you can get your hands on, and if you can't, I will help you get some information that's contained in 2018, but we'll go into some more details on what those changes are. Okay. 125 kA transformer exception that was in the old version has been replaced with a statement under 2,000 amps at 240 volts. We'll go into this, so don't worry too much about this. Addition of bus electrode configurations. This, let me try this. You'll notice there's 5 versions, and I'll do a little bit of explanation on these, but these 5 versions here are from 2. They've added 3 more. We'll get into that in just a minute. Oops. Oh, okay, so box dimensions, you're right. So these are going to be related to this right here. We're going to actually talk, much more talk now about the enclosure sizes than there was before. Okay, updated calculations. Okay, if any of you don't know what it is, a lot of the old was based on this thing called the Lee equation. That Lee equation was the standard, in quotes, but the Lee equation left out a lot of very important stuff. It was a great way to get this whole conversation started and really get people going. But the Lee equation has been shown over time to have left off some considerations that should have been in there. So the Lee equation is still accurate, just not quite as all-encompassing as it should have been. So it has evolved beyond just the Lee equation. Here we go right here. System grounding is no longer considered, okay? So that's interesting. And also, no support for single phase, okay? So these things, you'll see these again. So keep those terms in your mind as we move through this thing. Okay, accurate data collection, that's obvious. Calculation of bolt, let me get my thing here. Calculation of bolted fault. Electrode configuration, those are those letters that I showed you a minute ago. We'll talk more about that. Incident energy, this is what you're always doing, right? Calculation of final incident energy and arc flash boundary. So you're still doing that, but there's going to be a lot more to consider. It used to be very easy. Now there's a lot more to consider, and we're going to show you that. Oops. Oops. And oops. Okay. A little bit of comparison. 2002 was 240 with transformers less than 125 kVA, need not be considered. Now, 240 or less with available short circuit of less than 2,000 amps, sustainable arcs are possible but less likely. Possible but less likely keeps creeping up. We'll show you again. What does this mean? Okay, so you have the red, I don't know that you guys can read this very well. If you can't, this right here, this is 75 kVA, 112 and a half, 125. So this is the red zone here, right? There's still possibility of exception for locations with faults less than 2,000 amps. The language of possible but less likely requires risk analysis by the customer. Possible but less likely means you can no longer just disregard it. It now has to be considered. So, so then what we're talking about here is this 75 kVA. So this 125, it is possible but less likely, even below the 125. So all of these need to be considered now. Not used to be you could just disregard it, no longer. 208. Okay, so 208 obviously falls in there in the 240 system. Large portions of many 208 systems can no longer be excluded for arc flash incident energy analysis. More, if not all, 208 systems will need to be analyzed as part of any arc flash analysis. Okay, here we go. End user has the ability to conclude that locations with less than 2,000 do not need to be analyzed by performing a risk analysis. Calculations are required to determine the available fault current. So it used to be you could just pass it off. No, don't need it, don't need it. Yes, you do now. So your jobs in calculating arc flash energy just got more involved. Okay, here we go. So we were talking about these codes, and I'll show you this picture of it here in a minute. So VCB, vertical conductors inside a metal box. VOA, vertical conductors in open air. So that's kind of what the VOA. Now you've got vertical conductors terminating in an insulating barrier inside a metal box. Horizontal conductors inside a metal box. Horizontal conductors in open air. I know it's confusing and it's a little involved, but that's what we're talking about right there. Oh, let me, don't know why my lettering didn't show up, but okay. So vertical in a box, vertical against a barrier in a box, horizontal in open air in a box. So that's visually what we're talking about right there, okay? So, and again, those 3 green ones are out of the 5, those 3 green were added in 2018. And so interpreting what the gear looks like, that is now, there's a visual that you have to understand the gear itself, where that never used to be an issue. What do we got here? Studies are now more complicated. Oh, yeah, so this is what I was talking about here. General industry confusion on HCB configuration. When should it be used and when it shouldn't be used? So HCB is this one right here. Oops. HCB, is this one, horizontal conductors inside a metal box, which is that one right there. So anyway, again, it's important that you understand the actual configuration in the box. And before, that might not have been a concern. It might not have been something you ever thought of. I have no clue what happened to my labeling. Open air and vertical and horizontal in open air. So you can see that. Okay, arc flash boundary considerations. This boils down to this right here. Multiple arc flash scenarios, each equipment location as well as the system. So it's critical to understand the configurations. That was not normal before. It was not something that, I shouldn't say it wasn't typically thought of. Now it is a requirement. You need to think of those things. You must understand how to review the arc flash generated from software packages to ensure the accuracy. So again, if you're using an existing software package and you didn't think of the orientation of the conductors, you might not really have an accurate analysis going on. Electrode configurations must be selected by the engineer performing the study. Input from the manufacturer may be limited. So again, we say expertise is critical. That's you guys. So again, this isn't to scare you, it's to make you aware. Just be aware that that these studies now require just a little bit more attention to detail. We'll just leave it at that. Significant impact on incident energy for those different configurations. Correct electrode selection provides correct analysis results that's used to produce arc flash labeling. That label is the end result of what you're doing here. Qualified electrical workers depend, and this is where I want you to appreciate. Qualified electrical workers depend on that label to accurately select the protective equipment. If that label either is incorrect or not paid attention to, they could be in front of gear that's much more dangerous to them than they originally anticipated. So we're looking out for the innocence on that line right there. Okay, not a whole lot here, except for in blue I highlighted 15 kV MCCs is now a class of equipment to look at. 5 kV switchgear, the actual enclosure dimensions. Well, it was always in there, but now you have to understand the actual enclosure dimensions. 5 kV MCCs, shallow, low voltage MCCs and panel boards. So I hate to say it, but what used to be a relatively short list is now getting longer. So your work is going up, and that's not a, shouldn't say it's not a good thing. It's just more work for you. Okay. Equipment class used in 2018, typical working distance, typical bus gap. And again, we talked about it. You have to understand your enclosure sizes. That was not a part of 2002. Actual enclosure dimensions and bus gap in lieu of distance factor, height, width, depth, and bus gap. So again, it's all about what does the actual gear look like? What's the orientation of the conductors? All of these things are important now, and they were far less pushed on the earlier version. Studies are now more complicated. Hopefully you guys can get to the standard and read it. So you'll be able to see some of these things. Measure actual values, more data collection modeling equals higher cost to perform the analysis. Yes, but also higher accuracy. Eaton recommends consideration of both options above to determine the scope of work. So basically, yeah, we call these options, and certainly they are, but there's no industry consensus. So just all I'm saying is do your job well, and you can rest easy at night. But again, height, width, depth, bus gap. So dimensionally, it's all becoming quite important. So we want to stress that. That's essentially the same thing. We were talking about this 240, or in this case 208, fed from 125 transformer can no longer be excluded. So there's a couple numbers in there that you want to commit to memory. And now we're at 5 bus configurations where we were at 2 earlier. Yeah, so the software that you guys probably use to do some of that. Anyway, the studies are getting more complex. Engineering firms need to work well with multiple software vendors and understand applicable standards. I mean, that's just what it is. We would suggest become a member and get involved in the working group. Those of you that are interested in doing what you heard Tom talking about earlier, this is good stuff. If you want to get in there and learn more about this and contribute, we'd love it. We'd love to hear those things. Create and present papers on 1584. So those of you that eat, sleep, and drink this type of stuff, there's a place for you. There's a lot that needs to be explained. There's a lot that needs to be understood. And these things have only here recently, people are starting to realize that this 1584 is a different animal than it used to be. So what we're saying here is basically from most effective to least effective. And all we're really trying to say on this is elimination removes it, it's done. The most effective thing is don't have any chance of arc flash, right? If that risk can be eliminated through redundancy or outage, complete outage, you're good to go. Or of course, under 24 volts. Sometimes substituting the hazard, for instance, arc resistant switchgear, which we'll talk about here shortly, through the door voltage absence devices, high resistance grounds. So there are ways, now we're using a term mitigation, right? That's kind of where we're going on this, minimizing, and then we'll go even farther. All right, a little less effective, but still good, engineering controls, remote operators and racking, ARMS. In this particular case, arc flash reduction maintenance system. So this is a system, and Kevin will talk about it. This is a system that is voluntarily turned on. You do your maintenance, and then you turn it off before you energize or turn the gear back on, and it creates quite a safe environment for the operators that are working in the gear. Arc quenching gear, we'll talk about that a little bit. Again, these are going down in least effective. They're not useless, but they're certainly less effective. You always want to have good work policies, safety procedures, training, risk assessment, all those things. Push that stuff, train the people. For those of you that work in plants, train the operating personnel, hold them accountable to acting on the training that they have. And that's all great, but you know what? It's not a cure-all. And protective equipment. There are some protective equipment in one of the displays out there for those that haven't seen it. This is a great thing, except for the fact that in really bad cases, you're wearing what a lot of terms, people call it a bee suit. You almost can't work in a bee. There's almost times where the bee suit seems to be less safe than if you didn't wear one. For the fact that you have big giant gloves and you really can't feel anything, you really can't see anything, but it is there. It is good PPE to have. So at this point, I've brought up a lot of these mitigating things. Kevin will take it from here, but all I can say is please appreciate arc flash is one of the worst things that could ever happen to a human being. I have seen it with my own eyes. I've interviewed people that have been victims of arc flash. I don't want any of you to ever have to deal with that. So please take arc flash very seriously.
Get myself mic'd up here. All right, so with all that said, what can we do? What steps can we take in designing and preparing to minimize our risk with the electrical equipment? First, obviously label the equipment and train personnel with good safety practices on site. Glenn talked about the arc flash hazard label, which, gives you all the detail on the PPE requirements, the arc flash energy, the boundary, limited approach, restricted approach, prohibited approach. Second, we talked about reducing the available fault current and shorten the clearing time. One method to that is a HRG unit, a high resistance ground unit. Ground faults are up to 70 times more likely to occur than phase-to-phase faults. It does not reduce the arc flash exposure or preclude using PPE, but it can help reduce the probability of an arcing accident. Limits the ground faults typically to 5 to 10 amperes. Pulsing contactor allows for fault tracking, available for low voltage or medium voltage, and then also not allowed per NEC for 4-wire systems. 240.87, it's all about time, right? So non-instantaneous trip, where a circuit breaker is used without instantaneous trip, documentation shall be available to those authorized to design, install, operate, or inspect installation at the location of the circuit breakers. Where a circuit breaker is utilized without an instantaneous trip, one of the following equivalent shall be provided: zone selective interlocking, differential relaying, or what we call ARM switch, an arc reduction maintenance switch. That's 2011 NEC. Now, updated in 2014, arc energy reduction, where the highest continuous current trip setting for which the actual overcurrent installed in the circuit breaker is rated can be adjusted to 1200 amps or higher. 248.7A and B shall apply. A remains the same. B method to reduce the clearing time, one of the following or approved equivalent means shall be provided. So zone selective interlocking, differential relaying, energy reducing maintenance switch with local status indicator, energy reducing arc flash mitigation system, or an approved equivalent means, remote operation, arc resistant gear, light sensing. It's always evolving, more on the following slides. So zone selective interlocking, we go through an example of zone selective interlocking. So without zone selective interlocking, 0.5 seconds, 35 Ka fault, 43.7 calories per centimeter squared, greater than category 4 PPE at that fault location. With zone selective interlocking, you're at 0.08 seconds to clear the fault. 35 Ka fault, it's 7 calories per centimeter squared at category 2 PE. So you'll see the effect that a zone selective interlocking scheme can provide on this circuit. But wait, there's more. Differential relaying, kind of a good, better, best scenario we're going to run through on these slides in terms of technologies. So it recognizes the fault within the zone of protection, between these CTs, there's your relay, then your relay recognizes the fault, it responds typically with no delay, and then trips and isolates your fault. Reduction in time can significantly reduce the arc flash without disrupting selective coordination of your 5051. The one disadvantage is when compared to the zone selective interlocking is it can be costly, right? You got CTs for each incoming and outgoing breaker, and then you sum them all together into your relay, and then you take your relay to a lockout relay, and then the lockout relay trips and blocks your breaker from closing. And not an effective solution overall in the low voltage world where you've got zone selective interlocking as an option. The third option is the arc flash reduction maintenance switch, so ARMS. When activated, pickup setting, total breaker clearing time are reduced. Our maintenance mode switch is faster than instantaneous. It bypasses all microprocessor delays. So it's a separate setting, it's a separate trip circuit. Total clearing time in 40 milliseconds, low voltage power breakers or medium voltage breakers. Normal settings, would, for example, would be 10.7 calories per centimeter squared, but with arms, it's 2.2 calories per centimeter squared. Other clearing time options, energy reduction, arc flash mitigation system, other remote operation, arc flash switchgear, arc eliminating devices, substation primary breaker or vacuum fault interrupter. We'll go into some more of these in the following slides. Multiple relay settings groups similar to ARMS, arc flash sensing relays. So light sensing relays like a Schweitzer with the fiber point sensors and fiber loop. Scott stole my thunder a little earlier on his not retrofit conversion example of replacing a fuse primary switch with a switchover vacuum breaker. Your switch still gives you the visible disconnect. Your breaker's a fixed mounted device. This is a VCPT breaker in our scenario that has the capability of having an integral trip unit, and then you can have a separate trip unit on the front door of the gear. So you can have current sensors on your primary wired to your integral trip unit, and then you can have a set of CTs on your secondary side of your transformer bushings wired back to your separately mounted relay, or vice versa. You can do it either way. To reduce that incident energy at the secondary side of the transformer, because we talked about that 2 or 3 times already about how the secondary side of your transformer is the highest point of your highest risk of incident energy during a substation scenario. VFIs can also cover transformer primary thermal protection. A vacuum fault interrupter can be installed in substation or pad mount type. Secondary mounted MCCB at the transformer ATC, because again, if you're mounting the secondary MCCB at the transformer, you're reducing that length, you're reducing that distance from the MCCB to the transformer, thus reducing the incident energy by reducing the time it takes to operate. Consider vacuum circuit breaker metal enclosed on a dry type sub. And again, as Scott mentioned earlier, that we do recommend the snubber circuits on those breakers, on the load side of those breakers, when they're in close proximity of some transformers, because of the chopping that can take place. And then utilizing multiple settings groups in protective relays, similar to low voltage maintenance switch, only for medium voltage application. So used to reduce the trip delay in medium voltage relays. Most modern microprocessor relays have multiple settings groups, such as our EDR relays. This is just a pictorial example of a maintenance mode switch. Arc flash sensing protection, so the arc flash relay with the CTs and then the fiber sensor. So the arc flash relays looking at the current, while the point sensors looking for a flash of light. And when those two things send an alarm, that relay senses it and sends a fast trip signal to the breaker, so that you don't get a nuisance trip if it's a normal operation scenario. Obviously, the faster it trips, the less damage to the equipment. These systems do not provide functionality of arc resistant switchgear for personnel safety unless they are paired with an arc extinguisher device, typically 3 to 5 cycles. 2017 240.87 method to reduce clearing time. One of the following are approved equivalent means. Again, zone selective, differential, arc energy reduction maintenance switch, and energy reducing active mitigation system. And a couple of my points aren't showing up again on this slideshow. But again, it's, sorry about that. Oh, it's the green, an instantaneous trip setting that is less than available arcing current, and an instantaneous override that is less than available arcing current, and then approved equivalent means. I don't know why they're not showing up, but instantaneous override trip, again, when arcing current is greater than instantaneous override trip or override, no additional technology is required, only applies to UL 489 breakers, typical in switchboard panel board applications. Another category of methods, again, another method, move people further away, right? Remote operator panels, remote racking devices, integral racking, breakers, auxiliary drawers, anything, when if a fault's going to occur from an operational standpoint, if somebody didn't leave a tool behind, it's probably going to happen when you're racking something in and out potentially. So get the operators out away from the gear when you're racking those devices. Another method, arc resistant switchgear. We redirect that energy into another location. So the standard that covers that is our C30 is ANSI IEEE C37.20.7. It's the guide for testing metal enclosed switchgear rated up to 38 kV. Gives testing guidelines for conforming arc resistant capability with metal enclosed switchgear. Manufacturers are given significant latitude in how their assemblies can be tested. New guide and development will address low voltage and medium voltage MCC switchboards, and I'll say gas insulated switchgear. There's a picture of arc resistant switchgear. That's the plenum above the gear. The gears here, plenum, the arc duct, the exhaust duct coming out. These are fiber indicators here. The test is successful if none of the indicators burn during a fault event. Doors do not open. No projectiles greater than 60 grams come off the equipment. Lower than 2 meters. No holes are burned in the enclosure at a height lower than 2 meters, and all grounds remain intact. Here's another image of a medium voltage MCC with a medium voltage drive and the arc exhaust coming out the top there. 37.20.7 section 4.3 gives preferred arcing duration rating of 0.5 seconds, but allows for a rating of as low as 0.1 depending on the speed of the main protective device being used during testing. 37.20.7 allows for use of protective device relays, schemes, zone selective interlock, and other fast-acting mechanisms to limit the arcing energy by shortening the duration of the event. Location of the arc initiation has a tremendous effect on the enclosure's ability to contain the arc energy and or channel it away from the operator. Again, these are all methods, different products with arc resistant assemblies within the manufacturing world. Again, these all are redirecting the problem, not necessarily solving the problem, but keeping operators out and around the gear safe when the doors are closed and all that. Another solution is the crowbar. So you're going to create a bolt and fault inside the gear, basically, to once it senses a flash. But the potential issue with this is, unless it's done right, obviously it can damage the upstream equipment. Which brings us into the arc quenching switchgear solution, which reacts over 10 times faster than systems that rely on opening breaker to clear fault, like ARM, CSI, arc detection relays, bus differential. Got a good slide kind of showing that later on. Reduces incident energy more than previously mentioned options, may lower PPE requirements, decrease arc flash boundary, greatly reduces and eliminates damage to the switchgear for minimum downtime of the arc flash. So think about that. You have a bolted arc flash inside the gear, and this quenching device clears it in such a way that your downtime is a matter of hours instead of days, months, years, if you got to replace the gear at this point. Protecting your switchgear assets in the meantime. Obviously third-party tested with the C37.20.7 arc resistant test guide. No plenums, no ducts, no special construction, just this quenching device in the switchgear with the point sensors wired out, and no plenums. Exceeds arc resistant test requirements by demonstrating acceptance when breakers are removed and doors are left open. Always on, so this thing's always active, always monitoring. Once it operates, it's a replaceable device. You have to replace the whole device. You could still use your equipment without the device, but you don't have the protection that device provides until you get the replacement, and you can rack the replacement in when it's energized as well. And then 44% less stress on upstream equipment and cable terminations during arc fault. And then technology avoids nuisance trips. So basically what happens, arc flash is detected by light sensors and CTs. The arc flash relay verifies the light is from an arc event and not from normal ACB operation. The arc flash relay sends 2 signals, one to trigger the arc quenching device and one to trip the main breaker. This all happens in less than 4 milliseconds. The arc quenching device quenches the arc and contains the arc energy inside of the device. Then up to 67 milliseconds later, the main breaker trips open and de-energizes the lineup, protecting the gear from any further damage. That's just kind of a figure showing. So what they do in this technology, this is the quenching device. It's your A phase, your C phase, your B phase is tied together. We've got this loop that the magnetic, once it senses a fault, the magnetic polarities magnetize and cause this thing to create a low impedance fault inside this device. And that's where the energy gets redirected during that time cycle that we talked about. And here's kind of a graph kind of showing, your different solutions. So arc quenching switchgear operates here in less than right there's 5 milliseconds. It's kind of hard to see, but 4 milliseconds, that's where your arc quenching device operates. This is where your peak pressure sine wave. This is where arms. This is where a maintenance mode switch operates. This is where arc detection, with fiber and then bus differential. This is where instantaneous trip, and this is where zone selective interlocking, all those operate, and you see the kind of damage. And here's kind of how that translates. Typical results always perform an arc flash study, obviously. 480 volt, 85 KA available fault current scenario. Right here is 1.2 calories per centimeter squared. So that's a threshold of second degree burns without PPE. Arc quenching 0.7, arms 5.8, bus differential 9.1, arc detection relay 9.1, software instantaneous trip 10.2, and then zone selective interlocking 12.3. Maybe the best solution overall, prevent the fault, right? So steps you can take in preparing the equipment to try to avoid any type of fault. Obviously monitoring transformer bushings, capacitance, power factor, this bushing insulation monitor. Partial discharge monitoring, we've got an InsulGuard demo out front. Kind of go through that, insulating the bus, IR scanning, do periodic scans of the joints. Only way to scan IR scanning without a utility shutdown with the ports in the gear. Line side service disconnect, it's almost always going to be 40 calories per centimeter squared. On a service entrance main, utilize hinge gutter for group mounted feeders on all sections with switchboards. Dead front liquid substation transformers with the gauges, the low brake switch handle on the front, insulation, right? Epoxy shutters, isolation barriers in the gear, insulate a bus, cable boots, bus boots, This is a metal enclosed versus a metal clad option. It's metal enclosed with fluidized bus. And then continuous thermal monitoring again. And in summary, basically, solutions that reduce arc flash injuries and equipment damage. We want to take a total system approach, from looking at your arc flash study, doing the calculations, figuring out where you land, label the equipment properly, minimize risk, train personnel, and proper safety practices, reduce the available fault current if you can, redirect the blast energy, faster clearing time, move people further away, and minimize the probability of faults occurring in the first place. Any questions? Yes, sir.
The more the focus becomes on enclosure size, you're talking about different bus configurations and the size of the enclosure, the larger the enclosure, it seems to lower the incident energy. We have a piece of switchgear. The switchgear may have maybe 90 inches tall and the sections maybe 3 feet wide, 4 feet deep. But the busing and the connection points maybe in the back half of that. So what is the proper size you should be using for each of those enclosures?
The proper size for the enclosure or the proper size of?
Box. When you're plugging it into, we're plugging it into a model. We're looking at a dimension. I mean, I can look at the shop drawings that come in, and the shop drawings may be 4 feet deep and 3 feet wide, 90 inches tall.
Mm-hmm.
But the busing, there's the front door, there's the dead front portion, which
Right.
is really part of that.
Your concerns in the rear of the gear where the bus is,
I
yeah.
want to take advantage of his, the correct box dimensions, because if I use the default, it's tiny. But I don't want to overestimate. I don't want to say, if I'm not allowed to, that if it's 4 feet deep gear, but all the live busing is sitting behind a barrier that might.
12 inches deep.
Yeah, some further to the back. So I'm looking at, is there a industry standard instruction on how you define what that box dimension is?
It's probably specific for the manufacturer that's involved to some degree, because we all have some variances in our enclosures.
Well, is it, I mean.
And depending on the product too.
I'm trying to find my way through this, and the last exercise we went through, we took the enclosure size of the switchboard. And I'm concerned that that's not really the size I should be using, because the live parts where the arcing occurs a foot back from that. So it's could be a smaller box, which means the incident energy may be larger than what I'm modeling. I don't know if anybody else has that.
That's a good question, Glenn. So the question that he has is regarding with calculating, how do you determine the enclosure size, the proper enclosure size for the incident energy calculation, because in your example, your busing and your cabling is maybe 10 inches, maybe 12 inches from the front dead cover of the equipment that you're working on, whether it be a switchboard or whether it be a piece of metal clad switchgear, right? The answer to that, I'm not real sure myself. I would imagine that it's different depending on the manufacturer.
Is your question, how
Can be specific.
The box size?
How do we confirm we're using the proper size? I know the instructions are somewhat general.
Yeah.
But I know we went through them, SKM, for instance, they will give you a default box size. It's like 10 by 14. It's tiny. And then the incident energy is massive. Until you start looking, okay, well, I don't really need to use that. I need to use what this switchboard section might be.
Right. So against the barriers, dead front, and the exposed cable or exposed lugs, that is your volume. So though you want to use those real numbers. That's what I was talking about on mine, was where you used to be able to use a generic assessment. That's gone now.
Yeah.
You have to actually know those dimensions.
And then there was a point here where there was a point about minimizing or mitigating some arc potential or incident energy potential. There's a point about insulating barriers. You know, most of the gear I've been inside while de-energized, you see the plastic, maybe some plastic barriers, if you will, between sections, but there's no strength to that. It's not a full metal front to back barrier. So
Right.
I'm assuming that doesn't play any role in really minimizing incident energy, and I'm certainly
No.
not going to,
No.
you know,
No.
if I got 3 sections of switchgear or switchboard, I'm not treating each one necessarily. I'm going to model the box, probably can more conservatively than I need to by looking at the individual section, but the arc can propagate from section to section.
Those interface barriers are going to minimize the likelihood of the arc propagating between phases. Somebody dropping a tool between and hitting 2 pieces of,
I'm even thinking sections.
Yeah,
Like there's
yeah.
oftentimes a section where you see a big piece of red plastic sitting from top to bottom, but it's tacked together, but it doesn't have any strength to it.
Mm-hmm.
If there's an explosion, it's not going to prevent
right,
propagation.
right.
And one final question, I've had a conversation with some electricians, and they talk about, there's the incident energy calculation, there's the arc, and then there's the gas that could be, that's flammable, where you could propagate. Is that even part of this calculation, these standards? Is there a risk? How could you even predict where that gas might go in the event you have an explosion?
In
You can't.
right.
You can't. Gas is gas. It'll fit through any.
In standard
But
gear.
it doesn't last very long. That's
And
the other thing. It's not like it's going to keep floating around and move over here.
I get it. I guess there have been clients that have asked us, can we, if you're running the first section, service entrance section, for instance, that might not be the best example because that may have a full metal barrier. Let's say you have a 2,500 kVA pad-mount transformer, you got a 3,000 amp main, but it's your own gear, it's not barrier completely, and they want line side, load side labels on the equipment, but I say that you really can't distinguish between the two, and it has to do with how far the working distance might be and where you are in the adjacent sections. So from a conservative perspective, we're just putting the same label on the gear based on the worst case scenario. Is that?
Right. You always want to do worst case scenario. That's right.
Now,
If you start trying to slice and dice that, then you don't have enough detail to do that. The science of it won't allow you to do that. You want worst case scenario. Overprotection is better than underprotection.
Yeah.
Think of it that way.
I would say arc resistant switchgear, the whole purpose of the arc resistant switchgear is to redirect those gases and funnel it into a safe location. So in that scenario, we do know where those gases are going.
Yeah, we direct it, but how quickly they move and things like that, that's not something you would ever know. So, in fact, don't try not to get hung up on that because it's too hard of an answer to come up with. But there are mitigating means that know that it can work with the gases wherever they're. Anything else? Thank you for your time. Oh, sorry, go ahead. No.
The orientation of is that at the point at which the light breaker connects the bars, or where is it?
Could be the bottom of the breaker, sure. That lug connection at the bottom, or cable connection at the bottom of the breaker. Sure. It's, again, and there's no way. Your job is a lot harder. And these are extremely good questions. This is all new, our fairly. We will help you find it. But it's all. Can you contribute anything to the new 1584? Yeah. No, I that's what we described. You're talking about
Anybody do there's a column right there. I think I got everybody.
Got together and looked at all our, to try to determine how do we identify cameras, right? Motor sensors,
when you get a switchgear,
This is for the
it depends on the entry into the compartments and whether or not there's a yellow bus or a bus.
It's off.
Right, yeah, it's where you're letting the workers at, how much energy they're going to consume. Yeah, so point of entry into that equipment will determine whether or not you're at a vertical or horizontal bus. And then, you know, with the barriers, right? So, but what our gear guys did is basically try to come up with guidance. So if you're in a local facility, if you're in a local, equipment, depends on where you're at, get in. You gotta take worst case, because you, as an engineer, we don't know. You know, so it's challenging.
That helps? Thanks. Jack, that's one as well. Yeah. While you're on. Sure. Generally, like this would be one count of work. Like generally, DCB or DCBP, is your main conductor for your vertical bus. But I know in the 84 standard, if they're calling out, they're going to use gangs. It's actually a photo in there, HSD printer, and it has all the terms.
I've already made that. And I know exactly what it goes. Usually now it's going to be available. It's horizontal. It's not, right? So we got to think about that are always flow away from the source. Okay? And when you're looking at that bus, whether it's on that grader or on the bus itself, that flows to this way. It's not going to come down, say, oh, I'm going to go to the turn, and then go down. So there's a lot of interest in straight down on the bus. Even if you have a fault on the location of that breaker, you're going to create a class of 3-phase imaging cycles. And if the breaker can control this phase, but that is a very confusing part of actually. They show the picture and they say, yeah, it's more or less.
But that one you can separate.
Exactly. That's the information.
I also, if you have a second, follow up with his question on the last line. I think he was asking basically, if I'm going to put my 90-inch high switchboard, I'm trying to do a calculation, put it like if I put it 90 high there, like SKM, look at it, it kicks out that it has the maximum tested ranges of 1584.
Yeah.
And then it takes me back to the equation.
Yeah.
There is some maximum between what my actual lot size is and what the standard tested. I don't know quite.
Are you sure it's the box size or is it the available fault current that kicks you over to roughly?
I think it's the box.
Because available fault current is 106,000 amps. Above 106,000 amps, you go to roughly. And roughly does not calculate arcing currents. In fact, I don't like that. I don't like the roughly method at all because it doesn't calculate arcing currents. I can have 105,000 amps, which may not be your question, but I can have 105,000 amps and calculate 40 calories, put it up to 107,000 amps, and I'm down to 0.7 calories because I'm using the roughly method, right? Which doesn't make sense. But in any case, from a dimensional perspective, I'm not aware of any limitation on, I know there's from a size perspective, but if you make it smaller, your error is on the side of higher energy. So, to just make that, but if you look at 1584, there's no limitations on the size of the, because you have open air. There's an open air calculation.
There's a breakdown somewhere between where the code stops and then how the software is doing it. I'm pretty sure it's like a third.
It could be, is it
Like 30K.
All right.
But I started 90-inch cabinet, and it really gets into the equation.
It would be, that would be an interesting question. Is it SKM or Easy Power? What do you use? SKM. I'd flip that over to SKM because the 1584 doesn't have that limitation on size of enclosure. Yeah. Yeah, I honestly, I don't know what, I know what I've done in the past is for just some examples, I just use the smallest box size. And if you play with the dimensions, because I have a spreadsheet where I play with the dimensions, if anybody wants this, let me know. It's on my website. You can see the actual impact on incident energy. Now, I don't calculate the arc flash boundary, right? But the incident energy, you can see that the depth of the panel doesn't make a difference. No, but the width and the height will, and I just put everything at the smallest dimension that I could get from that piece of equipment, and I'm erroring. But if you look at the actual calorie difference, it's not that big of a deal. Yeah. Sure. Good question.
Anything over here? Thank you very much.
Try the veal. Thank you very much. Try the veal. I'll be here all week.
10 minutes after.
That was from Shrek. At least that's where I heard it from. Oh, hey, look at this. I turned this on and it freaking worked. It's FM. Yep.
Oh, damn.
How's that? Is that better? Okay. Okay, I think we're all set. Welcome, everybody. I'm Dan Carnevale. I'm responsible for our experience centers. How many of you have been to the Houston Experience Center? Anyone? Couple? Only a couple. So it's basically Disney, it's electrical Disneyland. So I would definitely suggest that you should go to the Houston Experience Center if you're there. And I'm out of Pittsburgh. We also have one in Pittsburgh. It's basically everything that you can imagine from electrical designs, like lots of arc flash solutions, lots of applications with panel board, switchboard, switchgear, and it's real, and it's working environments. So what's our experience centers? Basically, the experience centers are full-scale equipment, live equipment, and somebody to show you around and talk about, you know, how things work. And so you saw the Power Up program that we're talking about here. So for young consulting engineers or new people into the industry, we have these programs to talk about. You remember when you were in school and you got out of school and you knew that a transformer was two squiggly lines on a piece of paper? That's what we all learned, right? But we know they don't really look like that in real life. But unfortunately, like, we brought in a bunch of new hires to Eaton one time. We put like 20 of them in a room. And we said, okay, now point to a transformer. And they looked at us like, you know, like, but if we drew the squiggly lines on a piece of paper, that made more sense. So as engineers, a lot of times we learn stuff on paper, okay? What I'm going to talk to you about today in the terms of harmonics is something a little different than what we learn about in school. We learn that voltage equals current times resistance or impedance, right? That's Ohm's law. And way back in school, we also learned about constant current sources. How many times in your life have you used a constant current source for any kind of calculations or anything? Never, right? This is the one place where constant current sources make sense, and I'm going to explain why. But basically, who cares about harmonics, right? If you're a designer or a consultant, why do you care? If you're an operator, if you're a person running a facility, why do you care? If you're a salesperson or a representative that's putting equipment in, why do you care? First of all, what are harmonics? Where do harmonics come from? When we say harmonics come from what? How would you answer that? Nonlinear loads. I heard nonlinear loads. What's a nonlinear load? Are there any nonlinear loads in this room? Actually, yeah, I heard all. Are there any linear loads in this room? Probably not. If we had incandescent lights, maybe, but most of these are probably either LED or fluorescent or some sort of lights. Projector, the computer, all those are nonlinear loads. So nonlinear loads produce harmonic currents, and they send them out onto the system, and then what happens? And the currents flow through impedance, and what happens when current flows through impedance? It produces what? Voltage. And then we screw up our voltage. So we're going to talk about who cares about harmonics and why do we care, okay? But harmonics, my life has been basically power quality. There's 4 major power quality things, right? Grounding, harmonics, transients, and voltage variations. These are 5 different things that fall into those categories, but they're all a little bit different. So they're not all the same, but what we're going to focus on is one part of power quality, and that's harmonics. So this is what an outage would be, right? Voltage goes to 0. Now, if I call the utility and tell them I had an outage, what might they say? Nah, you didn't have an outage. You had a what? You had a momentary. If they don't have to roll a truck, you didn't have an outage. It was just a short-term interruption, okay? But that's a story for a different day, okay? What's that? That's a surge or a transient. That's a single pulse of voltage usually, maybe a lightning strike, maybe a capacitor ring wave, something like that. And that can cause all kinds of problems, but that's a little different than what we're talking about today. Can that trip a variable frequency drive? If it's a capacitor ring wave, yeah, you get a DC bus overvoltage, it might trip on overvoltage. But again, it's slightly different than what we're talking about today. What's a sag or a swell? A sag is where the voltage goes down for a little bit, and a swell is where the voltage goes up for a little bit, usually less than a couple seconds. What's a longer sag or a longer swell? A longer sag is called an undervoltage, a longer swell is called an overvoltage. Okay, so again, those are all power quality terms that we're not going to talk about today. So I'm setting sort of the details of what we are going to talk about, and that's harmonics. So it's distortion in the wave shape, okay, that can cause problems, and it's either current distortion or voltage distortion. We'll talk about where all that comes from, okay? Now, you see the picture here on your left. That's a linear load. Current looks like the voltage. Okay, this is the current, that's the voltage. Current looks like the voltage, and it's reflective of the voltage. So it looks very much like it. This is a nonlinear load. The current doesn't look like the voltage. And by the way, that current then screws up the voltage. So now we have two problems. So let me ask you this. If I told you, is anybody working with electric vehicle charging right now? Okay, some people. If I told you of these two waveforms, which of those is going to look most like electric vehicle charging? You would assume that one, right? You want some good news? Looks like this. Although it's even in phase, this is a lagging current, right? So voltage crosses, then current crosses. But I've tested probably 15 different electric vehicles, and the chargers on those vehicles, the current distortion is less than 10%, most of them less than 5%. So it almost looks very linear, which is really good news for all of us, because honestly, that could be another nightmare, okay? But what kind of current is that one, that double hump current? Where does that come from? VFDs. And what type of VFDs, to give you another question, 6 poles, 12 poles, 24 poles? 6 poles. And what are the harmonics associated with 6 pulse drives? 5 and 7. So you took 6 plus or minus 1, and then 2 times that, 12 plus or minus 1, 11th to 13th. We'll come to that. But harmonics are predictable. That's the good thing. We know they're predictable, and they're characteristic of certain specific loads. So this projector has specific harmonics, drives have specific harmonics, other rectifiers have specific harmonics, and we can predict that, and then we can decide what to do with it, okay? But it seems really complicated, doesn't it? So everybody's always said, oh, harmonics are really complicated, we need to worry about it. It's not really that complicated. What it is it goes back to Ohm's law. Voltage equals current times impedance, okay? And more specifically, voltage distortion equals current distortion times the harmonic impedance. Does impedance change? Let me ask you this. If you have a resistor, does the impedance change? Not really. Maybe a little bit with temperature, but not really. Does an inductor, does the impedance change? It does if you have what? If you have 60 hertz, it's 2 pi times F times the inductance, right? But what's the F, what's the frequency of the harmonics? It's another frequency that's typically higher, right? So if it's the 5th harmonic, it's 5 times 60 or 300 hertz. So the impedance does change as we go up in frequency. So that's a variable. The harmonic current, we said, comes from the nonlinear loads. So does that change? Yeah. If I have a factory or I have a conveyor system and I don't have any VFDs, and all of a sudden I put VFDs on all my motors, I've added much more current distortion. So based on this one and this one, that one then becomes bigger or worse, you could say, okay? So as you start off, you add more and more harmonic current loads. The systems are built for 60 hertz. What happens is the current distortion starts to cause heating. And then, oh, by the way, it starts to add more voltage distortion. And the bigger the harmonic current, the bigger the voltage distortion, very much proportional. And then what happens is, guess what? We switch from utility to generator. Who knows what a standard impedance is for a transformer if you do an arc flash study or a short circuit study? 5.5 to 6%, okay? What's the standard impedance, XD double prime, for a generator? What? 12, yeah, so it could be 12 to 20%, right? So let's say it's 18%. So if it's 6% on utility and 18%, now this impedance here changes not only from the inductance changing according to the frequency, but it changes because I'm going from utility to generator source. So now I've got 3 times as much impedance when I'm running on a generator with my same harmonic current. So guess what happens to my voltage? My source impedance changes, my voltage distortion goes crazy, right? So what do people do? Oh, I got a bad generator. Got to test my generator. So they roll in what? A load bank. What's a load bank? It's a resistor. Is that a linear or nonlinear load? It's a linear load. Voltage distortion equals current distortion times harmonic impedance. So no matter what this is, if that's 0, it doesn't matter, okay? So you're never going to see this with a load bank, are you? And this is one of those things as a designer you have to think about, right? So now which came first? Voltage distortion or current distortion? What did we just talk about? What causes what? Does voltage distortion start or current distortion start? Current, right? So this is where that constant current source comes into play. If I have a constant current source and I'm pushing that current through my system, however much current distortion I push through my system, that's going to dictate how much voltage distortion I have. What do you think are some of the issues with current distortion? I'm pushing extra current through my system. What's a natural thing for extra current to happen? Heat. Then I screw up my voltage. What's one of the things that's going to happen if I screw up my voltage? Yeah, you're going to have misoperation. Other equipment's not going to like that because it's expecting a certain voltage, and now you're going to give it a crappy voltage that it's not going to like. So depending on if you increase your source impedance or if you have more harmonic load, you're going to get more distortion. What do you think about that voltage waveform? Would you like to have that in one of your designs in your facility? That's actually, so I'm not going to have time to tell the story of the bad noise and the evil noise, but this was off an oil platform in the Gulf of Mexico. I actually went out, they dropped me off in a helicopter. They're like, fix that, and then we'll be back to pick you up when you fix it. So we have this in one of our videos. I'm going to talk a lot about videos later, but we have about 200 videos. 50 of them are on harmonics only. So you want to talk about harmonics? I love to talk about harmonics. You can listen to the videos. They're like 5 to 10 minutes, but they talk about all different types of things. We also have power quality videos. One of them is on case studies, and that is in one of the case studies. But the point of this is, we always say harmonics are not a problem unless they're a problem. Seems a little silly, right? But going back to who are you and why do you care about harmonics? They're not a problem unless they're creating other issues. What are the issues? Heating or misoperation. Are harmonics the new normal? Absolutely. You're going to have harmonics. You're not going to get around having harmonics. So how you deal with them and what you worry about is what's important. We talked about the Power Up program at our Experience Center. We get new consultants in. We always tell the consultants, we say, look, if you design the cheapest, crappiest system, you probably could save a lot of money for your first customer, but then in 6 months you won't have a job because they're not going to like your design because it's going to fail and it's, whatever, right? On the other end, if you design the most expensive, bulletproof, 100% going to work every time, in 6 months you're not going to have a job because nobody wants to pay the most expensive thing every single time, right? Your job as designers is to balance. What's the good, better, best version? Harmonics are exactly that. Sometimes the best solution is, believe it or not, doing nothing because harmonics are the new normal. If I don't have a problem with that waveform, I don't care. But in a lot of cases, if I have things like multiple zero crossings, yeah, it's probably going to be a problem. Transfer switches don't like that. Digital clocks, like on the oil platform, they run really fast when you see something like that. So in the paper, okay, in the paper we talk about basically symptoms, sources, and solutions of harmonics, okay? And then we talk about, the IEEE standard. What's the IEEE standard that you have to, that governs harmonics? 519, okay? We'll talk about that in a minute, but that's in there as well. And then we have some tables at the very end of the paper that basically talk about, cost differential and stuff. So if I'm comparing a line reactor to an active harmonic filter, how does that look, But what's the cost benefit of it? And how do they compare? As you look at the general sources of harmonics, it's really anything that goes from AC to DC. So, phone chargers, every single thing that's electronic is probably going to produce harmonics. So we have to deal with that. LED lights are LED lights, although they're a lot less load today, but variable frequency drives are probably the most significant one today. As far as deciding which characteristic harmonics you have, we talked about 6-pulse drives. So here's the equation right down here. If you have a 6-pulse drive, it's N, which is an integer, 1, 2, 3, 4, 5, 6, times P, number of pulses, plus or minus 1. So for a 6-pulse drive, 6 plus or minus 1, 12 plus or minus 1, 18. If I have a 24-pulse drive, it's 24 plus or minus 1. And as the harmonics go up in order, they go down in magnitude. So a 24-pulse drive has a lot less harmonics than a 6-pulse drive. Fifth harmonic for a 6-pulse drive is here. The 24-pulse drive has 23rd and 25th harmonic that are way lower. So it looks more linear, more like a resistive load, okay? And then you have things like, switch mode power supplies or computer power supplies. It has all the odd harmonics, or LED lighting. What do you notice about these last two? Even harmonic. So odd harmonics are typical. Even harmonics create asymmetry. And if you see me start to sweat up here and act a little weird, it's because I'm used to drawing on the board and acting like I always want to refer to drawing on stuff. So if you watch some of the videos, I'll talk somewhat through that. But even harmonics, if you looked at the top half of the waveform and the bottom half of the waveform, even harmonics are not the same. Odd harmonics, the top half of the waveform and the bottom half are exactly the same or symmetrical, okay? So even harmonics are an indication of something different than normal. When you energize a transformer and you hear that dong, it doesn't last forever, does it? It's only there for a little bit. Arcing devices like steel mills, arc furnaces, stuff like that. That can be short term, but it's not usually consistent for a long period of time. So how do you know you have a problem? Okay, we're talking about solutions. So a solution implies you have a problem. Well, we talked already about it. Current harmonics, which come from the loads and push back into the system. That's our constant current source. Let's say I have a VFD, and it's a 30 horsepower drive, and it produces 10 amps of fifth harmonic current. Where does that 10 amps go? It flows out on one of the conductors. How many phases is a drive, typically? 3 phases, right? So it flows out on the conductor. Does it go to ground? Nope. It goes out on A, back on B and C. Just like normal current going into the drive, except it goes the other way, okay? So one really important thing that they forgot to tell us when we're in college is that current flows in a loop. I wish they told me that current flowed in a loop. It made so much more sense once I discovered that. It's such a simple thing. But think about it. Current flows in a loop. It doesn't go over there and stop. So if current flows in a loop, that means it goes all the way over there somewhere and all the way back here, because it can't stop until it gets back. Okay? You want to hear what one of the guys in my college, senior year in college, he asked my college professor, he goes, what do they do to the end of transmission lines? Do they just tie them to ground? And he goes, what did you say? He's like the 70-year-old crusty guy who's really peed off all the time. He goes, what are you saying? And he goes, no. He goes, oh, forget it. Because he realized voltage can sit there all day long. Voltage is a potential. It's a difference, right? But if you have current, it has to flow out and back. So again, I wish they told us that because it makes so much more sense. Things like current transformers and potential transformers and things like that. If you understand that, you understand harmonics. So current harmonics flow out onto the system and they flow back on the other conductors. Third harmonics flow out on the system and they flow back where? On the neutrals, and they add up on the neutrals. And so there's other issues associated with that. But here's an example of a transformer getting really hot because of harmonics. Anybody know what this is? Capacitor. That's the outside of the capacitor, that's the inside of the capacitor. If you see the inside of the capacitor, that's probably bad. All right? If you blow the fuses, that's probably bad. That's called resonance. We don't like resonance. Resonance is bad. All right? What other symptoms or issues do you have if you have harmonics? You could have audible noise. If you walk up to a transformer, it can make buzzing and noise like that. You could have other issues like that, right? You could have things turning on and off when you don't want them to. One of the examples I like to give is I was in an auto plant and they were doing welding. And they were doing welding based on 20 cycle welds, electrical cycles. So a third of a second, 20 electrical cycles. How do they tell how long it is? Zero crossing, zero crossing, zero crossing. That's one cycle, okay? Well, what if there's a lot of notching going on the waveform? Zero crossing, like multiple. So they were doing, instead of 20 cycle welds, they were doing 8 cycle welds. And the welds were falling apart. Tailgates were falling off of minivans. But they didn't know that until like months later, and they get a recall, and they're like, what the heck's going on? Well, the voltage distortion was causing the welding equipment not to operate properly, but nobody put that together and looked at it as a power quality problem. They thought it was just, you know, a bad welder. This is the kind of stuff you can see though. Now, we show sort of this doctor analogy, right? So if you go to the doctor and you say, hey doc, I got a problem. Do they go like this? Do they go, let's try brain surgery. If that doesn't work, we can put a cast on your leg. If that doesn't work, we'll give you a shot. Do they do that? Let's hope not, right? Maybe get a new doctor. But if they do that, what are they going to ask you first? The symptoms. This is why it's really important. If you have voltage drops, sags, and you're dropping out drives based on voltage sags, that's not harmonics. If you have a transformer overheating, that's not sags. That's why I related everything back at the very beginning of this to which power quality problem were we talking about. So the symptoms here tell you what the problem is so you know how to fix it. Then there's other economic considerations, and that really relates to if you're doing power factor correction and you're blowing up capacitors, or maybe you have a power factor penalty. Maybe you put in harmonic filters. Is a harmonic filter a power factor correction device? Believe it or not, a harmonic filter is primarily a power factor correction device that you don't want to blow up because you avoid resonance. And secondly, it offers harmonic filtering. It has a primary benefit of power factor correction in almost all cases. I wouldn't say there's always, right? But the secondary benefit. And the more you detune it, you ever hear of detuned harmonic filters? 4.7th, 4.2nd, 4.1st. The more you detune it, the more you want it to be power factor only, as opposed to getting close to the harmonic where you want to try to get rid of the harmonic. So there's a lot of little things that go along with that you have to understand when you're applying things. But even previously, remember when we said, let's say the impedance of a generator is 18%? How can you make that impedance smaller? What did they used to do with all data centers? They would double the size of the generator. It wasn't because they needed 2,000 kilowatts. They needed 1,000 kilowatts. But what were they effectively doing? They were cutting the impedance in half. So you basically bought this big generator, and the only reason you bought the big generator was so you could get the impedance in half. Now we have active front-end UPSs, and they look almost linear, so they don't have that problem anymore, okay? So IEEE 519 2022 is the latest standard, believe it or not. They just came out with a new one last year, and they just included a few different things in there with inverters and stuff. But previous to that, there was an update in 2014. Does anybody know when the update before that was? 1992. Forever they kept saying, we're going to update, we're going to update. So they went from this 1992 standard, it was almost like, it was almost 100 pages, and they reduced it down to like 17. They made it much more concise in 2014, which is good news. But anyway, when we talk about harmonics, we could talk about internal versus external sources. And if we're talking about like us versus our neighbor, that's important to know. There's a thing they say in the standard called a point of common coupling. Okay, the point of common coupling is where me and my neighbor come together, and if I'm sending that current out onto the system, screwing up the voltage on the utility system, who's going to take responsibility for that? Well, the utility is going to enforce and say, you are. You're going to do that because it's your fault. You're screwing up your neighbor. All right? But sometimes you have to look at the data. And in this case, if you look at this, remember we said current distortion causes voltage distortion? Right now, my plant's shut down. I have no load, but I have 4% voltage distortion. So what does that tell you? Where's that coming from? It's coming from the source. It's coming from maybe somewhere else, the neighbors. Maybe they're creating the voltage distortion, because just because I go from 4% to say 5 or 6% doesn't mean I cross this magic threshold and all of a sudden my stuff's going to fall apart. But if the utility comes back to me and says, hey, you've exceeded this limit that we've imposed, well, you should look at, am I causing it or is the neighbor causing it? Has anybody modeled in SKM or any other program Harmonics at all? So so what you do is you put it in as a constant current source, and you do multiple load flows at every frequency, 60 hertz, 300 hertz, 420 hertz, and it tells you where the currents flow, how much voltage distortion you get, and this kind of stuff becomes evident. So here's some of the stuff out of the standard, comparing again the 92 standard to the 2014 standard, and again you can see the bottom line there is it really reduced the scope of it, because there was a whole bunch of educational stuff in there, and they just really got down to the main points of voltage distortion tables and current distortion tables. And it's much more, actually they freed up a little bit on the voltage distortion. They allow you to get a little bit more, and that's really just based on experience. What they found is people can live with more voltage distortion than they thought they could, okay? But here's a comparison of, in the 2014 table, and this is the same in the 2022 table, by the way, but you can have 8% total distortion, and then the individual ones can be a certain amount as well, but they're lower. And we'll talk about how to calculate total harmonic distortion. So that's what this is. If I take this wave, any waveform, current or voltage, and I go from here to here, that's one electrical cycle of 60 hertz. Then I break that down with math called FFT, fast Fourier transform, and I get a 60 hertz part, and I get a 180 hertz part, 300 hertz, so third harmonic, fifth harmonic, seventh harmonic, 11th harmonic, 13th harmonic, okay? Now let's say, just for simplicity of math, let's say the 60 hertz part is 100 amps. So 100% of 100 amps is 100 amps, so that's good. What's 20% of 100 amps? 20 amps. So I have 100 amps, 20 amps, 12 amps, 4 amps. So if I square all those and divide by 100, I get 23.8%, okay? But I want to tell you, be very careful when you're doing percent distortion, because what can happen is you can end up with a number like that, and then overnight you might drop your harmonics just a little bit. But let's say your 60 hertz increases a lot. Let's say you have a bunch of motors that are across the line. Let's say this number doubles. All of a sudden your THD goes way down, even though you might have the same amount of harmonic current. So it's really more about the amps of harmonic, not about the percentages. And so in the IEEE standard, they focus on what they call TDD, total demand distortion. And that's really just focused on this number here, which is the demand. And if you look at an actual example, this is a 18 pulse drive. Look at the actual amps of harmonic current. 8.2 amps, 9.2, 10.1, 10.8. They increase as I add load, okay? Not nearly dramatically as the fundamental increases. The fundamental kind of is proportional to the actual load. It increases pretty significantly. So if you look at the THD at a light load, you have 26% distortion. You say, holy cow, that's horrible, right? But really, you have less amps of harmonic there than at 60 hertz where you have 5.9%, okay? Which is the worst case. This is the worst case. I have more amps of harmonic distortion. So if you use TDD, you divide by the demand load, which is the worst case scenario, then I go pretty much increasing, and it feels better as far as what's increasing with my load. The other thing about this is, you might say, well, I want my drive to have less than 5 or 6% distortion. You go, well, okay, it is at 60 hertz, but why do you buy a drive? Do you buy a drive to run it at 60 hertz? No. If you do, I'll sell you a whole bunch of other stuff, because that's a really bad waste of money. Run a drive at less than 60 hertz to save, or you run it at less and more to change frequency to avoid, or to control the speed, right? Here's the current distortion table, and again, the important thing here is that TDD value, and it increases with what? I short circuit over I load. So if the load is the same, I have a 30 horsepower load, and I put it on a 30 kVA transformer, that ratio of 30 kVA transformer to my load, pretty low, meaning I'm loading up that transformer. If I put that same 30 horsepower load on a 3 MVA transformer, do I probably care at all? No. In other words, if I add a 30 horsepower drive on a 3 MVA transformer, am I going to go do a $20,000 Harmonics study? Again, probably not worth it, okay? So short circuit overload is important, meaning how much am I loading down the system, because what does that really imply? It implies how much I'm screwing up my voltage, okay? People always get caught up in that number right here. They go, well, 20% distortion. I have 40% distortion. My building's going to burn down. Okay? Well, let's, again, think about it in real amps. All right? If I had 20% distortion and you were the designer and you designed it to be okay at 20% distortion and it wasn't going to be okay at 21% distortion, let's think about what that means. Fundamental current of 100 amps. Harmonic distortion, 20 amps. That's 20% distortion. The total RMS current is 102 amps. So you designed your system to work at 100 amps, but not at 102 amps? Probably not a problem, okay? Most of the issues with harmonics, if they're heating, it's excessive harmonic distortion. And again, it's self-infecting. I'm usually screwing up my own system, so the utility doesn't really care about it. If it's above 20%, you start to get into some issues. But if you're designing a system that's above that, you have to really worry about what is that doing to my voltage? And that's really, the concerns come into play where I'm screwing up my voltage enough to cause other issues. So now I'll talk about just, again, I'm going to fly through a couple of these because they're all in the paper and they go into some detailed descriptions about these. But really I'm going to talk about individual load solutions versus system solutions. So in some cases it makes sense to do the load solution, in some sense it makes sense to do the system solution. A line reactor with a VFD or a DC choke. Has anybody used those before? Line reactors? Okay. So they're like probably $3 to $5 per horsepower with a drive. It'll cut your harmonics in half, meaning if I don't have a DC choke or a line reactor, my current distortion could be 80%. If I do, it could be 40%. I've reduced my harmonic current. So remember what happens? Current flows out and flows back. If I stop it from flowing, it doesn't go anywhere. It's constricting it, doesn't allow it to flow. It's like grabbing a hose and squeezing it really tight so the water doesn't come out of it. Okay? There's a good video on that talks about what a line reactor DC choke is. The advantage are it's very inexpensive compared to other things. I wouldn't even suggest buying a drive that doesn't have a DC choke or AC line reactor. It would be difficult for me to understand putting money in after the fact, especially with drives. Here's what the waveforms look like. So it's very discontinuous current as opposed to that. And look at for example, just this one's 70%. So if this was 100 amps, that's 70 amps. And this one's like less than 40. So it makes a big difference just by having that DC choke or line reactor. You get kind of diminishing returns. So as you go up in, the bigger the percent line reactor, the less benefit you get out of it. Let me ask you this. This is a very sometimes confusing point. If I put a 10% line reactor in front of my drive, am I going to get 10% voltage drop? A lot of people think you do. The answer is no, you don't. We have a frequently asked questions video on that, and it's probably about 2 to 3% voltage drop. Because people say, oh, I put too much line reactor on, then I get a big voltage drop. What's the first thing a drive does with your voltage when you bring it in? 60 hertz voltage, then it does what? It rectifies it. It goes from AC to DC. So if I have a little bit of a flat top, if I have a little bit of a voltage drop, it's not a big deal. I'd much rather have a more impedance source than a less impedance source, as long as I don't screw up my voltage so much on that side of the system that I have other issues. But downstream of the line reactor, your drive's going to be okay. Here's where the DC choke would go inside the drive. The nice thing about a DC choke is you can put a bigger DC choke in a drive than the AC line reactor as far as the impedance goes. Physically, it'll fit more. So you can get a 5% DC choke in the same amount of physical space you get a 3% AC line reactor. What about drive isolation transformers? Does anybody use drive isolation transformers? Okay. So some of the benefits of that are you get true electrical isolation, but in fact, it also acts like a DC or an AC line reactor as well. So here's without the reactor. This has a DC choke or an AC line reactor in the drive, by the way. That's why it looks a little different than the one I showed you before. But we're going from 50% down to, 33%. So 58% down to 33%. And you can see in the wave shape, it looks more what we'll call linear, more sinusoidal, okay? How about a drive dedicated filter? This is where that 10% line reactor comes in. Has anybody ever used a drive dedicated filter? What that means is I put a filter in front of each drive, and it makes it look from a 6 pulse to maybe an 18 pulse drive, okay? Much better. There's a 10% reactor here. Then there's a shunt filter here, and we'll talk about shunt filters, but basically what happens is the harmonics come out of the drive, remember, and they look, and currents look, and they go, oh, the other thing that they told us wrong in college is current flows to the path of least resistance. That's wrong. What should they have told us? It divides according to the resistance, right? It flows to all paths, but it divides according to the resistance. So if this is a really high resistance or impedance, and this is a really low impedance, most of it will go here and some of it might still go there. If this was equal to this, half of it goes there and half of it goes there, okay? But that's what a drive dedicated filter. What's the disadvantage of that? You're putting one on every single drive. So if you have a water treatment plant and you have 10 drives, but 5 of them are redundant, you put filters on every single drive when you really only need it on 5. So you might do more of a system level approach. How about a 12 pulse drive? This is with phase shifting. I can make a 6 pulse drive look like a 12 pulse. So you can do, you get less distortion, it looks more linear, okay? And then 24 pulse is what you end up with, especially with medium voltage. Anybody use a medium voltage drives? So yeah, so down at our experience center down in Houston, we have a sync transfer set up with a medium voltage drive, and we can show you the how that works. But we can show also the 24 pulse, which almost looks perfectly linear, okay? Now, as far as, let's say, you go to the next step, you say, I don't want to do a single drive approach. I want to do more of a system, an individual load approach, but I want to do it on the load itself. I want to pay for that EV charger that's going to have lower distortion, or I want to pay for that drive that has lower distortion. So you can do things like computer power supplies that are lower distortion. They call them power factor corrected, but they're really lower harmonic distortion. You could get low harmonic distortion rectifiers or active front end devices. So this is what computer power supplies used to look like. This is what the power factor corrected ones look like today. At one point, these were $12 and these were $75. They've come together a lot more in cost, okay? But again, this is a lot more what the front end of a vehicle charger looks like. So how does a standard drive converter work? We convert from AC to DC with a diode bridge here, DC bus, and then we have an IGBT on the output, IGBT bridge on the output that converts from DC back to AC, and that allows us to change the frequency. The point of changing the frequency there is so that we can regulate the speed of the motor, okay? On an active front-end drive or on a active front-end UPS, frankly, you could put a pulse width modulated filter here, which is basically like this thing in reverse. Put it over here. So in some cases, that could even double the cost of the drive. But you could argue that it can give you really nice, clean waveforms coming out of the drive, pushing back onto the system. When we do this with UPSs, by the way, we took out a transformer and a harmonic filter and put in an active front end. When we do it with drives, we didn't take anything out, we just add in extra stuff. So that's why, again, when you look at it, the difference between doing that on a drive and doing it on a UPS, it adds more cost. So here's what an active front end UPS or drive might look like in terms of current and voltage. And again, it's a lot more clean. Now, from a system solution standpoint, we could do these different things: tune filters, phase shifting, active filters, third harmonic filters specifically, or, and this is one that a lot of people have done for years, just oversize the equipment. If it's causing heating with a smaller piece of equipment, you put a bigger piece of equipment in, and it does a nice job of not heating it up. If I took a 75 kVA transformer, and this was the standard, we'll call it K1 transformer, a K13 transformer might be this big. And in fact, if you look inside and you kind of really scrutinize it, it may be 1.5 12 kVA transformer with a 75 kVA labeled. It's perfectly capable of handling 75 at 100% distortion, but it's just derated to do that, right? So that's how you oversize equipment. We talked about generators, why we do that. We do that to really reduce the impedance, okay? So let's talk about a couple of those. This is the shunt filter, and what happens is, remember, this changes with frequency. So 2 pi f times the inductance. Inductor, the impedance goes up. What happens with a capacitor? It's 1 over 2 pi f times the capacitance, so it goes down. So as they cross at a certain frequency. And this is, just to really stretch your mind this afternoon, this is, let's say, J10 ohms. This is minus J10 ohms. What's J10 minus J10? 0. So at some frequency, the current coming out of here sees 0 ohms and it wants to go that way and go back to the load. And then it never goes back on the system, hitting the impedance and screwing up our voltage, okay? That's how a harmonic filter works. So if you have harmonics coming out of each drive here, it will divide according to the impedance. Not all current doesn't flow to the path of least impedance. All current divides according to the impedance. And this is where some of it's going to go here, some of it's going to go there. If it doesn't all go through the impedance of the transformer, it doesn't screw up our voltage. We clean up our voltage and we clean up our system. We have a really good video on this one, and it talks about how the phase shifting works. But basically, you take 2 transformers here, delta delta or delta zigzag and delta Y, and these transformers make the wave shapes look a little different. They add together and become 12 poles. It makes a big difference. If you were designing commercial buildings and you shifted from, let's say, when we say we have, 3 floors here and you got a bunch of computer rooms, 5 rooms, 4 rooms, 3 rooms. Let's say you have fifth harmonic of each on each floor. So you have 5 plus 3 plus 4, 12 units of harmonic current, okay? If I do phase shifting on one of those floors, this one, I do a -3 there. So I have 5 plus 4, 9, -3 is 6. I've cut my harmonics in half just by changing one of my transformers. If I pick this transformer, I get -5 plus 4 plus 3. I get 2 units of harmonics, meaning if this was 120 amps of fifth harmonic current, now I'm down to 20 amps of fifth harmonic current. So it's this cancellation of harmonic current just by doing phase shifting. And that's, if I will tell you one thing, if you're designing, water treatment plants or if you're designing commercial buildings, take advantage of phase shifting. It's one of the easiest things to do because a lot of times you have to put transformers in anyway. Active harmonic filters basically are going to be just like the noise cancellation on your phone, right? How does that work? If I'm in a really noisy room, I'm talking to my phone, people don't hear outside of the room what's going on. They only hear my voice. And what happens is it injects equal and opposite frequencies. Or like if you have noise canceling headset, it injects equal and opposite frequencies. So it injects this garbage to add to that to make it look nice. Again, that's what's drawn from the source or pushed back to the source, okay? We talked a little bit about third harmonics adding up on the neutral. Just briefly, they can do, this isn't as big of a problem anymore because they have a lot of the better power supplies. Putting in a different transformer to handle those harmonics, for third harmonics, like this, a delta Y, or like this, a delta zigzag, we can make it a little bit more efficient. I want to skip ahead sort of more towards the end here. I want to show you a couple of things at the end. So resonance is a really important issue. You guys ever see the Tacoma Narrows Bridge? It oscillated and it ripped itself apart. If you put capacitors on a power system, basically they will resonate at a certain frequency. And in this case, if they resonated around the 7th harmonic, and I have a 6-pulse drive, do I have a source of 7th harmonic? Yeah. So I'm pushing 7th harmonic out, and let's say I push out 10 amps of 7th harmonic current. Between these two things resonating, it may get up to 1,000 amps of 7th harmonic current. What's going to happen? Hopefully I blow my fuses. Second, I might blow my capacitors. Third, I might blow up my transformer. Resonance is not a fun thing to deal with, okay? So as you add capacitors onto power systems that have harmonics, and we know harmonics are the new normal, you have to deal with it. So again, you don't want to see that, right? Here's an example again of heating. If you get a transformer and it causes a lot of heating, we can have issues with that, right? You can actually have voltage distortion from nonlinear loads cause linear motors to essentially want to spin backwards, which is not good either. It's like driving with your foot all the way to the floor on the gas pedal and pumping your brakes. Not very good idea. That's kind of what happens electrically. And then one last thing here, and then I'll show you the video page, is if I take my power triangle, kilowatts, kVAR, kVA, if you look at your power factor displacement, your power factor, just 60 hertz, that's what it looks like. As I add in harmonics, it's almost like I'm adding a third dimension to that power triangle, and essentially end up with more kVA. And so when I take kilowatts divided by kVA, my power factor is always going to be lower if I have harmonics, okay? That's my total power factor. So this is the last page. Basically, we have a whole bunch of videos on our eaton.com/experience website and under power quality specifically. And then we have 49 frequently asked question videos. There's also just eaton.com/harmonics. You guys will get a copy of this presentation. There's actually 120 slides in here. I hit a bunch of them, so you guys wouldn't have to, I wouldn't have to go really fast. I already went kind of fast, but anyway, that's it. So if you're in any of those situations and you want to figure out harmonics, I mean, it's important. It's the new normal, but you got to deal with it in the right way. And sometimes doing nothing is the right thing, right? Okay. I'll stick around for questions or if anybody has anything quick. But I know we want to try to take a break here.
10-minute break. So about 3:10, we'll start into energy transition, and we really want to make that presentation kind of a engaging conversation when we get to it.
Yeah.
So you mentioned in the start that you tested a bunch of EVs.
Yeah.
Which one performed the best?
So the question was, we tested a bunch of EVs, which one performed the best? Tesla did a really good job, and there's several other ones that are very similar to that. I think the new Lightning was pretty good. There was a couple that were kind of pushing at 8 or 9%. I don't remember specifically which ones they were, but I remember specifically like the Tesla one, because and I think they've been at it for longer than most of these people, so it's been pretty good.
Way off? Is Tesla much better? Or?
No, I mean, it would go from, say, 4% distortion. So on a 100 amp basis, they had 4 amps of harmonics, and the other ones had 8 amps. So it's almost like if you look at the waveform and you didn't have a meter that could measure it, you would think they're the same. You know, it's very close, very close. Yeah.
Just on isolation transfer, where would you say is the ideal application for a situation?
So the question is, if you, on an isolation transformer, what's the ideal situation for isolation transformers with harmonics? And it's really all about, if you can use them for phase shifting, that's going to be your best bet, because now you're canceling some of the harmonics from other loads, as opposed to using it just for the impedance, like a line reactor. Because a line reactor would be like $3 or $4 a horsepower kVA. Isolation's $50 a kVA roughly, or whatever. But if you can use it for phase shifting, 100%, it's a much better solution. Yeah.
So if I have an unreliable source, that would be a good.
Yeah, you don't know what you're getting from. Yeah, exactly. Yeah, absolutely.
So if I want to improve the power factors for the system, you say if I add the capacitor plate, I need to watch out for the
Yeah, so if you're adding capacitors with, when you have harmonic sources, so you have a source of harmonics, The Tacoma Narrows Bridge failed because the wind was blowing. But if the wind didn't blow, the bridge would have been fine. What happened was the bridge started to make it move, okay? So if you don't have harmonic currents, then the voltage, or then the current distortion wouldn't get amplified. So you can have a resonant point when you put a capacitor on, but when you excite that resonant at the frequency of interest, which is what harmonics are, 300 hertz, 420 hertz, before you only had 60 hertz. The resonant point was over there somewhere. Now you have this resonant point. So we have a couple good videos on that one as well. It's, and I can give you my card if you have other questions on it, but it's definitely worth looking into.
Yeah, so how do we correct it? We have both of them.
So when you correct it, the best way to correct resonance is to apply either a harmonic filter to tune it to where you know exactly where it's going to be, or to get rid of the harmonics. Sometimes it's harder to get rid of the harmonics from the load or the source. Yeah.
Is a mic good for the camera? All good? All right, we'll let everybody kind of trickle in, but we'll go ahead and get started just for the sake of time in the next session. I know I can see already everybody's face is really excited to get into engineering ethics, so we'll try to make our presentation a little bit quicker. So my name is Miguel Rivera. I'm the application engineer for energy transition. We'll get into a little bit what that means, but a little bit about my background. So I've been with Eaton for less than a year. I serve the Gulf and the 4 states surrounding Texas. So that would be considered the Gulf region. My experience is that I've been involved with renewable, sustainable projects for more than 10 years now. When I first started my career, I started at Environmental Chemical Corporation. They were a contractor. They were one of the first ESCO companies that went around the United States, did energy audits, energy analysis on basis, and then you brought your proposal to the table in terms of what energy conservation measures and what renewables and what you can install to kind of get that payback. The reason why that's important is just to kind of give you context is we had all the skin in the game. You financed the projects, you were the one that did all the construction, managed everything, and the end user, which was typically the basis, would then give you a percentage of the savings over a monthly period, and that's how you paid back the projects. So there was one, I share that story because there was one kind of turning point where every single project was a win, and every single project got your money back immediately. Paybacks were less than 5 years, and everybody was shaking hands and celebrating, and that was when LEDs came around. So I don't know if you guys have been around that long or have worked on projects when that first transition. Now it's common knowledge. Now, if your facilities manager is not recommending LEDs or you haven't retrofitted, they should fire that guy immediately. But there was a point in time where each fixture was expensive. I mean, it was about $80, $90 a fixture. Now you compare it to a 60-watt light bulb, they're pretty comparable in price. So the energy offset was already there. There was also a point in time where you had people that didn't like the color temperature. So, it was either too blue, too green, we're not gonna do LEDs, get them out of here, even though the payback and the savings were there. So again, my background, been involved in those type of projects and traditional MEP electrical design projects. I've been kind of boots on the ground like you guys, service calculations, putting receptacles everywhere, forgetting receptacles, forgetting to put lights in different places. I mean, I've done that as well. But the reason why I bring that up is because LEDs and were, yes, part of energy conservation because you got that energy savings, but really they were more of a market disruptor. So the reason why we're really talking about EVs and EV infrastructure is EVs are a market disruptor. They're not really, yes, they're tied to renewable energy, sustainable energy, only because it makes sense in terms of taking advantage of the capacities that are out there, but really it's a market disruptor. It's a technological advancement compared to, IC or internal combustion engine cars. So that's a little bit about my background. I'll go ahead and, you want to introduce yourself, John?
Yeah, so my name is John Gacchia. I'm with Eaton's North American sales team. I'm director for energy transition. So I've been building a team of application engineers like Miguel. Miguel, as he said, is our application engineer for these kind of projects in the Gulf region. But if your firm has offices in other parts of the country, we have other application engineers around the country that can help, and Miguel can help you connect your other offices with those. We'll kind of tag team the presentation here. Miguel's going to do most of it, and I'll chime in with some color commentary now and then on some of the projects we've been working on to share with you what we're doing in the energy transition space. We'll open it up at some point to kind of hear what you guys are working on as well too.
Yeah, so in terms of, the reason why Kevin said that we wanted to make this a little bit more interactive is because, we're just launching our chargers. There's other people in the space. And really, I could go down the spec sheets, but, there's a breaker and there's Wi-Fi on that breaker. I mean, that's about as complex as it gets. Everybody is, has a background in electrical. We're just kind of talking to you guys out there while we're in our booth. So, there's not much you're going to learn in terms of looking at the charger itself. So, so right now, let's just take a quick poll real quick on who drives an EV now. So actually, it's interesting. Actually, statistically, that's about right. I mean, if you kind of look at it right now, the adoption rate in the United States is only about 2%. So there's a couple of drivers that are going to change that. and we'll kind of get into that. What are you guys seeing right now in terms of your designs or EVs, or when you're talking to developers, landowners, landlords? What are you guys seeing now? Yeah, so that's a good one too. So what is the request, or what is the local jurisdiction asking for? So what type of occupancy is it? Industrial. Oh, that's more of. So in terms of regulating that or mandating it, how many parking space? Let's say a percentage of parking space. Are they mandated based on percentages, or? So what's a percentage? Give or take. 1% of parking spaces. Well, I thought you were going to say a lot more than that. That doesn't prove my case at all. So is anyone else seeing anything like that where the local jurisdictions are either asking for it or? So let me ask you this: on multifamily, if you guys work in, besides commercial industrial, if you work on multifamily, is that a request that you're starting to see as well, in terms of at least building in, a junction box or sizing capacity, maybe adding a separate service for electric vehicle chargers? How much? 2 to 5%. Yes, in terms of percent, or just starting to see it? Most require around what? 2 to 5%. Okay. Have you guys have any of you guys done a service calculation or load analysis, including EV chargers at all?
Yep.
So on percentage, how much does that increase your base load? So let's take a level 3 is a little bit different. You're not going to see those kind of in typical applications. That's going to be dedicated to wherever spot you're in. But let's say a level 2. 40%? Yeah, there you go. That's a bigger number. That's more of what we're trying to aim for. So, and someone else mentioned also that you guys did a service calc with EV chargers as well. Yeah. What was the percentage increase in your base load? You don't remember? So 50%, right? You want to top his guy's numbers. All right. So, kind of the point of that is. To kind of get a feel of what you guys are seeing. I know that, maybe because we're specifically in this realm, but, a lot of contractors, designers are coming up to us. We have a different fleet of products. We have in different kilowatt ranges, but that's more or less of what we're seeing as well. So, 40 to 50% increase in load. So if you that's kind of at a micro level, but that's a new construction. It's easier to accommodate that. It's easier to kind of, make provisions for either transformers, extra load centers, but what about retrofits? What if retrofits? What if you have a facility where you have to retrofit some of that infrastructure to be able to accommodate this extra load? How easy? You start thinking about how easy is that going to be? So if you take 2 things away kind of from this presentation, is one of them is, if you don't know anybody that drives an EV, and maybe actually that's a good one. Since you drive an EV, what's your experience in terms of charging your vehicle? How do you charge your vehicle? In your home? No, that's a good response. Do you ever go out in public and seek a charger? Like, do you go, okay, I need to go refuel my vehicle, so I'm going to go over there? You haven't needed to yet, right? So right now, that's the kind of statistics that we're seeing with most people that own EVs. So 80% of them will charge them at home. That's why, based on default, in terms of home load calculations, multifamily, you're going to need a charger wherever you go. And actually, her second response is the same thing that we see with all EV chargers as well. So that's the shift in the mindset. So from an electrical perspective, we can take advantage of that because now we upside the service, we make provisions, we size, set up junction boxes, set up the transformer. We can plan for that extra infrastructure. But, the shift in mindset and the kind of pushback or the things that you get from people right now that, because everybody's used to it, is you're not going somewhere to refuel your vehicle. You're refueling your vehicle wherever you are. It's more like charging a phone. And when you kind of think about that a little bit and kind of replay it, then it kind of makes sense. And then you start thinking, okay, well, that means that there's going to be electrical vehicle chargers everywhere. Why? Because like right now, for example, if you look at even a traditional model of a gas station, right? How do most gas stations make most of their money? They don't make money off of the gas that they're selling. They make it for the foot traffic. So you're going in there, you're purchasing gas, and they're making money. I mean, look at Buc-ee's, right? I mean, people spend hours there at Buc-ee's just for all the brisket sandwiches that they're selling, and they're one of the most profitable restaurants, considered restaurants in Texas. So they're making money off their food. So it's going to be the same thing in shift in mentality in terms of charging vehicles. Now, if you're a business owner, if you have, a movie theater, bowling alley, well, now it makes sense, in order to drive customers, that foot traffic, that those chargers are going to be there. So in order to kind of accommodate that, because you probably have also heard, all the stories, studies, and everything in terms of doom and gloom, upgrading 40%, if you just did that linearly, for you guys, I'll ask you guys in your service territory, the utilities that you worked with, just give me, I'll call on somebody. What's the last utility you worked with? Encore. So if you went anywhere and said, I need to upgrade the service, 40%, or you need to upgrade your whole infrastructure by 40%, what are they going to do? They're going to say, too bad, you can't install these chargers. I mean, you just wouldn't be able to do it. The good thing that there's kind of other drivers that are going to push that as well. So, I'll briefly go over some of our solutions in terms of load management. We have our smart breakers. I'll go over, since you guys are begging me, over our car charger kind of specs. We'll go over our energy storage solution, and then I'll go over our kind of a case study of a microgrid that we have installed in Puerto Rico. So our approach and the way to kind of solve this issue, utilities right now, even if they think that they don't have an issue, asking them to upgrade to 40% to be able to accommodate the extra infrastructure for electrical vehicles, it's not possible. So the way our mindset, you're going to see the slogan on everything that we offer. It's on our brochure, it's on our website, is that we're changing our mindset to thinking of everything as a grid. So that's the loads, that's your sources. Everything now is going to be two-way communication. So traditionally, and I would say even, when I started, about 10 years ago, this line has always been linear. You have your generation stations, scattered throughout Texas, nuclear, natural gas, coal, all those plants. And then that goes through your transmission systems, that's down to distribution, then you feed your loads. But what it means, everything as a grid, kind of even from a macro level perspective is, even your loads now can be considered microgrids. They have their own distributed DERs. They have their own storage solutions. They have their own EVs. So we'll go over this product as well too. But another reason why an EV can also be considered a market disruptor, and it's coming closer than you think, is actually EVs now can also be not just a load but also a source. So it's not just kind of power flows, because that's the way that we'll think of it as electrical guys. That's power flows, everything's going two ways. All your infrastructure has to be beefed up to be able to handle, both sources of current. Your short circuit calculations change, your load analysis change, the shifting peaks change. So it's all that power flow makes a difference in terms of the grid. But it's also going to have to be, the reason why we consider everything as a grid now, it also has to be communication as well. So I'll use Texas since everybody's from here, but let's say the entity that kind of regulates transmission here. Is anybody familiar with the entity here? They got in trouble 2 years ago? ERCOT, yeah. So ERCOT is more of your traffic controller, right? They regulate your transmission. They're the ones that are viewing from a macro level, anything that anything that's a renewable that's over 1 megawatt has to be registered in ERCOT, so they have visibility in that. They're also deploying and also sponsor grid storage to help have energy storage and call upon it whenever needed to help that get connected into the transmission systems. And then your distribution and on is going to be more of kind of your local utilities. So the funny thing is that the communication infrastructure between everybody is already there. So in my times, I also spent some time working for a utility, and the communication in terms of reporting, some of it is a little bit antiquated, but now it has to be more of gathering real-time data. So right now, what we would do is if you had a solar installation kind of on the load side, you would send a quarterly report to ERCOT, anything that was registered over 50 kW. But that's it. It's a stationary report. You don't have anything. You just tell them, okay, and we have this many meters. This is how many solar installs we have that are over 50 kW. And then they keep it, and then they store it. And hopefully they put in their data analytics. But since it's not data that they're processing, it's more of kind of record bookkeeping, right? So, and the last conversations, even speaking with ERCOT, they were having an issue with, I don't know if you've heard of the term phantom load. Has anybody heard that term? So what is a phantom load? Oh, no, you're good. No, like I said, I want to make it interactive. Nobody else wants to participate. But so what a phantom load was, basically they have all these DERs that are not registered because anything under 50 kW. But what would happen is that once on a cloudy day or cloudy areas, well, guess what happens? The solar drops, the solar's gone. So now you have, ERCOT was saying, well, we have projected load that's going to be this much, but now all of a sudden on a cloudy day it's this much. Well, how do we get that delta? How do we really account for it? So in terms of the communication schemes being there, also if you guys are familiar with what happened 2 years ago, basically the communication is there. So here in Texas, we have something called 4CP. Are you guys familiar with 4CP? So basically, we peak in the winter and we peak in the summer. So in the winter, that's not going to help you out with the solar. So that's an issue in terms of calling and having that available resource as generation. But let's just take the summer for example. So 4CP means that they take 4 readings of your peak load during that season, and they'll send an alert out to the utility. So, like my utility, I'm from San Antonio, CPS gets those alerts, and then they pass it on. That's where, all the demand response programs come, where they want to control your thermostats or any loads behind the meter. That's where they get the alerts from ERCOT saying, hey, we think we're going to peak based on temperature, based on the climate that we're in, based on how hot it's going to get. They'll send them an alert. So then now CPS responds, and they do that, again, they do that in the winter and they do that in the summer. And what happens is once you register that peak load, your utility then is responsible to pay ERCOT the fees based on a percentage of how much you contributed to that load. So the point of that is that the communication systems are there, but now it's about giving them real-time information and making that more of a dynamic play. The funnier story, did you guys hear what happened in California last year? So when they mandated the 30 by 30, so 30% of vehicles have to be EVs by 2030, and then subsequently then they mandated that by, I think it's 2050, that you can't sell any IC vehicles. Well, guess what happened a week later? Does anyone remember that story? They told everybody to stop charging. So the issue with that is like, it became a meme. That's an instant meme, right? That's a self-owned. That's pretty bad, But the thing is that was same thing. So they have the California ISO. That was the ISO saying, hey, we're peaking, stop charging. But from a utility perspective, regional, where you're controlling all the meters behind, your service territory, some of them were saying, hey, we're not peaking. We can still take some of the load. So, again, it's funny, but at the same time, the systems are there. Now it's about molding them in terms of correctly charging vehicles. Does anyone have any questions or stories about EVs or no? All right, so I'll give you a couple facts and statistics so that way you can walk away and say, okay, well, I know that, and I know that's going to be an issue because of that, and this guy told me. So Stanford actually released a study last year. They created a model in terms of EV adoption and how that was going to impact the grid. So there's 2 points to kind of take away from that, is that once we hit adoption rates of 30 to 40%, that we're going to require 25% more capacity. So it's not necessarily the 40, but even 25%. If you put that into perspective in terms of the utility, are they able to really deploy quickly, especially with lead times, pricing, everything? Are they going to be able to increase their capacity by 25%? The answer is, I'll give someone an easy one. The answer is, cut you off guard. The answer is no, right? So no, that's a huge undertaking. And then once we hit adoptions to 50%, without having communications, without doing anything, you're going to shift the peaks to nighttime. So again, just to put it in perspective in kind of a micro level, so the charger that we have out there is 7 kW. 7 kW is equal to how much tonnage of cooling would you say? 3. Yeah, 3. So 3 tons of cooling is about what the load that you're going to be adding to every resident. So again, just thinking of it as a linear, that's going to be really difficult to manage. Especially that now that you pay attention to the designs, so you do a service calculation, you ask for this many amps, you do this, this size transformer, and then what does the utility do when they send out a transformer? Oh, they cut it in half. Because now you have LEDs and everything's energy efficient, so you're not going to have ample capacity to be able to manage that load. The other one, just a quick analysis, Reuters did a study, this also was published last year, that 70% of transformers that we depend on, 70% of transmission lines are over 25 years, and 90% of transformers are over 40 years old. So, a question came up, why aren't transformers smart? It's like, well, that was 40 years ago. We didn't have communications. We didn't have all the metrics, gauges, pressure, oil, all that, in terms of being able to collect that metric or send that data somewhere to be able to keep up with the life of those transformers. I mean, that was a long time ago. And then I took a kind of quote from the Texas PUC, the Public Utility Commission, and they released a report. It was in 2020, but they did an analysis on the Texas grid and how it's going to handle EV chargers. How do you think that they did? I mean, I kind of have the answer up there, but in terms of level 2 residential, they said most of the utilities, CPS, Austin Energy, all the major ones, Encore, CenterPoint, they all said we can handle it, we're going to manage it, it's not going to be a big deal. But what they were afraid of was actually DC fast charging, and I'll explain kind of the difference between those, that we don't have sufficient capacity for something like, or infrastructure to be able to tie in, that many DC fast chargers in one location. The report, you kind of have to skip, I don't know, it's 100 pages, something like that. You kind of have to skip to about page 70. Guess what the first 70 pages are about? How are we going to pay for the roads if nobody's paying for gas? All right, so Department of Energy released the statistics, and this is what we're basing on, kind of our projections and everything on, is we're going to require to meet the demand of EVs as the adoption rates go up, and we'll go into a couple reasons of why the adoption rate is going to go up. We're going to need 75 million chargers to keep up with the demand. The point of that is, again, as we mentioned, that it's, if you kind of shift your perspective in terms of you're not going somewhere to charge your vehicle, you're charging your vehicle wherever you're at, then what that means is that electric vehicle chargers are going to be everywhere. Multifamily, especially, you don't have a garage, they're just going to be it's going to be a commodity. They're not expensive. It's small, but it's going to be like an amenity that anybody offers to get foot traffic in there. But they're just going to be, the way that we envision it. And if you kind of see the trends in China or in Europe, you just have them in parking lots. It's more than 5%, but probably closer to about 30 to 40% of the parking lots taken up by chargers. So, in terms of the adoption rate, what's going to happen is that EVs are going to be adopted more and more. I'm surprised that 1% follows the national trend, but a lot of guys, you guys are electrical. This is how we make our money. But federal and state kind of legislation is going to push that drive. So right now with the Inflation Reduction Act, you get $7,500 tax credit for buying a new EV. A lot of states are adopting legislation where, if not, you know, with the normal consumer, but 30% of vehicles have to be EV by 2030. If they're not passing that on to consumers, it could be like Texas. So we don't have a 30 by 30. We're not following that, but we are following in terms of trying to get up the percentage of the state vehicles. So any fleet that belongs to the state, getting that up to electrical as well. So, you know, those are kind of mandates that's going to kind of push that. And then you also have local incentives. You know, you mentioned AHJs that are starting to enforce having a certain percentage at certain parking lots. And then you have utilities, which, you know, rebates. I know, again, going to, I'll use these as examples, but CPS offers a rebate where they give you money to install your charger. And then after that, they give you a monthly rebate as well. It's not much, but it's refilling. It's one refueling of your vehicle, which is about $5, you know, a month. But you know what they're asking for is communication and on-site visibility to that charger, it being able to send you alerts and being able to give you an optimized schedule in terms of where you charge it. So there's some utilities that are starting to adopt that because they recognize everybody plugging in at the same time is going to be an issue. But if you manage that correctly, then we shouldn't see any issues. You know, as I said, business incentives, bringing in that traffic. And then again, just the technological advancement. If you've seen videos on how fast EVs go, you know, the room, the space, everything within a vehicle, it's just overall, you know, then autonomous driving will kick in. Overall, it's just a better technology. This graph, I know you guys can't see it, but if you kind of look at the solid blue dots, just wanted to show that to you. So the other kind of incentive, this is more for DC level 3 fast charging. This is what TxDOT, this is their five-year plan in terms of how they're going to install DC fast chargers based on adoption rate and where they're going to sprinkle them out throughout the state. So, you know, right now, if it looks like it's scattered, but really if you kind of follow one solid line, it kind of follows like a major highway. So that's, you know, if you've heard the term NEVI, that's the NEVI funding, all the Department of Transportation, that's distributed by state. But in TxDOT, you know, here in Texas, you know, we get a little bit more money than most of the other states. So we have $85 million to spend this year on DC fast chargers. You have anything to chime in, or do you have something?
The programs, National Electric Vehicle Infrastructure Program, like Gail mentioned, so federal government and the state money along major highway routes because of its size and road mile. Big chunk of that money that's coming into the federal government that's going to be deployed over the next 5 years. So you are going to see a lot more DC charging infrastructure. So you won't always have to charge at home. Drive at Houston if you want. San Antonio, it's hop along the way. Find a charger much more convenient going forward. And that's all going to happen over the next 5 years because that federal money has flowed to the states, and the states are now starting to deploy it here in 2023 for the next 5 years.
All right, so the next two slides are just to kind of show kind of a micro level. There is a difference between kind of commercial, industrial, and residential. Residential most likely is going to be 1 or 2, you know, electric vehicle chargers. Again, you're going to have some sort of load management or control, have visibility to it, because again, if utilities catch up, what's going to happen if they don't have ample capacity? What they're going to start doing is changing regulation, changing tariffs, and mandating certain things in order for them not to have to pay or upgrade their infrastructure. I mean, it's just, you know, just speaking to the utilities and being kind of on that side, that's what's going to happen. I mean, utilities never lose. If you guys have ever played with utilities, they never lose. So they'll find a way to kind of force that. So, but in order to be ready for that, you know, EV chargers is important to have that communication and have that control. And then, you know, some of the things that, and we'll get into the specifics, but now, you know, other load management tools. So if you've done a service calculation, if you look at, I think most homes, the average age home in the United States is about 40 years old as well. And you guys can fact check me, it's recorded. So, you know, are you going to be able to upgrade that service to have one or two chargers at that service, right? Most likely they won't have ample capacity where you can just pop in a breaker and charge and plug in the charger. So what you'll have to have is some sort of load management. So now, you can consider them non-coincidental peaks, right? So you get non-coincidental loads. Instead of turning on your range or your heat pump or your cooling, now you charge your vehicle at that time. So, being able to make that device a smart device is a huge benefit, and that'll help kind of with these upcoming issues, right, or anticipated issues. A load center, we're working on products in terms of making that smart as well, and then we have our own software as well to support that. From a commercial standpoint, it's a little bit different only because, solar panels, generator, large energy storage, those are all things that you can take advantage of to become kind of that source or to become, to play into the market as well. So is everybody familiar with HEB stores? Yeah, so it's really large. If not, it's coming here soon for sure. But, if you go down south, HEB is kind of the prominent grocery store. So if you ever get a chance, one of the things that they set up is they have a microgrid partnership with a company called Enchanted Rock. You guys are familiar with that? Have you heard of that? So Enchanted, that's actually a really good partnership. They win awards every year just because they're able to respond to emergencies. So basically, that's the way that I envision, kind of commercial space in terms of making that mutual kind of partnership and help solidify the grid. So basically what they did is they went in there, they went to every HEB and said, hey, you have a large enough load, you have enough space, I'm gonna install this natural gas generator, I'm gonna operate it. All I'm gonna do is, if ERCOT ever calls on emergency, as an emergency response system, if they ever call on it, then I get to turn on my generator, and HEB said, okay, well, I can island, if the power goes out, I have it. Well, it's a win-win for everybody. So HEB never loses power, and Enchanted Rock's able to sell back to ERCOT, so they're registered under ERCOT. So after the first kind of freeze, they made their whole capital investment up in that first freeze. So just to give you an example, I was just keeping up with rates. Typically wholesale rates about 2 cents a kilowatt hour. During that freeze, it went up to almost $600 a kilowatt hour. So, do the math in terms of how much energy you're producing, and, that's where you kind of make your base cases. But that's the way I envision, and the way that we're kind of thinking of things being able to communicate is just having that energy storage, and then, of course, industrial, commercial, have a lot more landscape to be able to install, larger solar installations as well to be able to offset energy and peak. So all right, so again, we have our smart breakers. We have our smart breakers that we offer. Again, this is load side management. This, you pop in BR, BAB. This makes any device smart. So I'll just quickly go over it. A big example for residential, I don't know if you guys work in the residential realm, but, in terms of making a real quick, easy one in terms of making your water heater smart, that's a huge advantage, right? Because you know your schedule. Everybody, if you start looking at load profiles, everybody has a schedule. Everything is cyclical. So you know when to turn on your water heater and when that hot water is going to be available. And I promise my wife agrees with that as well. Actually, no, she gets mad all the time. And we have our software in terms of being able to program. You can schedule it, turn it on, off, check data analytics. So it's another form of energy metering within that branch circuit. One of the things that we don't publicize, but another thing that we're trying to push for is, actually making that your back feed breaker if you do a load side connection for solar as well. So now you don't have that separate device or metering device that's measuring the solar. You actually just have it in the panel. All right, so just quickly in terms of infrastructure, because I know that was a title, so you guys get, at least you take some technical kind of knowledge from this presentation. But basically, again, this is the way that we kind of envision the way that, commercial, large industrial spaces or spaces that require a lot of chargers. Now, you're going to have a separate switchboard, most likely at 480, just to handle the DC fast chargers. And then you'll have, so it'll be a switchboard above your inline, and then downstream would then be what you would call your main distribution panel that actually feeds your loads. It's going to be the only way to kind of accommodate everything, installing solar panels, energy storage, and the meter. So what that means is now we sell larger bus, familiar with codes like 705.11 or 705.12 in terms of interconnecting and making everything work together and the power flows being in sync, then everything has to be sized appropriately. Our level 2, that's more of our 240-208 application, so, step down transformer. So the point of this slide is just that, just when you're factoring in kind of that load analysis, looking at how you're going to design this, it's going to be a lot more robust design than just having a panel and then your branch circuits off that main distribution panel.
Are not only deploying EV chargers, but like Miguel showed on here, we're also trying to figure out company has sustainability, or part of a university campus that's adding a lot of solar PV. So how do I add that into my power system? Like they're thinking about battery storage, so they could store solar that's generated in the day and use it later during the day. Peak load occurs later in the day. That's always not synced up. And they already have a generator and they have a utility. So how do those all work together? So having a switchboard structure that can connect all those at typically the 480 volt level, like Miguel showed there, and then there's a control layer platform that can coordinate all that as well too as to which of those distributed energy resource operates when and how to operate that. So there's a power distribution side and there's a control logic side as well too. And then you're just powering your DC or AC chargers off of that same infrastructure because they're another load now in the business.
Yeah, so, since we kind of got the cue to kind of wrap up, we have the spec sheets online in terms of our energy storage. We offer a 400 kW solution. We've kind of committed that because in terms of DC level fast charging, each of the chargers are 150 kW. Pairing those with energy storage makes you, not hit those peaks, especially as I was mentioning, you have the 4CP kind of peak seasons. We don't have, that's something that we're working on in terms of modeling and being able to offer a simulation in terms of what that looks like, in terms of what the load profile looks like, but that's all going to be, vary by location and adoption rates. So does anyone have any questions or?
I also add that, just like talking about this, both on the power and infrastructure side and the control side, in Houston, we have what we call one of our power system experience centers. We have 2 in the U.S. right now, one in Pittsburgh, where I'm located, and the other one is in Houston. So we have all our power distribution equipment, switchboards, and mini-mobile transformers there. And if you felt you've been there, or haven't, talk to the local team here that you tend to visit. But we're also implementing all our EV chargers as well as a microgrid demonstration with solar, battery storage, generator, and have it all work together with a microgrid control system. So be happy to arrange a visit for you there so you can see some in action. Because if your clients aren't asking for it today, they probably will be more and more in the future. We're starting to see, especially some of these microgrid projects, moving from what used to be military-based applications to now more the commercial and industrial space. As Miguel mentioned, we're implementing 2 microgrids at 2 of our own factories in Puerto Rico, manufacturing plants where we make circuit breakers. And we want to make sure those are reliable. They had some issues with the hurricanes down there, so we're putting that in from a resiliency standpoint to make sure those plants can keep running during the next hurricane, but also to offset CO2 emissions because Puerto Rico generates a lot of electricity from burning oil still. So Eaton has our own sustainability goals, but so do many other corporations and universities and hospitals. And so the whole, there's lots of push to reduce CO2 emissions. And adding solar is a good way to do that, and integrating it with a microgrid control system is a great way to do that. So, happy to arrange a visit for you at the Houston site to show you that. Any questions, comments from anybody in the group?
Question on the contacts, and then we can add either PLS system or battery if you want to restrict usage.
Yeah, so that one is our residential application, so you won't see it on that, but we do have our other commercial applications have RFID reader to scan, so give you access, and QR code. So if, same thing as you go downtown and you scan a parking spot and then you pay, it would be the same thing where you have access to that charger as well. All right, thank you guys. Yeah, let me get it. Man, we're gonna make it interesting. I don't even have time.
Yeah, it's not a lot of fun.
So I'll see you.
Get it so close y'all can hear me breathe. All right. I know everybody wants to get out of here as late as possible and hit all the traffic, so we'll go ahead and get started. This is for ethics credit for PEs. Is everybody here a PE? How about EITs? Do we have a few EITs? Awesome. Anybody dreaming of becoming an EIT? Okay. I don't blame them. We also, if anybody needs it, we also do programs for EITs becoming PEs and also non-EITs that are on that path. So that's available also. I'm Rick Strong. I'm the Director of Licensing and Registration for the Texas Board of Engineers and Professional Engineers and Land Surveyors. My card is full, my business card. That's me. I'm not wanting you to see me twice, but the key to it is if you need to get a hold of us, we have the PELS, the PELS website, and we also have the PELS email addresses. So if you have any of our old engineers at type addresses, those aren't any good anymore. For documentation, I'm assuming that this group is either going to send out certificates or a sign-up sheet or an email or something. Okay, and that's what you need to keep. Our office doesn't send out documentation. We don't even know who's here, but you're going to want credit for it, and if you do get audited, just keep your documentation. I want to go a little bit about a COVID update. Everybody's tired of hearing about COVID, but I want to tell you a little bit about how our office is opened up post-COVID. A little bit more about the board, some of our core functions, professional responsibility. I want to deep dive a little bit into it. You may see me skipping some of the scenarios and stuff that we do in our webinars, mainly because they don't translate as well to a group like this. But a lot of those scenarios you can go on your own. We're providing the PDF for this, and I'm assuming the PDF of this presentation will be distributed to everybody. So, and then a little bit more about the board activities. I'm not going to do death by PowerPoint and read every bit of this. I'll paraphrase the high points. And the main thing about the high point of this is our office is open to the public. We are open to the public from 9 to 2 on work days, and we post on our website if we're not going to be open. We have learned since April of 2020 how to work remote and telework and get all our jobs done and keep everything going as a normal process. In fact, applications over the last, both EIT, PE, and surveying applications are up 15% in the state of Texas. So not only are we handling our workload, but our workload is increasing. And the main thing about that is you can reach us. We did upgrade our phone system. So it's a more user-friendly type phone system with a set of menus. If you need to get in contact with us, that's great. Our emails, our licensing at PELS and our info at PELS, we monitor that continuously. So if you have any questions, you can still get a hold of us. We are, you can tell by my white beard and white hair, we're young and hip at the agency, and we want to stay young and hip, so we stay connected. The most important one up there is the pels.texas.gov. That's how you can find all our information. After the merger, we completely revamped the whole website to make it more user-friendly for both engineers and surveyors. We added more features. We're actually quite proud of it because there's a tremendous amount of information on there that people can easily access. And then we do have a Facebook and even a Twitter account, and we do, some of us monitor LinkedIn, and then the YouTube channel's there for the EITs and the non-EITs in the room. If you're going through the application process, The YouTube channels that are on our website are a step-by-step, a boring step-by-step instruction on how to fill out the forms, narrated by a guy from our office. He does a really good job, but it's not a video you want to watch on YouTube unless you really need it. But it's there for you. After the merger, the legislature in 2019 reorganized and merged our two agencies, and they rebuilt the board itself. We now have 5 licensed professional engineers, 1 registered professional land surveyor, 1 GLO. Who knows what the GLO is? It's the General Land Office. It's another agency, and they handle all the state lands. So the GLO puts a non-voting member, the GLO commissioner puts a non-voting member on our board also to sit and monitor because of the LSLS program. We have 3 public members. All our board members bring an extreme amount of history and expertise from all over the area of Texas to our board. You may recognize some of the names. I mainly put this up there just so you can see all the different regions that they represent. Through our merger and through our COVID issues, they were incredible leadership. Dr. Najad came in to the board about 12, 13 years ago and became chairman 3 years ago right as everything hit. So he's done a really good job navigating through everything. You may be asking why we only have 1 surveyor. If you look at the number of 72,000 professional engineers in the state of Texas and 2,800 professional surveyors, the representation is not balanced if you put more surveyors than engineers on the board. That being said, the legislation also created a surveying advisory committee that works for the board to pre-review all the rules, the policies, the procedures, and stay in touch with the surveying community. So that's the big B, the big board, and then there's the little board. That's the 36 people behind the scenes in a small office south of the river in Austin, and we do a tremendous amount of work. You can see my name there, license and registration. We also have Dr. Kinney that has been with the board 20 years. I'm the staff on the board as executive director. Also, if you've ever dealt with Janet Sobieski, she retired. She was head of operations. She was the one that that operations group keeps all our Echo interface going, our website interface going, our online applications, along with building management and everything else. And then, of course, there's me. I'm the good cop. Michael Sims, I call him the bad cop. He's compliance and enforcement. I try to work with you to get your application through and get registered, and he tries to take it away. So he hates that joke, and he doesn't put in his presentation. I offered it to him. So the mission statement. You've probably heard our mission statement several times. I like putting it up here because it's not just the mission statement of our agency, it's the mission statement, should be, of every professional engineer, every professional land surveyor, and that's to protect the public health, safety, and welfare. So the mission statement says, our mission is to protect the health, safety, and welfare of the people of Texas through the licensure and registration of qualified individuals, compliance with applicable laws and rules, and education about engineering and surveying. And that's why I'm here now. We reach about 24,000, 25,000 people a year with our education piece. Everything from PEs and surveyors and colleges, and we even go to the high school level, and we try to educate people not only on the importance of licensure, but also the importance of engineers and everything that engineers and surveyors do. Y'all know that. I'm preaching to the choir here. New London, this 85 years ago, the little school in New London was the start of our board. Everybody know the story. Anybody that's ever listened to our program knows the story. It's a little East Texas town between Tyler and Kilgore up there in that area. And in 1937, it was a booming community, oil boom. There were 10,000 people or more. Their families were moving in to work the oil fields. And so they built a state-of-the-art school for the community. Not maliciously, not an error made on purpose, but due to several errors, one in the tap of the natural gas and two with an electrical short, the school blew up. And you think about the impact that would have if 300 students and teachers died today in the United States. Think about the huge impact that would still have in our communities. It's massive. And the governor and the legislature got together and said there's got to be a way to regulate the design, and reached out. Other states, other nations were already in some kind of regulation for engineers and surveyors, and they created the board. Since that time, in fact, I licensed number 147801, I think it was last night when I was going through applications. So we're nearly at 148,000 consecutive license numbers since 1937. 71,000 of those are still active or inactive, most of them active. So it's still a relatively young agency, and a tremendous amount of people over a 40 or 50-year career are still in there doing engineering and design. The surveyors themselves, they established that the state lands surveying in 1919, and then in 1955 came up with a public surveying board. The two of those merged in 79, and then of course we merged with them in 2019. And for those of you that like numbers, there's been about 6,800 licensed surveyors since 1955, and 2,800 of them are still active today. The key to that is Texas is growing huge, and the demand for engineers is huge in the state of Texas, and still is. It's the same way on surveying side. Professional surveying, you think every lot that gets surveyed, every land transaction, the demand on it. So we don't make engineers and we don't make surveyors, but we do license them. So we get to see that growth, and we get to look at what barriers there are to licensure and what barriers there are to protection of the health, safety, and welfare of the public, and we're able to regulate that. And we see a trend where the attrition of surveyors match new surveyors coming in. And it's a viable career. It's a really, so if you know someone that maybe is not interested in the engineering path technically, but would be interested in a surveying path, send them to our website or us to talk to them, because there's the surveying in Texas is a growing field and is wide open for new people coming in. Licensing and registration, how does it protect the public? How does it provide a system to protect the public? The licensure process itself is set up to review through education, through experience, through references, to make sure that someone is competent. The licensing, the laws themselves set up continuing practice, continuing education, like y'all are doing now, to keep the competency standards up. It sets ethical and professional standards also in our laws and rules. So that's basically, how does it protect the public? Let's deep dive a little bit. First of all, it's kind of giving the loaded gun, so to speak, to any professional license, they impact one or two people at a time. But engineers could impact, you even drive the infrastructure coming up here, I did from Austin, And the engineers touched absolutely everything I drove by, every road, every bridge, every building, every piece of the infrastructure that was there, electrical. And you think that the public looks to engineers to be competent, ethical, honest, and if we let that down, then we can impact, like New London, we can impact hundreds or even thousands. The general public thinks very highly of licensure and highly of engineers in particular. They see licensing not as burdensome or frivolous, but they actually do see that it ensures safety, sets a level of expertise, holds people accountable, and is very valuable to society. So we are looked at very favorably. So favorably that some of the polls that have been taken over the years rank engineers, as far as honesty and ethics, up in the top 5 professions in the nation. That's up there with the medical doctors, the pharmacists, the dentists, and the nurses, people that actually hold their life in your hands. They see engineers the same way. So what is the building block to get us to the protection of the public health, safety, and welfare? We all start out with this education, experience, and exams, and I can pop it up there in about 2 seconds, and that's 10 years of your life. If you really think about that path, that's a whole 10 years of your life. And the bridge across that education, experience to exams that lead to licensing is that overarching ethics. I was doing a student talk the other day, and on the chat, one of the questions from the students, it was interesting. Virtual has changed everything. But you sit there and read the questions as they're coming up. One of the questions was, when should I kick my ethics in the path to being an engineer? It was a good question. I thought, who on their right mind would type that question? But it's a good question. When is there a point where you graduate, so you turn it on? You become a PE, and that's when you turn on your ethics. It is the all arching bridge across your education, your experience, and your exams. It's interesting, the compliance folks do all the investigations and stuff like that, unless it is an applicant. And then if there is some issue with an applicant, the licensing department, we do the investigation. And about 3 times a year, we'll get notified by NCES, which is the exam organization. Y'all have all had to take the exam, that, hey, here's someone, would you please investigate them? They did this in the exam. This appears to be an issue, and then we have to go into an investigation with them. So if you stop and think about it, they don't come to us because someone failed an exam. They come to us for a breach of ethics. Someone tried to cheat. Someone tried to give their brother's ID when they walked in the exam. They were interruptive of the process. So the ethics piece of it, we usually get to set up and investigate. It's interesting. All those pieces build up to professional licensure. And of course, y'all know the building block that connects that to the protection of public health, safety, and welfare is the professional practice and responsibility itself. And that's the ethics, professionalism, and competency, the things you practice every day. Competency, we'll keep checking time because I know that there's traffic building up out there, and you get your hour of credit. So I'm going to talk really fast, and I'm going to condense an hour and 15 minutes of talking into 45 minutes so that you get the same amount of information in your hour. So you get the credit. Had someone ask me one time, they said, you ended 5 minutes early, how do I get the full hour credit? I said, you go home and you pull up the laws and rules and you read them for 5 minutes. That way you're covered. So anyway, I get weird questions, I really do. I came from the mining industry. I graduated as a mining engineer from Texas A&M back when they had a program for miners. And then I went into the mining industry for 34 years, and I enjoyed it. My engineering and my PE license allowed me to go between mining operations and mine design and both be engineering manager and director and also over into the mine operations. And I thoroughly enjoyed it. And I got an opportunity 6 years ago to retire. And that lasted about 4 or 5 months. And I noticed online they had posted the job that I got. And I thought, well, that's an interesting way to give back to the engineering community that has done so well with me for 34 years. So that's how I ended up here. What was my point of that? I just rambled. Just an old coal miner that just gets off track and squirrel and goes somewhere else. So competency. I'm a mining engineer. If you came to me and said, I need a open pit design for a dragline high wall that's stable with 1.2 to 1.3 factor of safety, I'm there. I'm your person. Put me in. I can do it. I understand the geotech. I understand the civil engineering behind it. I understand all the background of it. And then you ask me, well, that's great, but can you also build a skyscraper for us in Houston? Don't live in that skyscraper. Come to my mine, go through the mines, you're going to be safe. You climb a skyscraper that I've worked outside my area of competency, that's what you want to avoid. And that's my responsibility. The law doesn't call out my name specifically in the statute and says you can only do this. I feel comfortable with environmental or with most parts of civil, road designs, mining design. I feel comfortable with that. Those are my area of discipline, and it's my responsibility to work within those areas of my discipline. Just like it's y'all's responsibility to stay in your area of competency. That's where a lot of ethical issues will come up too. Hey, can you come sign and seal this because I don't have an engineer right now and it's the old design and nothing's changed, and can you come do this? That's when the ethics kicks in. It's outside your area of competency. And then there's the ethics piece. It's being the dissenting opinion. It's very important. With today's groupthink and people all in a design and everybody doing design as a group and everybody parses out a project and goes and does different parts of it and brings it back in, it's being that, knowing your calculations, knowing your background, knowing your competency, knowing when there's an ethical issue and being willing to stand up and say, this isn't right and we need to do something about it. And it doesn't have to be aggressive. It can be professional, but it's being able to raise your hand and go, look, this isn't right. This isn't calculating correctly. I had a incident where we had a bunch of young engineers doing design for a mining method we were going to try. And we were sitting in the room and they were doing the presentation of it. And the presentation, they literally, in their presentation to the vice presidents and the executive vice president of our company, was, this doesn't work because the factor of safety that at the time we were regulated with was 1.18, I think it was. And one of the accountants spoke up and said, just round it up. Do the design and just round it up. That's a 1.2. Federal government's fine with that. And the young engineer, I was so proud of him because he stood up and said, I will not change my design. We have to find a better way to do it. And they went back and we gave them 2 more weeks, and they went back and they found out how to do it, and they figured out how to do it safe, and we went out there and implemented it. And that was that dissenting opinion, someone that had the ethics to stand up, no matter what it looked like career-wise, and stand up for what he believed and what his calculations showed. And then there's the professionalism, how he stood up to it, the honesty that he had when he was presenting his numbers, knowing that he was clear and being clear, and it affects us every day in contracts and change orders, and being able to put in there good professional language that represents ourselves and represents our clients. It's maintaining that public trust, thinking professionally, does the public expect from me? The Practice Act. Now let me look at time. Cool. So, yeah. Practice Act itself, when we merged, it looks different. Y'all were used to 1001. Most of you have it memorized. And then there's the rules that go with it, the associated rules that are the Chapter 130s. That's what it used to look like. The surveyors came in with 1071 as their statute and the 600s, Chapter 600s, as their rules to interpret them. So what happened with that? The 1001 is still there. There is still an Engineering Practice Act and there is still a Surveying Practice Act. That didn't dissolve, but they merged it. So the 1001 lays out the practice of engineering, but also the administration piece of licensing and the administration piece of the agency itself and how it will be conducted. And then 1071, although it's a lot smaller now and shares the administration with 1001, still lays out the profession of surveying. So no joke, you can go to our website, you can download the latest laws and rules, the documents there, you can bring it down as a PDF, you can also print it, it's yours. You can also go to the Texas Registry and pull it down if you want the same version, but we provide it on our website. So 1001 is there, 1071 is there, and we merged in the 600 chapters in with the 130s. So all that is still in there. The rules themselves help to interpret the laws, help to give more detail to the laws, and are set up. Actually, the rules, people say, oh, y'all sit there and write your rules to interpret the law the way you want. No, we write the rules. Staff actually writes the rules with attorneys, and then we send it to the governor's office, and the governor's office reviews it, literally reviews it, red lines it, comes back, it goes to the attorney general's office, they review it, then it goes for publishing, and it goes for public comment, and then there's a 30-day period where the public and all the professional societies and everybody else has an opportunity to go in and look at the rules and make comments. And then it comes back before the board a quarter or 6 months later and goes through an adoption period. So we don't do any of this out on our own. There's government procedures for every bit of it. So going through all the rule changes, we mostly just merged rules and brought them in. We cleaned up some of them that weren't supported by the statute or the new statute. And if you go, and this is kind of a roadmap. So if you want to go to the rules, if you need your extra 5 minutes after a while and you want to go in and study on surveying, how to become a surveyor, the rules are all there and that's a roadmap to it. You can see the mirror rule between engineering and surveying, and then enforcement itself is all Chapter 139, the bad cops. In 137 and 138, you will still find professional responsibility duties, including some signing and sealing, some direct supervision, care and diligence. Continuing education is still in there. For any of y'all that deal with Professional Services Procurement Act, it's in there. All that detail is still in there for you to find and get some guidance on. Signing and sealing. When I put something like this in a presentation or we do it in our main websites, we're not saying we've got a lot of cases on this or there's a lot of issues with it. We do get a lot of questions, however, people wanting some clarity around signing and sealing. So if you want to, you can go in the rules and read specifics about it, but very specifically, when you sign and seal something, you're taking responsibility for it. You're saying, I did it myself, or it's under my direct supervision. I am complete and accurate, and these are the reasons I did the plans, whether it be permitting or bidding or whatever, and you're putting your name and your seal on it. Very important. I wanted to do an overview real quick of just like maybe 2 scenarios, just to give you a flavor of real life type stuff. You'll see a lot of ethics woven in this also. A homeowner needs a signed and sealed floodplain certificate to close the sale of her home. So she fills out all the forms herself. She's not a PE, she's not an EIT. And she's got a neighbor and she goes to the neighbor, "You're a PE, can you sign this for me?" And he goes, "This is pretty low issue for me and low risk, I'll just sign and seal it." So what kind of rules is he breaking? What is this a violation of? And of course, the license holder shall only seal work done by themselves or performed under direct supervision. The issuance of oral or written assertions in the practice of engineering shall not be misleading or shall not in any manner whatsoever tend to create a misleading impression. An engineer shall engage in a professional business activities in an honest and ethical manner. And those are all the right answers. You cannot sign and seal someone else's work. We do have plan stamping cases that come across where people have assistants and they sit there and they never review the work. And it's against the law. And it's the same thing on the side of a surveyor. If a registered professional surveyor was and this really kind of hits home with all the home sales and all the big blow up of all the home sales that are going on and people moving and people coming into Texas. If the same house needed a survey and just said, "Hey, here's my old survey," and a surveyor just signs off on it, it's the same kind of ethical issues. It's the same kind of signing and sealing violations. And it's reflected not in 137, but also in 138. So that's a little more of a roadmap to going through the laws and rules. And one of the responsibilities we have, and we get a lot of questions about this, is the actual communication with the board. So of these choices up here, which ones are you must communicate with the board within 30 days? Is it changing email addresses and phone numbers, changing employer, disciplinary actions, civil lawsuits against you? And the answer by statute and rule is change of employment or disciplinary actions taken by another state. You must report to us within 30 days. The email addresses, if you want your e-newsletter and you want your renewal notices to come to your email, make sure you go in our system and have the right email. Make sure you do have the right home address on our system. It's our way of communicating with people. We found through COVID that there were a lot of emails because everything went out by mail. Now a lot of stuff goes out by email. We found a deficiency, so we're encouraging everybody, go in your ecosystem and make sure you got the right email. And if you're receiving our e-newsletters and our renewal notifications, then it's the correct email. So within 30 days, if you have a legal name change, mailing address change, employee status change, if you move from one firm to another, the firm needs to contact us and take us off the list, and you need to contact us and tell us where you're going. One thing you don't want is a disciplinary action from a complaint on a firm that you left 5 years ago that still shows you as a primary or secondary in the firm. And then criminal convictions. We actually have new, improved criminal history record guidelines that are going for comment into the governor's office next week. So still trying from 2014 when we all had to go get fingerprinted and go through all that. Still trying to refine with the AG's office and pressures on the governor, changes in legislation. We are redefining what the guidelines look like, fine-tuning them. But If you want to see the new guidelines, they will be, here in about 2 months, they'll be published on our website. Bottom line, if you get a felony or misdemeanor conviction, contact our C&E group and just let them know. In most cases, it's a non-issue. I'm going to skip through this one, but basically it's who is responsible for work. Is it when you sign and seal something that your EIT does and you find fault with what the EIT did, who bears the responsibility? Is it you or the EIT, or do you split the responsibility? You might want to take a guess, it's you, right? 100% you. You signed and sealed it, you're taking the responsibility. And it's the same way on the surveying side. If there's a surveyor that you depend on your drafter in your office, and your drafter missed a property corner or an edge by 20 feet, and you trust that drafter, so you're just signing and sealing what he did. And then, of course, the property owner files a complaint because they lost 20 foot of their property. Then who's the responsibility? It's the professional. Continuing education. You see the same thing over and over for engineers, but this is how it meshes with surveyors. Continuing education, 15 hours for PEs, 1 hour has to be ethics. Surprise, that's why I'm here. On the survey side, it's 12 hours and 3 hours of ethics. The 3 hours of ethics came from the old board and the old rules, and so we've just maintained it. People ask me, are they less ethical than us? No, but the rules are there, and it takes a while for things to change, and even if we do need to change. Self-study is still a good way to, if you lack some hours, to go get some hours. Make sure you document with your self-study what your sources are, the time you spent, what you learned, anything like that, just document it, and that counts. Up to 5 hours for PEs and 4 hours for RPLSs. Ethics hours cannot carry. If you have 2 ethics hours this year, you can't carry an hour to the next year. 14 of the 15 hours can be carried if you have extra hours, 30 hours or so. You can carry 14 into the next year. Only 1 year can you carry. You can't just keep that same bank and keep going with it. Stop and think about, what is the purpose of continuing education? It's to maintain your level of competency. It's to help you grow in areas that you want to grow in. So that's something to keep up with all year long. And seminars are nice. These conferences are great because they give you a good block of it. It's fantastic. But one thing COVID taught us was don't wait till the last month that you need before your renewal, because when these seminars get canceled and they don't have them turned over to virtual yet, then people lose hours. And continuing education was one thing that did not get excused by the legislature, the governor, or our board. So you still needed your continuing education to maintain your level of competency. There are no pre-approved courses. Please don't contact me or anybody on my team and say, hey, I'm going to take this course. Is it going to count? We're going to say, does it apply? Can you get a certificate? Is it something you need? But we're not going to pre-approve courses. The surveying board would actually have a list of pre-approved courses and course providers. That's gone. So engineers don't do that. And surveyors don't either now. And of course, keep in mind whatever you need for continuing education and plug that in. If you need management and leadership of engineering, plug that in. If you're deficient in some technical area, plug that in to keep your continuing education going. And then if you need an hour of ethics, always invite us to a conference so we can provide an hour of ethics. You'd think I get paid for this, but the jokes are free too. Continuing education, NCEES has a really neat tool that will help you track your continuing education. It allows you to document when you did it, what you did, attach certificates to it. It's free. If you go to NCES, it's one of the things they offer for free. You can register it. If you're licensed in multiple states, a lot of states offer, accept it as an audit. So if we audit you and you have an NCEES record, you can release it to us and we can look at it. So pretty easy. Now this in the application record, this is just a continuing education record. Really, really nice tool that they put together for this. Compliance and enforcement. The bad cops. I have time to talk about the bad cops. Engineers and surveyors are good actors. They're good people. As we saw by public profession, we get very few cases a year that are opened. We get some complaints, we get some, 600-700 complaints. We'll open cases if they have enough merit to them. We'll do the investigation. Some 60% of them get resolved with voluntary compliance. Look, you were in this gray area. This is the complaint. This is how it's substantiated. Here's the evidence. Okay, what do I got to do to fix it? Involuntary compliance. So if someone doesn't, well, let's cover this real quick. Filing a complaint, you're our eyes and ears out there. It's funny how free market and competitive nature people are, that it's pretty easy to file a complaint. But it has to be substantial. So if you need to file a complaint, you can email us, you can phone us. Yes, we still have faxes in our office. Usually Whataburger coupons come through on Thursdays, but they're still the faxes. I know, because I love Whataburger. Anyway, but you can still, you can go to the website and download the form and send the form in. Make sure you have good evidence. Make sure you've gone and at least looked at the rules and laws and said, hey, I think this is where this person has stepped out of bounds. If you want to be anonymous, anonymous is so hard to do nowadays. But if you want to be anonymous and you write on the back of a napkin, Rick Strong is the worst engineer in the world, and you go and you slip it through the door in the middle of the night, fine, but there's nothing for them to go on. He may be the worst engineer in the world, but there's nothing to go on. So if you want to file something anonymous and put it in our mailbox up on the porch or something like that, give us some details so we can start an investigation. Write it out in enough circumstances and evidence so that we can go and we can follow up on it. The board has a wide range of actions that it can do, reprimands all the way down to some pretty lofty fines. We can even do emergency suspensions. We can require ethical courses. It's interesting that the biggest majority of our cases are not technical, they are ethical professional. And the biggest majority of our complaints are ethical professional. So sometimes to alleviate a problem or to fix a problem, we require ethics courses, sometimes technical courses, and then we'll even assist the Attorney General's office for civil and criminal cases. It kind of has long tentacles. If you get a violation that or anything but informal reprimands, they go on the NESIS record for the whole nation. Any other state can see it also. It goes in our quarterly e-newsletter, and we have to put it on our website. So something like this doesn't get handled off here in secrecy. We're public, we have open records, and we put it out there. Y'all remember getting the paper newsletters? I got them for years and years and years. What was the first thing you turned to when you got it? Everybody's laughing, right? You went right to the middle to find your buddy from college, right? I did the same thing. Some things we can't do. There is limitations in our laws and rules that we cannot do. And when we merged with the surveyors, we did a lot of law and rule searching to see where our boundaries were. One of them was we don't settle the dispute of a property boundary. That's for civil cases. You file a complaint with us, we can do what's within our laws and our rules, but then actually settling a dispute on a property boundary is not within our laws. So it's good to know some of these things too that aren't given. Oh, I'm way ahead of that, but thank you. He's giving me time. Either that or he wants a high five, I don't know. So how do you prevent complaints? How do you prevent this? It goes back to the ethics and professionalism. It's having good, clear communication. It's having not a handshake agreement on a contract, but a good written contract. It's having good change orders. It's saving your calculations and designs, not only doing good, competent technical calculations, but also keeping the documentation in order to, if you ever have to defend it. And not only knowing our laws and rules, but also wherever you're doing a design for, know the laws and rules in that area also, and abide by those laws and rules. Policy advisory opinions. If you're reading through our laws and you're reading through the rules and you go, wait a minute, we've got this situation at work and it really doesn't match any of this, you can actually ask the board for a opinion on it. There's a form on our website, you can fill it out, you can send it in. Before you send in you might go look, there's some 60 plus interpretations that are already on there. They may fit what you're looking for. If not, please send in a policy advisory opinion questionnaire and it'll actually go to our board members. And the board members themselves will weigh in on, with their expertise, how the laws or rules should be interpreted. Recent board activities, the new rules, if you download them, have all the rules from the mergers. We've also just been through a cleanup of the rules to find any little things here and there. The licensed state land surveying ceiling rules were modified to match the statute. A lot of cleanup there. And then one of the things that the Sunset Review talked to us about, and then also the old surveying agency, is taking some of the barriers to licensure with a Texas-specific exam. Surveyors, if you don't know, they have to go through fundamentals exam, and then in Texas, they had to apply in Texas and go through a Texas 8-hour exam designed in Texas for Texas surveyors. That had no mobility whatsoever as a credential anywhere else in the United States. Nor did Texas recognize the mobility of the national PS exam and let anybody in on that either. The Sunset and the legislature asked us to fix that and get the mobility there. The mobility of coming in and going out, and accept the national exam along with a lot smaller Texas-specific surveying exam. That is developed and will be rolling out in October 2023. This April exam coming up, which we do from our agency, will be the old style exam, and the new one coming up in October 2023 has passed through all the laws are there, the conversion's been adopted, public comment, all that. So we're rolling it out. It'll be great for surveying, and it does not compromise, the way we've designed it, it will not compromise the integrity of the surveying community. It just moves one of those barriers where the mobility is there and the defendability of the test against the statute are there. That's it about the surveying exam. Webinars, I said at the first, we offer webinars or personal face-to-face if the groups are big enough for licensure or becoming an EIT, becoming a PE, becoming a surveyor, and then actual ethics webinars like this one. Just go online, go through Christabel. She's the one that administers all of it, and ask for one of us to show up, and we'll try our best to accommodate it. E-newsletters, if you're not getting the e-newsletter, then go in and check your email to make sure it's coming to you. And then just to let you know, kind of show the effect of COVID, in 2014, we did 155 presentations. 2018, we did 168, and then COVID hit in 2020 and it dropped down. And we do less face-to-face and less overall presentations, but we're reaching more people with virtual and still hitting that 24,000 mark of people that request, and we were able to provide it. We do the webinars. The quarterly webinars are still there. There's 4 of them stacked in. We do 1,000 people a piece, and those listen-only webinars. And then we also offer one a month that you can go and sign up for. So if you know someone that needed the credit, they need to go in and just sign up through our website. We covered the PDH. Now, ta-da. Hopefully I finished on time. I'm getting a thumbs up. That's good. Anybody have any questions? And I'll be here for just a little bit if anybody wants to come up afterwards. Yes, you got a question?
In your presentation, I was just wondering how you didn't show the other side of the spectrum, competition, lawyers, used cars.
Well, this slide would have probably, if we went through all the careers and licensure, we'd probably have to have 70, 80 slides before we got to lawyers. I don't know. I don't know where they fell. I'm proud of engineers. That's all I got to say. Cool. If you feel like you got slided on time or anything, go download the laws and rules and just sit there and read them. Thank y'all very much.
So again, just real quick, thank you to everybody for your time and attention today. All the slides, minus the ethics. Rick did say he's got access to those virtually, but all the other slides will be made available. Again, you're going to be getting a survey here planned next week or two. I would ask if you have 5 minutes. Any feedback you've got for us, good or bad, is only going to help us be better in the future and hopefully more dialed in for what you guys want to do. So again, drive safe, thank you, and hopefully, if you have questions about anything, I want you to control, we're here to hopefully help you.
And this is on YouTube, so if you want that address, let me know. I don't know. ThomasDimitrovich.com and you'll find it. All right?
Thank you.
Sure thing. I got the entire day, so you can revisit it all.
Thank you.
You know, you could play it on TV with the family, right? Put it up on TV.
Yeah, I mean, we had some folks that like maybe they want to do EV charging.
Yeah, what I'm
send them and say, hey,
what I plan on doing,
I think afternoon at this time, and they can just go do it.
Yeah, I might download it and chop it up as well.
You're gonna chop it?
I am,
Oh,
yeah,
okay.
and then I'll put them up in sections.
Oh, sweet.
Yep.
Thank you.
Sure thing, man.
Yeah, let me know when you can make it.
I will do that. I got your contact information.
Are you, when you're leaving to airport, I can give you a ride if you need a ride.
Well, yeah, you know what? I'll go whenever. I can leave now if you want to leave.
Yeah, I mean.
Let me just pack this up. All right. Okay, everybody out there on YouTube, thanks for joining in. Take care, stay safe, and please stay healthy.
Bye, guys.